Morning. Thanks for coming, everyone. I just want to do like a quick welcome session. I will not keep you here long before the sessions or anything like that. Unlike last year, I think we were here for like 40 minutes or something. Not last year. I keep doing this. I keep saying last year. It's been 3 years since we've been here in person, which is crazy. But it's fantastic to see such a brilliant turnout today. Loads and loads of people here today, so to see all the great sessions, so it's kind of makes it all worthwhile, all the pain and the horror. So I'll run through a few things, and yeah, I won't keep you too long. So quick introduction: the organising team that put this together is myself, Nikki, and Paul. Put in countless hours of our own time. And some work time when we should have been doing work, probably. This is recorded, isn't it? I mean, not work time to put this together. So it's been difficult, but it's great to see so many people here, and it kind of all makes it worthwhile. So we've got some awesome volunteers today, all wearing these great T-shirts where there's way too big a gap between 20 and 22. So. You have to point it out, embrace it. Yeah. So if you have any questions, if you don't know what room you're going to, if you don't know where the toilets are or anything like that, feel free to ask anyone in these T-shirts. The day doesn't run smoothly without these amazing volunteers. They'll be in each of the rooms to help the speakers, to help you get into the rooms and things like that. If you're interested in volunteering and you think that looks fun, then contact us on the email address above. And get in touch for next year, potentially. A couple of kind of housekeeping bits and pieces. Hopefully you can all see that map. It's not a battleship or some sort of sci-fi ship. It's the venue. Stole your joke. So just to kind of give you an idea of where things are, you all know where Auditorium A is, and hopefully everyone in B and C can hear me as well. But it's just give you a bit of guidance on where everything is. The main kind of foyer area is where the food will be served for lunch, and you'll get your tea and coffee there at the morning breaks and the afternoon break. And you can go up the stairs where we'll get to or there's lifts on the other side where you can get to the conference rooms, which are upstairs. There's also another couple of entrances for Auditorium B and C upstairs as well. So that's them all marked up. We've got room 2, room 3, 4 and 6 up there as well. Also want to just introduce you to our newcomer speakers, something that we take a lot of pride in and that we try our hardest to encourage is new speakers coming into the community, people who haven't spoke at any conferences before. We want to try and encourage them to speak at events and get involved in the community. That's how I started, that's how Paul started as well, and I'm still convincing Nikki to do the same. So they have got great sessions throughout the day, along with all other speakers as well, so please go along, see them, encourage them as well. The not so great slides, which I hopefully don't need to say too much about, but we're all part of the data community. We do more and get better by meeting new people, by engaging in events like this, by seeing brilliant sessions. And by registering today, you've all agreed to abide by the code of conduct. What that boils down to is just be nice to people. If you see anyone or if you have any problems, reach out to one of the volunteers, to myself, to any of the team, and we will deal with it. But the bottom line is be nice to each other. The contact details are also on the website where you can drop us an email or you can use the contact form and contact us anonymously as well. So going on to some more thank yous. This event wouldn't be possible. We wouldn't be able to put this on in this amazing venue if it wasn't for our sponsors and the companies that have supported us over the years, but most importantly this year. They make it possible, and we've got a couple of introduction pieces for them, for our exhibitors that are here today. They just want to say hello to everybody. So we've got someone from the Data Lab in Auditorium A. We get our first fall down. Maybe come back to them. Cheers, Paul. Anyone from Advancing Analytics?
Not you.
which is me. I've not prepared an introduction. Advancing analytics. So is this a conflict of interest?
Yeah, but
somehow?
I think you have to go with it now.
Yeah. Advancing analytics, we're a big data consultancy. Come and see us at the stand up at the back, next to Microsoft. We are experts in data lakehouse. This is really weird. So yeah, come see us, and we've got sessions throughout the day as well. We've got quite a lot of speakers here today. Octopus Deploy, I don't think they wanted to be put on the spot, but check them out. They're in the exhibition area as well, and pop over to their stand to say hello. Quorum? Hey, James. It's fine. Yeah. As long as you weren't calling someone a shit.
Okay, I didn't actually read that. Yeah, we're Quorum. We've got a stand right at the back, kind of towards the toilets, but that's okay. We're kind of, sorry, I thought I saw Terry here. I'm like, why did he not come up? We're a kind of data platform partner. We do an awful lot with Azure, 365, Power BI. If you're interested in becoming a data engineer, interested in coming to work for a really, what I think is quite an exciting, probably the most dynamic data consultancy in Scotland, come and talk to us. We've got a couple of sessions today. I'm doing one on Azure machine learning, which could be really dull and boring, so don't go to that. But the guys later on are doing a talk on what it's like to come and work as a data engineer. So if you're still here at 4:30, I think, come and see us. That's all I'll say. Thank you.
That was much better than mine, off the cuff. So I'll jump back to the data lab. Darren will do a quick introduction, quick hello.
So, good morning and welcome all. I'm Darren Gardner from the Data Lab, Scotland's Innovation Centre for Data Science and AI. So we're really just here to support the ecosystem around data and data science in Scotland, and obviously Craig and his team at Data Scotland are an important part of that, because we are not just about supporting businesses, but data professionals, data champions, everyone who's interested in the world of data and data science, and just encouraging, we are involved in training up MSc students to create that kind of new level of data professionals. We're supporting PhD students, we're supporting companies with data science and innovation, and really just trying to make sure that everybody in all sectors is aware of the power of data and the value of data, and obviously the importance of having data professionals in their organisation. So hopefully you all have a great day. We're on the stand all day supporting, so just come and talk to us if you want to.
Good, cheers. I don't believe so. Mic's okay, Alan? Oh, okay. Is it this one? Next we've got the data shed. Excellent.
Hi all, I'm Adam from the Data Shed. My colleagues are here with me. We've come all the way from Leeds, which is where our headquarters are. Over the next couple of months, we're going to be launching into the Scottish market with opening an office in Edinburgh. We're a data consultancy working with clients large and small across the length and breadth of the UK. We've got a talk at 10:30 about SSIS and SQL. We've also got a game that we've developed, including ducks and horses, which I won't spoil, but please come over to the booth and come and have a chat with us, have a go on the game, and there are some prizes to be won as well. Cheers, guys.
Cheers. We've got Microsoft. Ian, you're up.
Hi, I'm Ian from Microsoft. We've got a stand down the corner, so we've got the Skills Cloud Challenge at the moment. If you go and do that and enter it, you can go and win some Surface headphones. Also, a Go 3 as well is on there, so if you sign up to that, go through it, some good. We've also got lots of stickers. I know you like stickers, so go and grab some stickers. We also got a few other little bits on there. There's a couple of other cloud solution architects up there with myself. Happy to talk to you around anything Azure data related. Don't ask us about your Office license or your Xbox license. Can't really help you with that today, but we'll try and answer some of the other questions. And great to be here. Great to see you've done this, Craig, and the team, so well done. We'll speak to you soon.
I'm jumping about these slides, so I hope I haven't missed anyone. We've got SolarWinds. Excellent. Excellent.
Hey, good morning. I'm Douglas McDowell from SolarWinds. We're a leading green energy. Oh, kidding. Actually, I get those job requests all the time, a solar panel installer. But no, we do software. We make databases fast again after users break them, after developers do crazy things. Help you monitor, diagnose, and optimize your database, whether it be SQL Server, Azure SQL, or open source databases. We cover broad and wide and offer installed software as well as SaaS solutions. Come see us. Owen's going to talk about database migration later today, and we've got a few folks in the booth. We're in between the data lab and the data shed, I believe, but we're there in the corner. Come see us.
Cheers. And last but not least, just a note to say that our live stream and AV today is provided by Product Forge. So this room, our Auditorium B as well behind you, will be live streamed, a selection of the sessions to YouTube. So basically anyone that hasn't been able to make it today, Product Forge have been absolutely brilliant in setting up a live stream so that they can get a taste of what Data Scotland's like. And hopefully we'll have those sessions recorded that we can potentially make them available after the event as well. So big thank you for all the effort they've put in today and all the stress of getting all this equipment set up as well. So I've got a few other bits and pieces to jump through. Very quickly, we've got a web app for the schedule. So we didn't want to waste lots of paper by printing the schedule out or additional... Hello? Yeah, we didn't want to waste a lot of additional paper and banners by printing the schedule and then potential last minute changes and things like that. So check out the web app. It's on that QR code, or if you go to the URL, just a website, or you can create a shortcut on your phone. It's fantastic in my opinion. We didn't build it or pay for it. It's created by Sessionize, which help us with the session selection and submission by speakers. So check that out. Next, also something that I really want to say is feedback for us as event organisers and also for sessions as well. So speakers at sessions, feedback is so valuable. Not even just star ratings of 1 to 5, but comments, whether they're positive or negative. It's the only way we grow as an event. It's the only way that speakers can grow as well. So please submit session feedback. You've got no excuses because the QR code is on the back of everybody's badge. It will be displayed in each of the rooms as well. And as a further incentive, we've got a fantastic Lego kit and some other prizes as well, which we'll be giving away at 5:30 today. And I'm spoiling the next slide. 5:30 today for someone who's submitted feedback. So every entry, every session that you submit feedback for will be an entry into that prize draw, and we'll call the name out at the end of the day. And whoa, I've broken it. Just on the second last slide, almost made it to the end. It's a very temperamental.
It's a strong start to the day.
Yeah. You might try that one.
Do you need the slide?
Not really, no. So the last thing is, just wanted to highlight that the prize draws are at 5:30 in the main exhibition area, so where the food is and where all the exhibitors are. We'll kind of walk around and we'll do all the prizes. Most of the sponsors, I believe, are also doing their own prize draws. So, and I think a lot of them are Lego, seems to be a theme. Apparently I'm not allowed to put in for them either. It would probably cause a riot. But yeah, check that out. And then to end the brain melting day that everyone's going to have, we've got an after party for essentially an area booked within Doppio Malto in George Square. If you need any directions or any other help on how to get there, grab one of us. We'll probably end up going there en masse around about 6 o'clock, 6:30 time. So please join us. The speakers, sponsors and everyone will be there as well, so you can get a chance to speak with people and network a bit more as well. And the last slide was just to have a great day, and I hope everyone has a brilliant day and the sessions are great, and That was it really. You want to say anything, Paul?
Yeah, the only thing I wanted to say is that, just to re-emphasise what Craig said, that this event is free today for everybody here, and the sponsors pay for it. So it'd be awesome if you would visit the sponsors today when you're going round. Not just because of the prizes, although if you're not in the Lego, maybe it's not so much an incentive, but just to let the sponsors know that all of you are interested and care about them being here today and paying for this event. This event is not cheap to put on, so it'd be really awesome if you could just visit them, say hello, and let them know that you really appreciate them being here. That would be really great.
Well put, yeah. Nikki, you good?
Thank you so much for coming, is all I've got to really offer, and please leave us feedback so that we can improve for next year.
Great. Oh, on the dot. Okay, you've got 10 minutes to get to whatever session you want to go to. If you're staying here, then nice and easy. Have a great day, everyone.
had haggis for breakfast yesterday. It's like, just got to do it, right? Hi, Benny. So who works for Microsoft? Get out. Who works for Microsoft but doesn't want to admit it? No? No takers? Good. We're in a safe space then. Can I start yet, Zach?
Yeah.
Still got 1 minute. I need to build the suspense a little bit more.
20 seconds.
20 seconds. No, let's not go that much. That's far too much effort. Is it recorded? Do I need to be prompt for the recording or streaming?
No, I don't think it is.
Okay.
I think it's recorded.
Okay.
I don't think it's streaming.
Okay. I need to stay near these microphones though, right? Can I walk over here? Can you still hear me? I'll walk back over here.
Stay within the banners.
Stay within the what?
The banners.
Oh, within the banners. Okay.
That's the space.
Testing, testing. All right, I'll stop being silly. Let's start then, shall we? Hopefully you're in the right room. Here's what I found from my watch. We are here to talk about Synapse, or Synapse, the product that Microsoft have now given us to do analytics. And we're going to take a look at it. We're going to take an introduction to it. And I'm a simple person, so my simple agenda is very much going to be the what, the why, and the how. My name's Paul Andrew. Hopefully you've gathered that one. I'm a consultant by day for Avanade. I'm an MVP by night. And at some point I might sleep, but not while I've got 2 young children. So I've been working with the Azure Data Platform tools pretty much ever since they existed. And then before that, as a BI developer working with SQL Server 2000 onwards, I did write VB script in DTS packages a long time ago, which is why if I don't gel my hair, it looks very grey. So I've got those battle scars. The slides that I'm about to show you, if you like them, you can of course take pictures, but what I've done is I've just actually committed a PDF of these slides for you to my GitHub repository. So if you want to take a picture of anything, then this is the one to take a picture of. github.com/Mr. Paul Andrew, the same as my Twitter handle, the same as LinkedIn and most things, same as my blog. So go and grab a PDF if you like it. There's a subfolder in there for Data Scotland, so you're very welcome to that. I try and keep my slides quite visual, so hopefully you'll enjoy them. So the agenda, as I said, I'm a very simple creature, so we're going to do what, why, and how. And kicking off with what is Azure Synapse Analytics? Now this question kind of, it perplexed me for quite a long time. When Microsoft introduced the product, there was a lot of hype, there was a lot of confusion, and people were asking me, okay, well, you're a data platform consultant here, what is this new resource then, and why should I care about it? So I was thinking about this for a long time, and for the longest time, actually, my answer here was just null. I was like, well, I'm not really sure. They'd shown us some things, they'd released some things, they'd renamed some things, and the confusion, I think, was very real. But of course, we couldn't leave the answer there as null. We had to do better. So I thought about it, I walked around the house a bit, and I came up with another answer, and my second answer was, well, Synapse Analytics is lots of things. And I thought, yeah, okay, this answer is correct. It's not very detailed, but it's certainly correct. It is lots of things. So I kind of stamped that as version 1. Okay, I'll go with that. That is my answer. That's what I told people. And rather than just saying it depends, because that's what all consultants do. So I thought about it for a bit longer, and then I thought, okay, answer version 2. And I thought answer version 2 was, I'm going to say that Synapse Analytics is a complete suite of cloud-native processing services. So I thought about this answer, and I thought, yeah, okay, this is also correct. This is what we have here. This is what Microsoft has given us. So I thought about that for a bit longer, and then I thought, okay, fine. If I drop the cloud native part from that, if I say that this product is a complete suite of data processing services, and given my sort of career history, I thought about that, and I thought, well, what other Microsoft product do we already know and love that is a complete suite of data processing services? Do we know this icon? This was my conclusion, SQL Server. SQL Server is a complete suite of data processing services. And I thought about that, and I thought, okay, is this fair? Is this a good comparison? I thought, we've moved from on-premises into the cloud, and Microsoft have given us these different products. And I thought, yeah, okay. So I thought, well, could we say that Synapse is to data processing in Azure what SQL Server is to data processing on-premises? What do we think? Do we like this comparison? Am I barking mad? Who's not sure yet? So I kind of went with this, and I thought, yeah, if we're going to describe SQL Server, this is how I'm going to describe it. Because hopefully, as we know, within our SQL Server suite, we have a whole bunch of services in here. The database engine, integration services, analysis services, reporting services, the agent, the master data management, data quality, SQL Server Management Studio. So all of this gets bundled up into the SQL Server product as a suite of services that give us that ability to do whatever we need to do with that data. So I thought about that, and I thought, yeah, fine, okay, we can go with that. And I thought, well, if we stick with that then, what does Synapse Analytics give us if I was to dissect it in the same way? And this really is how I think we need to introduce it, how we need to think about it. Certainly if I'm going to say to you, what is Synapse Analytics? This is how I want to introduce it for you. And we can answer it in multiple ways, as I have done already. So if we dissect Synapse in that same way, and we start picking apart, okay, well, what actually goes into this thing? We can start by saying we have pipelines. Pipelines that allow us to ingest and integrate to do things with that data. We have this compute that sits behind those pipelines called the integration runtimes. It can be based in Azure. It can be based in our own private networks on premises if we want to allow us to ingest data from local to the cloud. We can run sys packages if we like via Synapse using the integration runtime for it within the pipeline's capability. We can develop data flows. This low-code, sort of no-code experience that Microsoft now give us if we want to create something using a graphical interface like a sys package, and then that data flow gets converted into what Microsoft call a data flow script. They provide it, they compile it, and as a jar file, they give it to Spark to execute. So we've got that capability in there as well with these data flows. We have a massively parallel data warehouse in here. What was our SQL data warehouse as a standalone offering? If you want to go back even further, what was the on-premises analytics appliance? That was a massive sort of £1 million investment rack that you had to go and deploy and work with. I engaged with a few NHS customers and had some fun with that. Fairly scary, but now, we have this cloud version of it with storage nodes and compute, and it's all sort of baked in there as well. We have a SQL database-like offering baked in here. We don't have any storage. It comes in this serverless form. Serverless not to mean that there are no servers, but to mean that there are servers that we have to manage less. So we have that. We have a new implementation of Spark baked in here. Depending on how Microsoft are doing with the releases of Spark from the open source community and how quickly they manage to roll that into Synapse, we have Spark compute pools in here as well. We've now got Data Explorer bolted on. Data Explorer is Microsoft's supposedly big data offering for exploring data. So that gets included within the Synapse suite as well. We have our Power BI workspace integrated. Not very well, but it's integrated, it's in there. We can create things from our Power BI workspace using our Synapse artifacts. We have our data lake storage integrated and included. It's there at deployment time when we deploy Synapse. It's mounted, ready to go for us. It's used for some of the Synapse system files. So we get that. We get a whole bunch of new tooling. You'll notice now that everything is a studio. Of course, we started with Visual Studio. Fine, that's the original. We now have Synapse Analytics Studio. You deploy a Synapse Analytics workspace, which is kind of the instance of it, if you like. You use Synapse Studio as the developer canvas to interact with it. So we have that. We have a .NET SDK. We have a notebook experience and script files that we can create through the studio to interact with all of the product offerings that we've got encompassed within this workspace. We can, if we like, conveniently ingest our data from some of Microsoft's sort of pre-approved resources if we consider that OLTP setup versus our OLAP, online versus the analytical processing. Microsoft now call this the HTAP, hybrid transactional analytical processing, which they offer through Synapse Link, supported now Cosmos and SQL Server 22. I think they've just put Dataverse into preview as well. So we have that capability. And we now have integration with Purview. So we can perform that governance over all of this stuff if we want to. So there's a lot that goes into that, right? That's this complete suite of data processing services, which I think is basically the best and only way that we can really describe this. So somebody says to me, okay, well, that's a lot of technology, that's a lot to get through. They say, well, what can it do? And I say, well, surely you know what it can do based on all of this technology, but I tried to simplify a little bit. I tried to answer this in a different way. And I thought, okay, well, we have compute, we have storage, we have some ingestion, we have some integration, we have some tooling, some orchestration, some things that are embedded. So if we wanted to think about Synapse, then maybe this is just another way we could describe it. Somebody says to me, what is Synapse? And I say, well, how would you like to look at it? What lens would you like to apply to this? So here's another option. Another way, of course, we could describe it is in terms of the established data platform resources that maybe we already know. Now, because I've been working with Azure for a long time, I'm familiar with most of these, so for me it makes sense. But then when it becomes integrated into Synapse, then what does it really look like? So for those pipelines, deliberately using some older icons on the left here, we could say, well, we took Azure Data Factory, and Microsoft took another fork of that code and included it as part of Synapse. For our SQL Data Warehouse, they just renamed it and said, okay, that's bundled in there. I'm being a little cynical, of course, here, which is why I asked if anyone works for Microsoft. We have our SQL database engine, the 2014 version, as it feels like at the moment. It's a bit of a hybrid, but that's what it feels like to me. We have that data lake storage already mounted in there. We have Power BI, as I've said, that workspace just becomes abstracted and included. We have the Spark implementation. We've had Spark implementations already in HD Insight and Databricks, of course. We now have another version of it. And we have Data Explorer now bolted on. Now, the amusing thing for me was that when I looked at this and I went through this list and I thought, well, how am I going to introduce it to you? In 2019, when I was sat at the PASS Summit, when Rohan Kumar introduced this as part of the PASS Summit keynote for the first time, I tweeted pretty much the same thing based on what he showed us. And what's quite nice is that my first impressions of what I saw on screen is basically what we now have. There's obviously been a few changes and things have changed over time, but this is what we have. So if that's what we're dealing with, then the next thing really that we need to think about is why. Why should we use this stuff? Why do we care? Why do we want this stuff? And in moments like this, I turn to Microsoft Marketing, mainly for giggles, but I turn to Microsoft Marketing and say, okay, well, why do we want this? Now, every time I do a talk, I will take a screenshot of the Microsoft website and make fun of what they tell us about why we should use their products. And pretty much the day after, they will change their website, so they'll take down what I have now criticized. But I've taken a screenshot of this one because it's good. So we see up here that Microsoft tells us that this is limitless. Yes, I want things to be limitless. Do we like the film Limitless? That's what I think about when I see something that's limitless. Give me those drugs, I want to do that. Synapse is limitless, yes, okay. It's limitless at scale as well. We can scale our limitlessness. Okay, thanks Microsoft. What's really good about this one, I think before they took it down, was this video. This video that said to us about what Synapse was and why and all the good stuff. And in this video, if you play it, if you find it, if you go through it, Microsoft tell us that what we've been doing so far is stitching together a multitude of services. Okay, I can go with that. They then also tell us in this video, their words, that this has resulted in brittle, high-maintenance architectures. It's like, oh, thanks, Microsoft. Well, if I've been stitching together brittle, high-maintenance architectures, I've been doing it with your products. It was a bit like, So, that kind of sort of sat raw with me for a little bit, which is why I felt the need to call it out here. And yeah, I think they have since taken down this video. The URL is sort of in the subheading if you want to grab it from the PDFs. So I thought about that and I thought, okay, I'll take that one on the chin for now. And I thought, well, what else do we have? And one thing that I did like, and one thing that I could certainly get behind here, without being too cynical, is that they say that it brings together data integration, enterprise data warehousing, and big data analytics. Now that I like, bringing all of that stuff together, yeah, great. And they say they bring it together in this unified experience. Now, being somebody that's come from a world of SQL Server, that SQL Server, suite of data processing resources, I think, yeah, in Azure, it'll be really nice to have something that unified all of that stuff. So I can definitely get on board if this is what Microsoft's vision is for Synapse. But of course, a vision doesn't always match the implementation or the reality of what we have, which is the problem, which is where, as a consultant, my customers ask me to help them out, because reality and vision are never the same. So we've got a bit of an inkling as to why there, if this is what we're going to do, if we want to unify our data analytics platforms and use a tool that can deliver it in this very sort of integrated way. Fine. So let's think about that and let's consider Synapse in terms of a logical architecture. I'm not going to call this a reference architecture because we are going to talk about technology in here, but a logical architecture that we might build. So here's my logical architecture. It could be very subjective, we could sort of tweak it, we could move a few things around, but I've drawn this quite deliberately to help make my point. So I have those vertical swim lanes, if you like, of data sources, ingestion, processing, serving, consumption. So this is how we might create something for the purposes of taking our data from its source to gaining some insight from it. So this is what we could do. And the services or the data products that I've chosen for my logical architecture start with Data Factory. Data Factory has been around before Synapse, so I might use that to do that data ingestion. I have my data lake for the storage, and I have probably Databricks to perform that compute and do that transformation work over that data. Sure. I might include some more Data Factory pipelines to support that orchestration of these processes as I move that data through the bronze, silver, gold layers in order to enrich it and gain that insight. Could do. I might use Azure Data Explorer to handle that sort of hot path, that more real-time data that's coming through, that telemetry. I could also use Stream Analytics and things in there. I've got the Event Hub icon on there as that endpoint to bring that data in. I could do this. I could serve that data with a SQL endpoint in a SQL database. And I could use a semantic layer, something like analysis services, to model it, to make sure it's in a really nice sort of presentable form for my users for when they do that self-service. So this could be my logical architecture, and pretty much this was my logical architecture prior to Synapse coming along. So this is what we might have done or would have done or have done. So let's flip this now and let's think about this in terms of what Synapse now offers and what we can actually include. So I will very subtly change the slide. I'll change it back. Those yellow words, they go away, and we now potentially deliver the same thing using Synapse. But of course, my other one, this was my brittle architecture. I stitched this together and it was brittle and it was high maintenance and it was rubbish, according to Microsoft. Now with Synapse, it's not. Now with Synapse, it's okay, it's good. So I've included obviously a few more bits and pieces on here, a few more icons. We still have a very similar set of ingestion patterns. We're still using pipelines and integration runtimes. We have that HTAP capability though, for those data sources that support it. If we wanted to use Synapse Link to handle that data ingestion for us, sure, we could. We've got our compute box sort of now expanded to consider the new Spark implementation, to consider that parallel data warehousing processing that we have in the form of those dedicated SQL pools, sure. On the serving side, we could do this now with this SQL serverless capability or from the dedicated pools if we want to give Microsoft all of our money to do that. We could. So really then, this is what happens is we deliver a logical architecture like this and we create this Synapse boundary around it because we have this unified platform, this unified product and capability to do all of these things. All of this tooling exists within that sort of red dotted box that I've got on the screen. Now if we wanted to, we could draw it like that, but my customer had said that that wasn't a very good architecture diagram. It's like, okay, so we'll draw it like that. So we could do that. So that's very much the why. Let's create an architecture like this, and why Synapse is obviously useful to deliver most of what's on there. Let's just now, what's the problem? Synapse is the answer, as Microsoft Cloud Solution Architects will tell you. But okay, I'm not going to be too critical. Let's move on. Let's think about, okay, well, how are we going to go and do this? How are we going to deliver this thing? Now, how becomes a problem because we have this breadth of resources, that massive breadth of all those things that I talked about, and that ultimate depth that we want to go into. Now, I've only got 50 minutes to deliver this talk, so we can't really go too much on the depth, but we can at least try and explore most of the breadth of what we want to do. So if we consider that in the context of Synapse, and so far, with all of the things that I've talked to you about, we've talked to you about it very much from a technology point of view, a capability point of view. Now, as technical people, we understand what that technology can do. We understand how we might want to apply it and where it becomes applicable. It's this age-old saying of there is more than one way to skin a cat. No cats were harmed in my presentation, but this is true. So we think, well, if we want to do something with our data from all of this technology and all of this capability we now have in Synapse, what do we actually use to do it? And this is really now the challenge of an architect. It's not just deciding, well, what tool should we use, but what is the right tool? And what happens a lot with my customers is that they get distracted by the new and shiny thing that Microsoft is talking about, which was Synapse. And it's like, okay, I've got some data, let's use this new and shiny thing. I say, no, whoa, hang on a minute. Don't tell me what you want to do. Tell me what you need. Tell me what you're trying to do here. And this hopefully will sort of influence what our technology choices should be. So fitting the tool to the problem. Not starting with the solution that is Synapse and then let's reverse engineer whatever we need to do for whatever our problem might be. But in this sort of breadth and depth of, well, how are we going to implement this? I've talked about technology, but I don't want to sort of think about it in that way, and Microsoft don't want us to either. So I've left the sort of Synapse Studio icon on there quite deliberately. So if we bring that sort of front and center, and we actually go into Synapse Studio, which we will anyway momentarily, but we go into Synapse Studio, this is what we see. So rather than thinking about it from a technology perspective, we can think about it from more of a use case perspective. What are we actually trying to do? We need some data, sure. We need to do some development, sure. We need to do some integration. We need to do some monitoring. We need to manage our platform, sure. So I think rather than getting bogged down with all of those technical capabilities that exist in there, let's try and think about it from a use case perspective. So if we go with these and we say, okay, well, what do we get? We've got these sort of headlines, and FYI, Microsoft call these hubs. Within Synapse Studio, you have the data hub, the develop hub. So this is sort of the naming we're now going with. So in the home hub, we can ingest, explore, analyze, and visualize. That's all we can do, nothing else. We do get a knowledge center, which I'll show you in a moment. So the home screen, just the sort of the landing, the starting point, if you like. If we consider data, and we hit the little plus icon within Synapse Studio, we can create SQL databases. We can create lake databases. We can create Data Explorer databases. So suddenly all of that technology gets resurfaced, but just within the context of the thing that we're trying to do. Fine. This makes a little more sense. We can do this. If we develop, we can develop scripts, we can develop notebooks, we can develop data flows. Okay? Again, all of that technology comes bubbling to the surface, but from this use case oriented perspective. Our integrate, the icon's kind of an obvious one here. Yes, we want to create some pipelines. We want to create some linked service connections. Sure. When we're monitoring, we want to monitor that compute. Monitor those requests that have been made to that compute. All the usual suspects and things that we expect to see. And if we manage our Synapse workspace, we can consider not just the compute that's in there, but the new access model that Microsoft gives us as well. All of those are the things that we might want to do. We might want to connect our Synapse Studio to Git or GitHub. Fine. So let's take a look at it, shall we? Let me duplicate here. Now, as we only had a sort of 50-minute session, I really was conflicted with what to show you and where to go with Synapse Studio. So much so that, there's so much in here that's like, well, what am I going to do as a meaningful demo for these people to try and give them a flavor as to what's possible in Synapse? And, I kind of drew the same sort of conclusions when I was defining it. It's like, well, I want to show them everything, but we'll go through, we'll see how we get on, we'll see how time allows, and when Zach kicks me out, basically. So in that home hub, as promised, let's zoom a little bit. Oh, mind you, you've got a massive screen to look at. So in the home screen, one thing I will just call out for you, which is quite nice, is this knowledge center. Because if you come into Synapse for the first time and you think, oh, what do I actually want to build here? We can go into the knowledge center and we can browse this gallery. Now, this gallery gives us templates, it gives us code snippets, it gives us all sorts of things that we might want to use to get started, which is really nice. So I can go to the notebooks and I can say, hey, yeah, getting started with .NET for Apache Spark. Did you know we can now write C# against Spark? Who likes this? I like this because I like C#, but I feel like I'm the only person that does. Of course, the Spark people don't. They prefer Python and Scala. But hey, in Synapse Studio, we can write C# against Spark. So we could do this. We could continue and Microsoft give us a whole bunch of code snippets that we can open that notebook, we can add it to our workspace. We've even got like GIF animations in here. I mean, what's not to like? So we could do this. We could use some SQL scripts to do a whole bunch of other stuff, ingesting Parquet files and copying. They've really sort of gone to town with helping us getting started here. We've got pipelines where we can sort of bring data in from SAP and stuff like that, and we can do some sort of Slowly changing dimensions. It feels like the SSIS wizard for creating a slowly changing dimension that maybe we just don't want to go there. But, you know, we've got a pipeline. We've got a very complicated mapping data flow that we could look at to do that if we like. If we're getting started, maybe, sure. So nice and helpful, but, you know, of course, we're proper developers, right? We don't need that. We can do the full code experience. So I think, okay, well, considering my logical architecture, I want some data. I want to bring that data in. Now, because I'm traditional, I'm going to use the AdventureWorks database. Because we like bike, retail, paraphernalia, don't we? Do we like AdventureWorks? Yeah? Just me? So what Microsoft provide for us in their GitHub repository, in a variety of subfolders in here, we can see the SQL Server samples. So I want to use the SQL Server samples, and I want to use the AdventureWorks sample database, the OLTP variety of it, and what Microsoft do is they make a whole bunch of sample data, as you can see, available in CSV form to use in this database, to use with it. There's also a SQL script somewhere down here as well if you want to deploy it, but I just want the data. So what I'm going to do is in Synapse Studio, I'm going to say, yes, data. That's what I want. I want to do data. So I'll come in here and I'll say, okay, this isn't data within my workspace. This data is somewhere else. So I'm going to create an integration data set. And that integration data set is going to be for my AdventureWorks database. Now, here's one I made earlier, of course, but it's going to come from GitHub. It's going to come from the GitHub API. So I can have a look at that. And as you might know, what you can do with GitHub is that anything that's there, you can go to the raw sort of URL for it, and you can get that as user content. And you can bring that back. So it's felt like an easy data source that we could bring in here. So I'm going to hit that GitHub raw URL with a HTTP link service connection. I'm going to provide a very long repository folder as a parameter where, we're going to go and get that. And then I'm going to parameterize that file name that exists within here. So that's going to be my integration data set. And then I'm going to use a pipeline. Or maybe, the other data set I want is going to be a generic data set, a binary data set that's going to allow me to land this data in my data lake. So I've got two data sets. I then want a pipeline to do this ingestion. I want to parameterize it. So I'm going to create a copy activity in my pipeline. The source of it, of course, is going to be my AdventureWorks data set. The sink is going to be a file in my data lake store that's integrated within my Synapse workspace. Now this one is going to be parameterized because I don't just want to bring down one file, I want to bring down a few. So I'm going to perform a get, and then I'm going to bootstrap that, and I'm going to use it multiple times to get the order headers, the order detail, and the product data sets. So I've got some green ticks, of course, because I tested this earlier. We don't want any demo failures today, thank you. So this is just me ingesting some raw data using Synapse. Nice and easy. And if you hit refresh more times, it makes it go faster, by the way. Top tip. 18 seconds, not bad. So I've ingested some data. I can now go back to my data hub, my linked data, so my data lake storage in this case. I can look in here. I can go to my raw folder, AdventureWorks, some files, all good, ingested a minute or so ago, so no cheating. Now I can right click, I can preview this. I can preview this data and I go, okay, what have we got in here? It doesn't look quite right. We've got quite a lot of nulls in here. Something's obviously not really working with the preview. So I've brought this down as a CSV file as it was in my source system. But if I actually download the file and we look at it, why does Windows 11 do this? Why not just give me all the options? I'm a big boy, I can deal with it. Don't sort of limit my options. Anyway, we can see that it's not really a CSV file, it's not comma separated, it's actually tab separated. Thanks Microsoft. It's okay, we can deal with that. But it's in my raw form, so that's fine. So in Synapse, we could do something here. It's like, okay, well, I want to develop something to address that. Now, in my case, I want to develop a notebook, possibly. Now, I'm going to develop a notebook. Do we want Python or do we want C#? Oh, boo. I want C#, and I'm in charge. I've got both. I've written both. I can switch between both, but not like in a morning. I need to sort of spend the morning doing Python, the afternoon doing C#. If I try and do both in the same morning, it just scrambles my head. I then start talking to the wife in gibberish because I forget how to speak English. So, all right, we'll go with Python. You guys can choose. So I've got some Python. It's not the most complicated Python in the world, but we're just taking in this data. We're taking it in a notebook. We can run this against my Spark compute that I've got within my Synapse workspace. So we could do that. My touchscreen doesn't want to scroll. Fine. So I'm passing in a definition for the data frame. I'm going to append some audit columns on here. I might do a little bit of tweaking and cleaning up of some things in the account number, possibly. And then we output a cleaned data frame. And maybe we write that back to my storage. Now, do we write it back to our storage in Delta format? Do we like Delta Lake? Our lake databases within Synapse at the moment don't support Delta Lake. They only support Parquet, which is a little frustrating. If we were thinking about this from a use case perspective, I think, fine, I want Delta Lake, but if we're going to do that, it means that we're probably going to be stuck with Delta Lake for the time being. Not that it's a bad thing, but if we then wanted to do something in our analytical model further down the line, if we had huge amounts of data that we wanted to handle in a relational way with our dedicated SQL pool, then maybe Parquet, maybe Delta isn't the way to go. Maybe we might want to do it in Parquet instead, because if we're considering external tables and the next layer of our solution, if that's not going to be Spark and that's going to be SQL instead, at the moment Synapse doesn't support that. You might call it a brittle architecture. So maybe we output that, maybe we output it to Parquet, maybe we output it to Delta as well. I'm obviously not going to run this because starting up the Spark session, it's not very demo friendly, but we have all of these things there if we need it. So let's pretend I've ran that and it worked perfectly, because all of my code works perfectly. I'm sure yours does as well. So I've output my raw data. I've now got it available as Parquet files, the product data set. I've also got it available as Delta files, not just the sales order one apparently. So, we could do both. We've got that flexibility. It's a case of, well, what do we want to do next? Do we want to model it? Do we want to do something analytical with it? Sure. Now, if I want to stick with Spark, then, by all means, I could. I want to take that AdventureWorks LTP data, I want to turn it into a fact sales data set with a dimensional product data set. Now, sure, I could stick in Spark and I could do that. I've done this one in C#, sorry. And I could create a table. I'm going to use SQL to do it. I might output that as well. I might output that in Delta format as well. We could do this. It's kind of very sort of use case orientated. There are many ways to skin the cat. What are your requirements? What does this depend on as to what we're going to use to do it? Alternatively, we might want to use our dedicated SQL pools that we have within Synapse Studio. If we do that, we might want to create some external tables. We might want to use Polybase to bring in our sales order details information. Because we have this now unified and integrated workspace, it means that these external tables exist and Polybase can authenticate and access the data lake storage that's already mounted here. So we could do that. We could bring in our sales order details, our sales order header, and then we could create using create table as select or ctas, which is generally the fastest way to recreate a fact table in your data warehouse if your data volumes are high enough to warrant that. We can now do merge statements as well if you want, but generally that sort of row by row upsert is not going to be as quick as just rebuilding the whole fact table. In most cases, it's very much and it depends. So we could, if we wanted to, create the same thing with our fact sales. We could do that, and if we consider our logical architecture, we're sort of moving towards more of sort of the silver, the gold layers here, and then we could go and serve it if we wanted to. Now, we could serve our fact sales directly from our dedicated SQL pools if you wanted to. It means paying Microsoft lots of money and dealing with things like query concurrency, and there might be some challenges with that. So again, it's kind of an it depends type scenario. We could, if we wanted to, serve it using the serverless capability that we now have. So in our Synapse workspace, we could, wherever I've put my SQL script, we could, if we wanted to just do an open row set against my fact sales, the Delta format this time, if we wanted to. We're sort of taking a fork here with where this data is going, but it's kind of up to you. This is where I was conflict on what am I actually going to show you. So I could query that Delta table. I could create a view for it that's going to exist within my serverless SQL pool. And I could use that to serve the fact sales and then model it downstream in my visualization tool. Fine, we could do this. What else could we do in here? Well, I wanted to try and create something that was a little more fun, because this is kind of, I think, fairly traditional, fairly normal stuff that hopefully we've probably been doing in Azure with some of these tools already. But what else could we do in here? Well, one compute pool that I've not looked at so far is the Data Explorer compute. So, a recent add-on from Microsoft, I've got a Data Explorer compute pool here. And what I've got in my Azure resource group is an event hub that is ingesting tweets as we speak. These tweets are being fired to this event hub via a very sort of simple C# application that I've just whipped up and I've actually left running in the background. This is monitoring the Microsoft hashtag on Twitter. Via the Twitter API, you can query it, you can bring down some tweets, you can do something with this data. So to try and make it a little more interesting here, I've got this running. So this is my sort of Twitter relay, if you like, from the Twitter API, sending it to an Azure Event Hub. So in my logical architecture, this could be my hot data path. So this is running in the background, and I'm sending some tweets. You can see my Event Hub is running here, and I've got some tweets coming in, which then means that for my Data Explorer compute, I can create a connection to that Event Hub. Scale. Help me out. Well, they've changed the links. Funny. So what we can do is we can go into the Data Explorer compute, and we can create now a connection between my Event Hub and the compute that we've got available. Now, when I say this is integrated into Synapse, I'm kind of using that term very loosely, because what happens is when we go in here, we look at the databases, we can create a database, but we very quickly end up in the Data Explorer panes rather than in Synapse. We're sort of leaving the Synapse Studio reservation a little bit here to do this. But I've got that database connection established between my Event Hub and my Data Explorer compute, which means if I wanted to, if this was now some hot path of telemetry, let's say that I wanted to do something in a real-world scenario where I want to analyze the social media interaction of my AdventureWorks products. AdventureWorks has its own hashtag, but there's not a lot of chatter on there compared to the Microsoft one. So I have that connection in place. Now maybe I want to develop a KQL query. So I might want to create a tweets table for that data. And there's a very nice wizard in the Data Explorer Studio of the normal variety that will allow you to do that. And we can create a mapping for that ingestion. We can query that tweets table, he says. Oh, that's okay, correct. Fail. We need to go to data. Silly me. We're dealing with data. We're not developing yet. We are developing a table, but we've got that table. We now want to query that table. So select top 1,000 in SQL. In KQL, you take 1,000. Another language where, we have brain mash trying to write different syntax, KQL versus SQL. So we've got some tweets coming in here. We see a UTC time. Feel free to join along and tweet the Microsoft hashtag, and we can include you in the recording. But so we have some tweets coming in. So we could do this. This could be our telemetry. So it's just kind of sort of showing you the art of the possible and really sort of quickly touching on what's available in the different areas of Synapse Studio if we choose to use these different approaches to handle and ingest our data. Now, the last thing I wanted to show you was considering a DevOps story in Synapse and think about deploying it, sort of to pivot from development and think about productionization. So I couldn't really do that quickly by showing you. So I just whipped up a couple of slides to sort of give you some information about how you could consider deploying Synapse and some of the sort of the pitfalls that we might have with it. So if we come back to this as my logical architecture, and what I've got there is everything framed that we've sort of looked at and built and considered with that hot data, that batch data, and sort of taking it through and serving it possibly. And that becomes dev. If we've got our Git connected workspace, we of course want test, we want pre-production, we want production as well. Now there's a problem. In this non-brittle solution, if that's what we're going to take forward, what we get within our GitHub repository for Synapse is a folder structure similar to this. A little bit like this. There'll probably be some other stuff in here as well. But we source control a lot of these things aligns to what we've developed and roughly aligned to what we build in Synapse Studio. So if we tidy that up a little bit, he says, tongue-in-cheek, the thing that I want us to sort of take away here and consider is that at the top, we have a whole bunch of managed artifacts, as I'm going to call them. Managed artifacts that we basically saw in GitHub, which is that top banner. Now, the problem we also have within Synapse is that we have a bunch of unmanaged artifacts as well. And this is where I'm kind of advising caution and want a few sort of takeaway lessons in here as well. That if we have a SQL script, as an example, up there somewhere, can't do that with my laser pointer. If we have some SQL scripts where we create a table, we create a view, we're actually then persisting something into that instance of that SQL database or that SQL instance. That's then no longer under source control. So if we sort of publish things, we then have to be careful with what we do, which means that the DevOps story for Synapse becomes quite difficult. Similarly, at the bottom level, we have that infrastructure. If we deploy our Synapse Studio with the artifacts that we have in GitHub, are we then going to get all of the Spark pools, the dedicated SQL pools, the Data Explorer pools that we might otherwise have in our test environment? There's more work that we're going to have to do here. So how do we do this in Synapse? Well, it's a bit of a difficult one. It's something that we need to sort of be careful with and consider. The ultimate analogy I have for this at the moment is a bit like a leaky bucket, which I don't think is too unfair at the moment, but I think there is a little bit of cynicism needed, and Microsoft do need to be held account a little bit for where Synapse is as a product, because it's been GA now for a long time. It was first announced back in 2019, so we've had a good amount of time for Microsoft to get things in order. I'm all for them delivering a minimum viable product, but at some point we need to finish it off. So a little bit of a tongue-in-cheek, but I don't want to necessarily detract from the positivity of that unified experience. But when it comes to DevOps, this is pretty much where we're at and what we do need to consider in Synapse. So it's just a little sort of lesson I wanted to bolt on of, well, how could we do DevOps in Synapse at the moment? Shameless promotion here. If you want to know more about Synapse and sort of, putting my money where my mouth is to some extent, so not just being critical of Synapse, but actually also writing about it for O'Reilly's. I'm authoring this book with my colleague Richard. I got fed up trying to remember where the ISBN was, so I just bought the domain Learning Synapse, and it redirects you to the O'Reilly platform. So go and check that out as well. So this is sort of me putting something down that will help you guys to deliver your Synapse solutions in the future. Considering the caveats, considering everything that's in there, coming at it from a very sort of use case orientated perspective, which I think is the best way to look at it. So with that, I will just say thank you very much for listening. That QR code will get you my contact details, similar to what's already on the slide. Do reach out to me. I'll be around for the rest of the day, so come and have a chat and things. We talk about lots more other than just Synapse. But yeah, so that's your lot. Thank you very much. Zach has just reminded me as well, quite rightly, that the QR code on your badges as well will also get you to the feedback form. So I'd really appreciate your feedback and let me know what you thought of that session. Thanks, mate.
Or 9:30 is not too bad for a first session. I had to speak at SQL Bits and I had spoke at 8 o'clock in the morning on Saturday. Not many people. It was pretty embarrassing. Anyway, it's all good. So yeah, I'm delighted that I could make it here to Scotland. It's my first time to Glasgow and had a lovely walk around the city. Last night kind of wandered around. It's a lovely town. Anyway, let's get stuck into it. Today's session is a kind of a end-to-end, plug in a few things solution, and you guys have to take part as much as possible. It's not compulsory, but I would really love for you to jump in and do what I'm looking for on the screen right now. So today, I'm going to do a thing where you're going to email to image@datalineo.com some photos. Selfies are much preferred. You and your friend sitting next to you. You don't have to take those photos, so anything that's already in your gallery, fire away. You can take a photo of the pen and notepad or your shoe, anything like that. So it can be people and it can be objects. And after you start doing that, it's going to go in, it's going to start processing. You'll get an email back using Power Automate. And while that's kind of churning through, I'm going to show you the whole plan, the moving parts, how it works. And then we're going to open up a Power BI report and analyze the results of all of those images. Okay? So, right now, whip out your phone or your laptop and start going through your gallery and picking out photos that you're happy to send. And I'll be very, very strict. None of these images will be socialized. They'll all be extremely deleted afterwards. I have a PowerShell script that rips them away from wherever they were. So be rest assured they're not going to be out there in the wild. And of course, so I've been doing this session for a while and I got so many pictures of Donald Trump, it was ridiculous. So none of that, okay? And obviously anything else worse than that, we don't want to send those. So just objects, stuff that you've taken photos of. I usually get selfies that people have taken from recent events. I get people taking photos of stuff on right where they are right now, and also pictures of animals and their pets. All those kind of things, I would be delighted for you to send them through. Okay, so I'm going to pause for like 30 seconds while you're whipping those things out. And while I have that, I have a real-time Power BI dashboard that is going to show you, as each of you send that email through, it's going to start popping up on this screen. So look, I've got 2 so far, and one of those was from me. So one person was quick, and that's great. And just to take part myself, I'm going to do this. I'm going to do it with you. Might as well, right? Take a photo. This sets the scene for the whole session, okay? The more we get, the better. This way, this. Okay. Now, okay, I am going to send that to image. The subject of the email doesn't matter at all, just put anything in there. And preferably, for those of you who are still doing it, it gives you the option to reduce the image size, take that option. 7 megabytes and so forth ones, they will get resized, but I have a limit of how many I'm allowed to do. It's up to 50, so I don't think we're going to hit that. Okay. Reduce. Send. And you can attach multiple images to your email. So attach 3, 4, whatever you like. If you've sent one and you've got other options, do it again. Send more through. The more, the merrier. Okay, look at these numbers shooting up. You can see that on your screen, can you? No, you can't. I think it's extended. Here we are. Okay, now there's my second screen. Boom. Okay, now can you see that? So this is moving in real time. So this is a Power BI streaming dashboard. So the Power Automate is picking up your emails from the inbox and it's saying, okay, an email's arrived, it's got an attachment, it's going to save those attachments somewhere and then it's going to perform some cognitive services stuff on it. But at the same time, it's writing to a Power BI streaming dashboard which moves in kind of pretty much extremely near real time. So we've got 20 emails, 34 images, 50 megs worth of data. Thank you so much. That's higher than the average. Sometimes I'm squeezing people to get 3 or 4, so this is perfecto. Thank you so much. Right, let's get into the session now. My mouse isn't working now because... Okay. Now that bit's started, I'm going to do the About Me as quick as possible because it's going to put you to sleep. We want this to be an interesting session. I am originally from Australia. I moved to Dublin about 20-something years ago. I've been there since. First guess as to why I'm still there. Usually people get it right first time. And yes, my wife is from Dublin, as a separate note. I'm a MVP since about 2018. Kind of Power BI, mostly what I do. I have my own company in Dublin. We've gone through a good bit of growth. We've gone from me to 6 in the last 12 months, so things are really going well. And I run events like this in Dublin called Data Cayley, what used to be SQL Saturday. We haven't done it in person, obviously, like everyone else, but next year, summertime, we would be hoping to put that on. So keep your eyes open for that. There's my Twitter handle is there. If anybody wants to get connected. All right, this is the one and only real slide that I'm going to show today because we're just going to do demo-y type of things for the rest of the session. So there's the process. Power Automate is monitoring the inbox of image at datalineo.com, okay? And then every time an email comes in, the trigger of that Power Automate will kick off and say, all right, now I have an email. What am I going to do with it? It says, first things first, let me see if there's attachments. Yes, there is, and there can be one to many, so it does a loop for every attachment. It stores it into Azure blob storage, and it writes to the Power BI streaming data set with a little bit of that metadata that came through, so who the email came from, a little bit about the size of the image. So Power Automate is great. It's kind of taking metadata. Not only do you get the attachment, you get the size of the attachment, the name of the file, and of course the binary contents of that file. It writes that metadata to a SQL database, or Azure SQL database. And then it says, right, that's one thing, but now for every attachment, it splits off and does two things in parallel. The first thing it does is the Microsoft Cognitive Services Face API. So it's going to scan every attachment for faces that it can see in that image. And then it does a loop for every face that it sees, and it takes metadata about that face. And we're going to have a bit of fun with that because it gives us some nice, interesting information about what it detects in that face. The happiness, the sadness, the age. Don't you worry, I'm going to be really blunt when we get to it. I'll tell you my age, and I've become very hard-skinned because I apparently am 3-4 years older as far as cognitive services is concerned. It writes that metadata to SQL, and you can see at the bottom of this box here, the one that has Face API. See the little icons down the bottom? There's other things that it's doing. It's doing parse JSON stuff. It's calling the HTTP endpoint. This Power Automate flow I wrote about, I think, probably pushing 3 or 4 years ago. And now it's starting to become a bit outdated because I used to call the API the HTTP action, but now there's actually a cognitive services built-in trigger that I just kind of pass my key and stuff. It's much more simple now. In parallel, it calls the vision, like object detection API. So it goes off and says, what objects can I see in that image? And obviously people, pets, animals. And I took an image just before this session with multiple things on it. We'll have a review of that. All of this happening in real time and in like the 20-something emails that we've got. There's probably more by now because it takes a couple of minutes for them to really kick in. Then you will have got a reply back. So some of you will have got an email back from image at Datalineo, and if you've attached one to whatever number of images, there'll be a table saying, okay, this image I saw looks like a shoe on someone's foot. I'm 75% sure. And then so on, okay? You probably would have got that back already. And then the email is deleted, gone, okay? And then down below, you can see the Power BI thing. There's two things. One is the streaming dashboard, a streaming data set. It's getting pumped with that basic metadata just to see as data is coming in. And then I'm going to open up, the more fun part of this session is let's analyze what those images told us in terms of facial recognition, facial attributes, and also object detection. Okay, so lots of moving parts. It's a very dangerous demo for me because there's so many pieces that are connected to each other. And if anybody is already following my Twitter account, about this time yesterday, the whole thing broke and died. It was my fault for only testing it yesterday after not having used it for about a year. And what had happened was the cognitive services endpoint that I have created in my Azure portal has kind of aged and has started to become actually problematic. It was giving me back incorrect data. And so I had to rip out a little bit of the code. It doesn't make a huge impact. What it does is I previously would take 5, 6 photos of myself and put it into a database and train it. And all the photos that I send, it would say, oh, I recognize that person, it's Ben. Okay? None of the images that you sent are going to say, oh, that's whatever your names are. So it doesn't really impact the session overall. All right, let's look at the results. Okay. Now, just before this session, I took 4 photos of myself doing ridiculous faces. And we're just going to analyze what the Face API gives us back in terms of facial expressions. It's always an interesting one because, you know, there's, I can never remember, I think it's 6 or 8 different facial expressions that it gives you a blend of. So happy, sad, angry, scared. Actually, we can have a look. So this one here is my kind of, let's say, neutral looking face. That's another one. If you can see at the top, can you read that okay? The top line of that little pop-up. You've got 1, 2, 3, 4, 5, 6, 7, 8 different things that it will spread 1% across, or sorry, 100% across, and my facial expression is going to be a mix of those 8 things. So in this one, I'm 95% neutral, I'm 1% happy, and 2% angry. That's, you know, whatever. Maybe I'm a bit angry about something, but only to the level of 2%. My son got his leaving cert results, and my wife texted me about 5 minutes before that. I should be a little bit happier. Actually, he did really well. I was quite happy. There's my 1% happy. And also, the box below, you can see the person is unknown. Normally, that would have said Ben, because I have loaded 5, 6, 7 images of myself, trained the model, and there was another identification thing. That one, unfortunately, is the thing that broke yesterday. Age, 48. I'm 47 and a half. So, okay. Now, it has always bumped my age up a little bit, and I've practiced all kinds of facial expressions. And you'll see from those 4 images, it varies by a couple of years. So whichever one is the youngest, that's what you're going to see me pulling that face for the rest of the day. Eye makeup and lip makeup, false. Few. Okay. Now, I also want to say, have a look at those 8 things across the top. Anger. So most of them are quite logical in terms of what you would express the look on somebody's face. He's angry. He looks disgusted. She looks happy. They look neutral face, okay? Sad, fearful, yep. Contempt. What the hell is contempt? Nobody has ever said, oh, geez, man, that person looks contempted. And then surprise. All of them make sense except for one. It took me a long time to pull the face and I learnt it, okay? So, there we are, that's the first one. There's my next one. Hang on, let me do the pop-up. I'm 63% sad and a bit of anger. This one, there's a bit of a surprise, I think. Yeah, 84% surprise. And here is the one that is 100% contempt. So just lock that face in. If you're telling the story about the great day you had and you won the lottery and the person's listening to you and they start, change the tune of the story a little because they are not really happy with what you're talking about. Yeah, it's just the side mouth thing. So that's the way the cognitive services model has been trained. It just looks for your big gob swinging over to the left or the right and says, well, hang on, this person is feeling a bit of contempt. Last one I'll show, and then I'm going to refresh this, and it's going to pop up a whole bunch more images, the ones that you guys sent. So I took this image here with multiple things on it. I was sitting at my desk. I have an Irish passport. I've been living there long enough that they gave me citizenship. Pair of sunnies, watch, keys, cup of coffee, and you can see on the right the objects detected. It's not great when there's a mixture of random things, and in fact I think I need to improve the output of this because I do think that there's more object detection data coming back in the JSON response. I'm just not parsing it well, so I'm going to review that a little bit to see if it did say watch, sunglasses and stuff like that. So I kind of think I need to review that. I had noticed that the last time. Also, image tags. So look, sitting, laying, indoor. Let's go over here and just, for completeness, man, looking. Now, these image tags are quite laughable sometimes. Old, there you go. Old, older. Laughable indeed. Contempt. Look, sandwich. I don't know in what world any human or otherwise would look at that and say, let's just write down sandwich. That's got something to do with that picture. I don't know. I really don't know how those object detection things are coming through. Right, let's up the ante. I'm going to do a refresh. So now it's going to go off to the SQL database. And it's going to pull in all the images that you guys sent. So now we have, let me deselect and look at the first one. Now, I do apologize. I probably won't be able to stop and go through every single one. And look, if you want to see what your image came back with, and we don't look at it today, let me know. I'm happy to kind of show you sometime during the day. But by the end of today, they're all gone. Okay? And that's my promise. Okay, so it came from AMB_1 at something. I'm kind of anonymizing the emails. I don't want you all spamming this poor person. But we have what I'm going to assume is, look, llama. Is it a llama? Anyone who sent that? Okay, yeah, it's a llama. Large, green, sitting. Faces spotted, none. Good. Faces recognized, none. And 17 image tags. Okay, perfect. So we have here a book or something. It says here a laptop. So whoever sent this one, Michelle Austin 27th, a laptop computer sitting on top of a table, which it's not. You would have got that sentence back in your inbox with some sort of percentage confidence about it. I find that it's overconfident. So Michelle, if you wouldn't mind, what's the percentage confidence that you got from that? What you would have got an email back from Datalineo Image with that sentence saying a laptop computer and then a percentage. What was the percentage?
The percentage, 46%.
46. Okay, I'm okay with that because I often see it would be like 80%, 90% when it's nowhere near. So, okay, 40% says maybe. I'm not so confident. Okay, Costa Coffee person, a hand holding a cup of coffee. Okay, great. Container. Do you know what? We really want to see people's faces. So let's just pop down and see who was brave. Okay, here's something. Okay, I love the outfit, for starters. Faces spotted, 1. Person standing on a sidewalk. Young, image tag. Yeah, whatever. Let's do some statistics here. So 100% happy. 35-year-old male. Yeah? Excellent. Yeah, sucks to be you. Nice. Yeah, mine is always older. I do find if you're quite clean face, you know, without so much speckle and whatever like me, it tends to make you look a lot more accurate. Okay, let's go and have a look. Enough of me. Oh, here's the one that I did while I was standing here. Faces spotted is only 1. Now, normally it's very good at spotting faces in the crowd. I think I was just a bit blurry when I took that photo, but normally even little faces way in the background it can pick up and photos like this that I've done before, would say faces spotted could be like 12, 15, and it would catch just little faces way in the distance. But I think you're all too busy looking down and sending images, and it said, I can't spot. So the blurriness and the looking down kind of meant it didn't quite catch you. Let me just see. 49, yeah, whatever. Okay. Here's someone on the motorbike. Faces spotted 1. Not bad. And it's a 97% neutral, 47-year-old male. That's a tough one because, you know, we're in a helmet there, but somehow it said this person is 47. Now, even I couldn't randomly guess what age that person is, so I don't know how it did it. We have a pet lover. Faces spotted none. 2 objects detected, a dog and a ball. I guess the tongue bit might have come up as a ball. And you can see here there's no data related to facial expressions and stuff like that. Brekkie. Okay. Let's just rip down. Okay, now we have another dog one. Looks like, is that the same dog again? Okay. Okay, Eva. Are you here, Eva? That's you? Okay, I could recognise you. Are you okay that we look at the attributes? All right, are you ready? 31?
57.
Okay, so Eva, you're 98% happy, a bit of neutral and a bit of sad. And it's quite interesting. Now, if I was to look at that, I wouldn't say 98% happy. There's certainly some happiness in there. But, you know, cognitive services does what it does. It's trained. And it's only one model. So somehow Microsoft are using images to train its model, and everything is judged the same way. Also, if we just pop open again, you'll see eye makeup, lip makeup. You see that is true. There is a lot more other information that comes back, where it gives me the rectangle box of your left eye, the right eye, the cheeks, the head, the face. There's tons and tons of information. So I'm only showing you some selective stuff that's a little bit interesting. But yeah, there is a huge amount of data that's coming back. Okay.
Can I ask about wearing glasses? Because it made that notation for her, for one of your photos as well, and I've had it do that on me when I'm not wearing glasses.
Yep.
Several times as well. In my case, I assumed it was the bags under my eyes or something.
Totally bags under your eyes, my friend. Yeah, so look, if we select one of these ones, you'll see it did say, oh, it's not on here actually, but it does come back saying glasses. You know, wearing glasses, yes, no, is another part of the response back. And yeah, it does kind of, you know, if you had a rough night, for sure, it comes back with some information that's not quite accurate. Okay, this one came from whamwenny.simonda. Okay, where are you? Okay. That's not you though, is it?
It's not my wife.
Okay. All right, so, oops, hang on, let me select. Okay, so 100% happy. Good for you. You're on the right track. And 29-year-old female.
No.
Lip makeup. Is she here?
She's not.
Okay, let's really talk about her a lot then. Is she going to be happy with that?
Yes.
Okay.
35.
Okay, perfect. So yeah, and look, the image tags: person, dining table, tableware, wine glass. Yeah, I mean, no wonder she's happy, man. Fed, watered, glass of wine. What a husband. Okay, here we have someone. No faces spotted in this one. JVK, where are you? Feeding a squirrel. Okay, this is where we want to be. Okay, let's have a look. 3 faces. 3 faces detected there. So one of those faces was not picked up, for starters. Another thing that comes back, which I don't plot on this, is the rectangular box of the faces. I used to do a session like this where I had a Raspberry Pi computer. Anyone knows what those are? A little handheld device, and I had a camera, and I used to go around and go like this. It was too temperamental though. And with that, the Python script that I was using to grab that, I was plotting the square on the image, and you could see here's person A, B, C. This is all in Power Automate. I don't have access to the Python part. I could do it, but I kind of stopped going too far with it. But you can see 3 faces spotted, and I don't know which one of those 3 faces wasn't spotted. But let's have a look. This came from Gordon. Where's Gordon? Okay, Gordon, we have 3 faces. You can kind of use a bit of process of elimination here by the bottom table. We have 2 males and a female, 27-year-old male, 30-year-old male, and 32-year-old female. Do you know the ages of these people broadly?
So I'm the 30-year-old male.
Uh-huh.
The other 2 are quite a bit out. They're both in their early 20s.
Okay. And you're wearing lip makeup, eye makeup as well.
Must be.
Let's see. Eye makeup.
Slip bags, telling you.
And look at your happiness rating is maxed out. So you're having a great time at Data Scotland. Good to hear. I hope that continues for the rest of the day. Let's rip through another pet, Murray. Two dogs. We don't have any objects detected, interestingly. Okay, so this one came back with no tags. I don't know, maybe the dogs are just in a position that it didn't quite pick up. OA Justice 96, are you here? Okay, faces spotted, none, and definitely the hat and sunnies caused that limitation. You know, I think, and also I do notice that the faces kind of tend to have to be forward-facing, sides, and definitely side profile. It's not really picking up those. So it really is designed for front-facing faces to be picked up. Okay, who's got the French bulldog? Now, this is a nice one. Okay, this is a bunch of stuff. A bit of apples, some other cup of coffee, and butter. And what's in the plastic bag? Michelle, where's Michelle again? What's in the plastic bag?
Bread.
Bread, okay. So here, look, it's nice. The tags are probably good, capturing a lot of those things. No faces spotted. Okay, good. Another thing that I've noticed when I'm taking a photo of people at a house and there's a photo in the background, it will spot the photo as well and pick up that face. So it does quite well at capturing those. Okay, now let's do some more people stuff. Stuart, where's Stuart? Okay, Stuart. Person, table, outdoor, looking, front, holding. Okay, yeah, broadly speaking, the tags can be quite hit and miss. But the purpose of those tags is just to quickly find images that may have some information relating to that. So if you've got 1,000 photos and you want to pick all the green ones, there is a tag generally called green or something if the photo is quite green in nature. Stuart, are you okay? We do your... All right, Stuart, 45. Close enough, good. 95% neutral, that's fine. A little bit of contempt in there for your saying something wasn't perfect that day, Stuart, but you know, for the most part, it's not too bad. Okay, JVK, we have 2 faces spotted. So, do you know that person behind you?
No, I don't.
Okay. Are you okay again? We do your... All right, so 34-year-old male and 54-year-old male. So close enough again. The person behind you, you know, let me just do quick. $54, okay, ballpark, I guess. You know, I'm not one to judge, but it's in and around the right age. headset. I just want to have a look at that Sennheiser, because I just bought a new headset the other day. I just wanted to see what brand it was. Indoor, so what you don't see here is anything headset related, but that doesn't look traditionally like a set of headphones, I suppose. The shape of it, it's folded up. So the tags have just been a little bit random. So Helen, where's Helen? Helen, a little baby photo. Are you okay? We just do the age thing on this one. I don't want to cross any lines here. 1. Yeah. Is it a female? Yeah. Okay. Yeah. So another thing, children photos always are a lot farther away from the truth with gender, for sure. I took photos of my son. He's 12. He just started in secondary school this week, and it has him wearing lip makeup, eye makeup. His age is like 2 years older, and sometimes when he's got his boyish smile, it comes up as a female, because children are very smooth-faced. So the cognitive services uses that to assume if you're not gruff like men can tend to get, then it kind of may swing the response back into being female. Okay, let's just wander down a couple more. Who's having a snooze there? Okay, Eva, where are you? Oh yeah, sorry, yeah. So let's have a look on this one. Oh yeah, so look, face is spotted with 0. So for some reason, it didn't even pick up your face. And that one there is quite unexpected. I would normally see that should definitely pick up a face in that image. So I don't know why it didn't. Maybe just even the face is twisted away a little bit or something. Maybe the helmet distorted the ability for it to pick up a face. But I have to say that's the worst case that I've seen it not pick up a face. I've seen it when there's like that previous 54-year-old in the back of JVK's email, it picked up his face and it was like a blur. But I guess it just picked up the eyes and so forth, and no tags. Who's having a snoozy here on the airplane? Here we are. Who is this?
It's a friend. He's not here.
Okay. So it didn't spot his face, and we're not going to make fun of him while he's not here because we don't have any facial expression information. Okay, we've got a pint of Guinness. No face is spotted. Laptop. Okay, and that's all of our images now. Let me just deselect this one. So 21, so objects detected was 80 overall, 825 images in the image tag. And I have this other visual, which is all of the images together in a kind of a carousel-y, whatever you call it, and we can select by tag. Okay, so over here, across all of the images collected, I can now select a tag and it will filter and show me all of the ones with dog. Okay, so here's dog, and you've got those ones. And you'll laugh at some of the photos because there's no way there's a dog in that photo. Okay, but I guess it just helps you narrow down the photos. If you're looking broadly across a large spectrum, it can. If you're sort of looking for, I want to look at outdoor images of dogs for some catalogue that you're doing. This tags is good. It just kind of reduces your 10,000 photos down to a couple of hundred to kind of give you some filtering capabilities. Okay. So let's look a little bit more at the actual Power Automate. Where are we? What's our timing? I just want to get my timing right. 15, perfect. So let's break it out and have a look at the actual Power Automate flow. Who's been hands-on at all with Power Automate flow or building Power Automates? Okay, and then who's never used them? Okay, and wow, okay. And all the people who've never used them, are you in the space of doing anything with databases, Power BI, blah, blah, blah? Anything Azure-y, Office-y, close enough to that kind of thing? Or you all have an Office account with your work. You know, we're at Data Scotland, Microsoft mostly. So I'm going to say one thing. I started using Power Automate for the first time, and I found it the most easy tool to start using with the very, very low friction to get started. And the low friction means that you'll actually find it useful very quickly. So I'm a Power BI guy. I came up from the SQL database world, the SQL Server world, building data warehouses and then doing business intelligence with lots of other tools, and kind of finally hoisted my flag against the Microsoft stuff many years ago. But now, as you know, the Microsoft platform, what used to be quite disparate and difficult to plug together, anybody who's set up an old SharePoint a SharePoint on-premise, and then a SQL Server database, and the relevant networking, firewalling, and then setting up movement of data from here to there, those things have just started to come so close together that now anybody can build a full solution like this. So this is all built in Office. This is only me mucking around building this, but it's easy now to do if you're a data person, or even if you're living your life in Excel. You can use Power Automate to just automate some of those repetitive tasks of moving stuff here and there. You know, moving files to a place where Power BI can pick it up. And that place can be a SharePoint online document library. So now someone emails your file every Friday and you need to manually do blah, blah. Now I have an inbox, I watch for the file and the file name, I put it into SharePoint, Power BI will do some stuff, and I'm hands off now. And that's a business capability, not an IT or data professional capability. It's a wonderful tool. I'm very salesy about it, but I do find that it plugs an enormous gap of what a lot of people are doing manually these days. The one thing that I will say about it is it's not good for churning data. You know, if you're getting a database with kind of 1,000 rows of something, I wouldn't use it to churn the 1,000 rows. Use something else for that, Power BI data flows or something else. But it's good for automating stuff to do. So let's have a look at the Power Automate kind of homepage. And it used to be called flow.microsoft.com, but now it's make.powerautomate.com. If you have an Office license with work, you can use this straight away. There are limitations of what you can do and what you can't do. If you need the license to connect to certain things, it's $15 a month per person. And getting that license depends on your company and how easy it is to get. Sometimes that could take months. Sometimes you go, can I have a license? Yep, I'll just right now, done. Okay, go. That's wherever you are in that spectrum, it depends on who you're working for. So make.powerautomate.com. The first thing, if you've never used this, is go straight for templates. And just kind of, the first one I always do is the notification one, which used to come up at the top. It says, send me a notification in 10 minutes. It used to be there. Yeah, there it is there. Look, send myself a reminder in 10 minutes, okay? This is the nice first step into creating a flow, because you don't have to think, it sets it up for you. You have to install the Flow app on your phone, but you don't write any code. You set up a couple of minor things, and you press run, and it'll do it. And it's no thinking, but it shows you the moving parts. And then you go and do a slightly more complicated one, and then a more complicated one. And always my recommendation is the first while that you're doing these flows, don't make them some sort of mission critical requirement, just play a little. And then you'll get past that point of feeling a bit more comfortable and go, okay, now I can really use this in my organization. So send myself a reminder in 10 minutes. There's a button to initiate the flow. So a flow works with two things. One is the trigger, okay? One is the trigger to say, what's starting this flow to run? Always the first step is something that's happening somewhere that will make the rest of these steps execute. Trigger. The next thing is just called actions. And the actions can be whatever. I mean, really, it's, there's an enormous, a plethora, if you will, of things you can do with the Power Automate flows. And I'm going to open up the flow that was on my slide deck, and we're going to actually open it up and look at all the steps. And you will see from my slide, it's quite simplified, and you'll see it expands. There's doing looping, there's parallel branches, lots of stuff happening for those emails that you sent in to get processed, data stored in SQL, streaming data set being populated, and so on. So this one here, create flow. Okay, and it's going to say that the button is the trigger, meaning no action's going to happen. I'm going to say, look, just go. And again, while you're developing your flow, the first flow that you create, it's good to have the button as the trigger, because it just means you don't have to do something and make it trigger. You just go, run. You know, that's a nice way to get it started. Okay, and it's done that. Edit. The user interface is it is very simple. It starts at the top and just goes downhill to the end. So it says manually trigger, meaning it's just going to sit and wait until I press the button, effectively. And I can press that button on my phone, or I can initiate it from here. It's going to wait, I'm going to say 1 minute, and then it's going to send a push notification to my mobile phone. Now, of course, I have to have installed the Flow app to make that happen. So I'm going to do save, and then test. Now, how do I test it? I can manually run it, or if it ran before, I can rerun that previous one again. And if it was processing files, it'll pick up those files again and do all the good stuff. So I'm going to do test, and it says, hey, do you want to do this? So you need to sign in, yada, yada, yada. Now run. Okay, done. And here, it shows you in real time the activity. So anyone who used to do SSIS packages in SQL, you could watch, you know, same experience. My little yellow dial is going to wait for a minute, and fingers crossed, I'll get a little notification on my phone when that kicks off. Okay, this will be the longest minute ever. All right, I should have said 30 seconds or something. While that's running, I'm going to open up another one, and we're going to look at the flow that we went through today. And you'll see it's called version 3 because I was hacking like hell yesterday trying to fix the broken one. Version 1 broke, version 2 destroyed itself, and version 3 is alive now. So let's have a look at my flows. Oh, where's my mouse? There. And there's one here, session, image analytics, analyze email 3. Alrighty, boom. And look, there it is. It's succeeded. One of them's still running. Okay, multiple parallel ones will run. And I guess this one is maybe churning a bigger file or something like that. I'm not quite sure what the issue is. So whoever sent that may yet get that email back if it doesn't ultimately fail. But yeah, all of you sent your images in at the same time, within a kind of 5-minute spell. And it wasn't one flow that would run and wait for the next one. They're all running in parallel. So that's okay. You can have a lot of activity running at the same time. But let's go in and look at the process. And I'll just quickly, let's remind ourselves of the slide. So the Power Automate is triggered with the email coming in. That's our trigger. Here, look, I even wrote trigger. Look at that go. And then actions. This is the stuff that it's going to do. So gets the attachments, stores it in blob, streaming data set, writes some SQL, do the face API stuff, computer vision stuff, and then your email comes back, and then I delete the email. Okay, right. Let's see what that looks like really in the Power Automate. So here's the trigger. When an email arrives to image@datalineo.com, and you can expand to look at the details of this step. It says which folder, so you can nominate which folder. I'm just obviously choosing my inbox. I can look at the advanced options, and you always need to ensure you say include attachments yes. And I have a feeling that's no by default, because Power Automate is trying to minimize the data, the metadata that's having to deal with, but I actually need those images, so I had to change that to yes. Again, this is a couple of years old, so that default might be on yes by now. I set a whole bunch of variables. There are better ways for me to do this, but back then it was the quickest, cheapest option, and I'm creating all these variables which get populated via the cognitive services response. I grab the object detection description that gives back, and I put it into this variable. I set up a GUID for the image that gets written to the database, so I have a unique key. My database skills coming in, we want our primary key on our data. The email from you, so that I can email you back. A whole bunch of variables. It goes down, and it looks quite simple from here, and that says apply to each attachment, and then respond to the sender, that's you, and then delete the email. Looks simple, doesn't it? But we have to open the bonnet and see what's inside here. And now you're going to see expand, 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 lots of steps, parallel branches, and so forth. I would say that this one is probably on the more complicated side that you would generally need to deal with in your day-to-day activities. Normally it's just move a file from here to there, or do some processing of something, 5 to 10 steps. This one really, it's doing a lot of looping because, there's my notification, by the way, reminder by Power Automate, so yay. So this one, you think about the looping. You send in one email with 5 images attached. And then for each image, it's a loop. And then for each image, it finds 3 faces. So 5 loops and number of faces it finds in each. So it's looping within looping within looping. So nested looping up the yin-yang. So we get the attachment details. This is where I get the metadata, the binary contents of the file. I do some resizing. So the cognitive services has a limitation on the size of the file that it will process. So I have a step in here where, here, get the image details. This is where I go and get the attachment, and it just creates a bunch of variables that are passed down the Power Automate that I can use later. So if I look at this step here, okay, I'm setting the switch to say, is the file too big or too small or right size? I have 3 options here. One is the file is too big, therefore I'm going to pass it to an action, which is a third-party action called Encodian, and it resizes the image for me. And then it writes it to Azure Blob Storage. And then I can use cognitive services on it. So for any of you who sent me a 5, 6, 7 plus megabyte image, it resized it and stored it in storage. Otherwise, cognitive services would have said, no, file's too big. I also have a minimum size limit, because a lot of you would send an email with a photo of the company logo and all that kind of stuff, and it processes that as well. So I kind of have a minimum, I think it's like 50 kilobytes. So if any of you sent a photo that was 40 kilobytes, it was just going to pass it into the too small bucket. I'm going to assume it was your footer of your email, okay? First things first, I do a switch. Large attachment, normal size attachment, and that's what this step here is doing. And this step is using, and this is where we start to get a bit advanced, it's using an expression. Should be. Oh no, it's setting the switch. Where's my expression? So you can see here, there's functions that you can apply on the metadata to say, time? Okay. There's functions you can apply on the metadata, apart from using the actions that are just click and drag. You can write little scripts as the workflow language. Okay? Now, very quickly, I'm going to run through the rest. Large attachment, it resizes the image and stores it in blob. Now, if it's a good size file, it's going to add the streaming data set. It's going to do in parallel my custom vision and my facial recognition. If the facial detection is not empty, it's doing identification, so on and so on and so on. So you can see it's diving into more loops, And it was not easy to write this because the user interface gets harder to work with as the complexity grows. But I found it to be very, very stable and quite enjoyable, a little bit, in fact, to start writing these flows. So I'm going to pop over to my final slide. And say thank you very much. Thank you.
Go? Yeah? Oh, okay. Cool. Hi. So, my name's Simon. Hi. I'm a consultant. I do lots of work with data lakes. And it's been a bit weird for the past couple of years. The technology has changed a lot. So back in the day, people built lakes. They didn't really work very well. And it got a bad reputation. Anyone heard of a data swamp? There's lots of, there's the anti-lake propaganda coming out there, ruining our reputation. And today I want to talk about a thing called a lakehouse. I want to talk about why things have changed so much. What's different about the way that we build lakes now than it was 2-3 years ago? So that's the plan. That's what we're here for. If you didn't think we're talking about lakehouses, you're in the wrong room. I'm a Microsoft MVP, so I talk to Microsoft quite a lot about their products and about Synapse and all that good stuff. I'm also a Databricks beacon, which is no one's ever heard of, and that means I do the same with Databricks. So I talk to Databricks about Spark and the roadmap and where they're going to try and build the best of both worlds. That's what I do. Cool. So, anyone seen something like that before? It's like an enterprise data warehouse, right? We've all built it 1,000,000 times. You get some data from somewhere, you put it into some kind of staging schema, you pick it up, you put it into a clean schema, you pick it up, and you turn it into a warehouse. Age old, we've been doing that for years. And that's rubbish, honestly. That's the way we used to do things. And there's a load of problems with traditional warehousing. There's a lot of things that we used to do that don't quite work anymore. So we kind of moved away from it. And people moved and started doing something that we call the modern data warehouse. It's like an architecture pattern of saying, I'm gonna plug some things together. We're gonna do some early stuff in a lake, and then we're gonna pick it up and put it into like a staging schema. And that just still doesn't make too much sense. So things have changed, things have evolved. We do different things than we used to. So some basic stuff. Got a data frame in Spark. So everything we're doing these days is in Spark. Who uses Spark? Not that many people, okay. So we've adopted Spark as our main ETL language. We use it to transform data. We use it to query data. We use it to move data around the place. And there's reasons for that. Now, one of it is flexibility. So if we are trying to load some data somewhere, we're trying to build something that picks some data up, shapes it, and puts it down. In the old days, when we're doing things like SSIS, we're doing things like traditional data transformations, I need to have a script for every single piece of data that I move. If someone says, move this bit of data, I need to go, okay, I need to write some code, I need to tell it which table, I need to tell it where, I need to deploy that code. If I'm deploying that code, I have to test that code. So getting new data into a warehouse is really slow, it's not very agile, there's risk involved. If I'm using Spark, I can have this thing called a data frame. And that's the same, it's basically just a query, but I can pass in, this is the schema I'm expecting it to have. This is the format of data, is it JSON, is it CSV, is it Parquet? This is where to find that data. And they're just parameters. So I can write a really generic script saying, pick up some data, I'll tell you which data and where at runtime. Do something to it, I'll tell you what to do as code, as parameters. Write it down to my lake, and I'll tell you where to put it as parameters. I can build one script that can load data from anywhere to anywhere with any transformations and just make it metadata driven. So suddenly I've got agility. Suddenly, if I want to add more data, I just add some rules, I add some metadata. I don't have to do a code deployment. I don't have to retest my entire framework. So Spark's about agility, which is a bit of a weird thing, because you talk about Spark, and people go, oh, it's a big data tool. But I don't have big data, because big data is only if you've got petabytes of data, right? It's only if you're Uber, Netflix. It has that reputation because of that name, big data. And that's not what it's for me. For me, it's about agility. It's about, I've got 100 tables I need to load, and I want to do that fast. I want to have a small bit of code that is so flexible. That's the benefit of Spark for me. So doing this kind of thing, Spark enables it. So we have been on a journey. So we started off in the world of databases. We started off building relational warehouses, Kimball star schemas, all that good stuff. We threw it away and went, I'm going to build lakes. But as I mentioned, lakes themselves have been on a maturity journey. So when people started first using lakes, they were like, I'm going to use the humble CSV, because it's human readable. You can open it. It works. It's easy. But it doesn't have structure. It doesn't have a schema. If you compress it, then actually it performs worse because you don't get parallelism. There's weird things with CSVs. And if you're trying to build a professional analytics system, you're trying to make a star schema with facts and dimensions that is good quality, you can't have to tell it every time you read the data that that's a date, that's an int, that's a string. That's really, really painful. So people went, yeah, we're going to move to a thing called Parquet. Anyone used a column store index in a SQL server? Parquet's that, but as a flat file. Column store compression, really good compression, really, really good. You can select certain columns and not read the rest of it. It's great for analytics. And it has the structure built in. So when you read it, it knows what columns it has. It knows what the names are. It knows that that's an int, that's a date, that's a string. Loads of benefits. But it still has loads of problems. It's still a lake. Someone can go and just delete a file and then suddenly you've lost data. If you write an update, what if it's wrong? You don't have a backup. You can't roll back. There's danger. You can't really manage a system that way. So whilst Parquet was good, it wasn't good enough. So people like me were trying to build star schemas and analytic systems and that kind of thing in a lake, but you had to do so much work to make it reliable. You had to have so many extra processes to make it kind of work that it wasn't really that useful. It wasn't that maintainable. You had to have tons of specialist skills to do it. And that's not good. So the thing that's changed, this new thing called Delta. So Delta is a file format. And Delta is a Parquet-based file format. So your data is still held as Parquet. And what it does is it adds a transaction log around the top. Stored as metadata, stored in the lake next to your files. Real basic, really easy. But what that does is means you can have governance, you can have a rollback, you can have statistics. It's more scalable. It does so many things. You can write a merge statement. You've no idea how happy it makes me that I can write a merge statement. And Delta enables all of that. So this big pivotal shift, this change in how people think about lakes, is saying rather than have all the problems of lakes and flat files and it's not managed and no structure, it's saying, well, actually, let's learn from databases. Let's learn from all the good stuff about a relational database. The governance, the schema, the transactions, the statistics. Apply those to the lake, but keep all the good parts of a lake. Best of both worlds. That's what we're trying to do. So if someone says lakehouse, we're saying, I want to build a good analytics star schema, a data warehouse, but I want to get all the benefits and the technology underpinning it from the lake. That's it. And yes, it's a cheesy marketing term. Yes, it's propaganda coming from Databricks with them banging the drum going, yeah, the lakehouse, we've invented a new thing. I mean, we're still just doing Kimball. We still have dimensions, we still have facts. Now, we might occasionally challenge that structure and go, well, you know, who's ever put a string on a fact? Oh, look at you, judging me. It doesn't matter so much, because actually the column store compression, the way you can manage it in the lake, you don't have that requirement. So some of the old rules no longer really apply. But all things like slowly changing dimensions, all the data modeling, the data management, is all absolutely as relevant as it's ever been. So we're saying, well, let's take Kimball, let's take warehousing, let's make sure it's relevant for the technology, but we're using it in a lake. That's a lakehouse. Cool, right, bye. No? Okay, you want some proof? We'll go talk about it, talk about what it actually is. So, as I said, all the good points of a database. We want it to be structured, governed, familiar. Like, never underestimate how valuable familiar is. As in, I want to be able to write an update statement, a merge statement. I want to be able to write in SQL, delete from my table where value equals whatever. You couldn't do that in a lake previously. So just saying, all the skills you know about managing a system, you do it the same way. It's just so vital, rather than having to relearn and retrain and learn an entirely different language. If you can manage it the same way you manage a current SQL database, that is so valuable. And it's fast for certain things. But we're keeping the flexibility of a lake. It can handle JSON, which shouldn't be that hard. Come on, SQL. But having complex data types, having images, videos, being able to do advanced analytics, being able to do data science on the same system using the same language, rather than having to pull it out, do some modeling, push it back in again, or hack a model into a database which never really worked properly. You can use the same technology to do all that stuff because we're using a lake. So it's best of both worlds. It's what a lakehouse is. So yes, take it with a pinch of salt. There's a bit of marketing propaganda in there. But the technology approach just makes sense. It's the same thing we've always done. Make sense? Cool. Okay, so what is Delta? Yeah, you've got the official definition. The unified data management system that brings blah, 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 blah. Makes no sense. That's all fluffy marketing words. What is Delta actually? It's an optimized managed format for working with Parquet. In a nutshell, that's it. Your data is still Parquet. Add your transaction log. It makes it easier. If you want the even shorter, condensed version, it's Parquet, but better. Data still Parquet. Your actual data files are literal .parquet files using the same engine. It just adds some stuff around it. So, sounds quite fancy. What's it actually doing? So, we have our folder. Get everything in a lake is a folder with some files inside it. And the way it used to work, we'd have my folder, got some Parquet in there. Now, Parquet is immutable. I can't change it. It's a compressed file. It's like opening up a zip file, changing it. You can't like recompress it. It's not how a compressed file works. So if I wanted to update this Parquet, I'd have to read all the data into memory, update it, delete the existing one, and write it back down again. Which again, is painful, right? This is what my life used to be. So if I did something like delete star from there, where segment equals 3, which that command wouldn't work, I'd have to build a bit of code to do it. After that delete, I'd have one Parquet file that has the updated records. So I had my old state of it, delete those, I now have a folder with one Parquet file. That's how it used to happen. We move over to Delta. We now store this in the Delta file format. It looks more like this. So I still have my folder. I've still got my original data stored as 2 Parquet files, but now I've got a subfolder called Delta log. So you know it's a Delta table if you look at it, and it's got a Delta log there. The data's still Parquet. The data's still stored in exactly the same way. It's just I now have a little JSON transaction log. That is it. So if I want to then figure out how that works, what is that transaction log? It's just a list of what files are currently part of that table. So I can open up that JSON every time I edit that table, every time I add data, remove data, do a merge, whatever I happen to do, I'll have a new little JSON file, and that will say, I've added some files, I've removed some files. So whenever I want to query it, I say, right, what files are currently part of my Delta table? In this case, my two Parquet files are currently part of my Delta table. So what happens when we do that update? So we go in, we do our delete star from sales where segment equals 3, which now works. I can now write delete statements, update statements, merge statements because of Delta. And it adds a transaction. So I've changed the data, I get a new transaction. It writes down the new state of data. So I've got my new Parquet file that's got those records deleted, the new state of data. And in that new transaction log, it says, well, the old files, they're no longer relevant. That's a historical version. That's an old version of my data, and I've added this new file. So when I come in and query it, when I say, right, select star from my table, it looks at that, it sees the transaction log, it realizes it doesn't need to query the old files, and it just reads the new one. That's all it is. Delta is just a rolling file manifest going, at this date and time, those files are active, those files aren't active. That's it. It's really simple in terms of what it's doing. It's just a list of files. And what that enables you to do is kind of nuts. There's a load of stuff you can do because of that. So we can come in here and we can do select star from sales at this temporal point. So I can time travel. We can say, I want to know at this point in time what files were active in my Delta table. So select star, timestamp as of 2022, 09, 02, 1201. What time is it? I was trying to get it right. And that will look at that and go, oh, at that point, we hadn't applied our new transaction, therefore we didn't know that we had the new file, we haven't removed our old one, so it looks at the old state of the data. So I can query at any point to go, what state was the table in at that point? Now, bit of a warning here. Everyone looks at that going, oh, I can use that for slowly changing dimensions. Oh, perfect. Do not do that. That's a terrible thing to do. Because actually, if in my original 2 Parquet files, if I had 10 million rows in there, the new state of it has the same 10 million rows. So every time I update, there's a load of redundant rows copied over that haven't changed. So if you keep this for a long time, if you think about how many excess copies of every single row you'd have, it gets really expensive. So you can use it for slowly changing. If you hate money and you want to give it all away to Microsoft, go nuts. But generally we don't. We treat it like a transactional backup. It means for a week, for 30 days, if I do a big update statement and I just ruin all of my data, I can go roll it back to the previous version. And I can do that. got the ability to back things up in a lake, which is so sad that it's so exciting, but you didn't used to have that kind of thing. We've got the maturity slowly coming in here. It's enabling us to treat it like a professional system, just by having a transaction log. That's it. It's like, now we've invented things that relational databases have had for years. It's not new. It's just the idea of separating it, storing it as metadata, keeping it next to the data, and still getting the benefits of a lake. That's what it's all about. So yeah, it's interesting times. So what else can we do? So if I've got my Parquet sat there, and I have a bit of data that comes in, but that data's got 4 columns, not 3, or loads of extra data types. It's a different data structure. The schema has evolved. And I have the ability to say, no, guard my schema, which again, we couldn't used to do in Lake, and if you tried to update it, it would just put it in there and then everything would break and it was painful. Now we can have schema enforcement. We can say, no, I want a good managed structure. You're not allowed to change my data. That's an option that we have. Or we have another option, and we can go, actually just evolve. From that point, add the new columns. Without writing any alter table statements, without having to code around it, without having to deploy a new version of it, I can just tick a box on the table properties saying, if anyone tries to insert data that has extra columns, just evolve. So I can have the flexibility of a lake. I can have it agile, I can have it adaptable, or I can have it governed and secure. That's my choice. Again, it's just features that is blending the good parts of a lake, the flexibility, the adaptability, with the governance and management of a warehouse. That's what we're doing. I can write a merge statement. So, just really familiar syntax. Who's written a merge statement in SQL? Good. It's the same. And that's kind of like, again, familiarity. People who are used to doing that kind of ETL process in a warehouse, you can use the same script. You can do it in the same way. Now, in reality, I never do that. I do it in PySpark, because then I can parameterize it. I can have one generic merge statement, so one script that can say, merge any bit of data into any table. Run it 100 times for 100 different data sets, and I'm managing one script, not 100 different ETL pipelines. So you can do it better. But just the familiarity of having that stuff is kind of insane. It's kind of nuts. So, let's go and have a quick look at how things are working. So I'm here, I'm in Databricks. I've got my script here. My cluster is turned on, because I was good and I was prepared. I've done this before and not had that. And I'm just going to dive quickly into my lake, so then we can go and have a look at what's going to happen to our data while we go and have a play with this stuff. I should have done this before, but it's fine. Okay, so I've got my data Scotland. Go in there, I'm going to delete that existing data. So we're starting with a blank slate, and I'm going to go and delete that database as well. So we're starting with nothing, and then we'll go from there. So drop database, Cascade is going to delete all the tables inside it, and then we have nothing. We are starting with a nice blank slate. I'll make that a little bit bigger for you guys. Cool. Okay. There we go. So let's run that command. So I'm going to create a database. Now this is all the SQL layer. My files are still in the lake. I'm still managing a lake. I still have flat files. I'm still going to have Parquet and Delta and all that good stuff. But all the way through basically any Spark provider. So if you're using Synapse, using Databricks, you can have this SQL representation. And it looks like a database. And it looks like tables. It's just pointers. All it is just pointing at those flat files in the lake. So that table doesn't exist. I'm going to do a create table statement. So create a table. Here's some data types. Here's some column names. Do it in this location in the lake. Now, that is magic. It shouldn't be magic, but it is magic. Because in the old days, the schema, the structure of that table is built into the files. So there's no data, you can't create a table because the table's defined by the files. So you never had this idea of being able to create a structure in advance and then fill it full of data. That just wasn't the thing in a lake. Now we can. So we can run that, gone off, created our table. I ran that yesterday, going to run that again. And what that's going to do is going to create an empty folder. An empty folder with a transaction log that defines that table. So we can go. You'll be there in a second. So I've got that Delta Lake folder, I've got my address. There's no data in that folder. There's no Parquet. I've not inserted any rows, there's nothing in there, but it has a transaction log. So I've got a little checksum file and I've got the actual JSON. I've got the what happened as part of that transaction. Now open it, download that file, open it up. You can use the magic button, which is Control, well, sorry, no, I'm not going to mess it up. Shift, Alt, and F, auto-formatting of JSON files. Love it. Okay, so we've got a transaction. So what have I done here? I can see the schema. So I have the definition of the structure of that table held in my transaction log. I can see some information. Who did it? It was me. I did a create table statement. I've got an audit trail. I've got governance. I can see who went and updated my data. And I've got some cluster level information. Which notebook, which cluster, how is it run, some basic stuff. That's good, that all works. I can then insert some data. So go off, insert a load of data into that table. Just a quick insert statement. It's all hard-coded, wouldn't normally do this, but just generating a bit of data. There we go. And we can go back, and what we'll see is there's another transaction. So I can see I've done something else to my data. I can go back and have a look. I've got a Parquet file. I've now entered it. So the data is still held as Parquet. It's still column store. You still get good compression, all of that stuff. Except now we have this little transaction saying I've done something to my data. Let's open this one up. So we can see we've got an add. We've added a file. So because it added a Parquet file, it's made a transaction log saying I've added a Parquet file. Great. We can see some stats. We've got number of records. So I know there's 3 records in there. So if I ever do a count star, if I ever say how many records are in my table, it can look at the transaction log and return it. It doesn't need to read the data. Really importantly, I've got these things. I've got the minimum and maximum values for each column. So look at that as an example. The minimum customer ID held in here is 11. So if I write a query and say, give me all the data for customer ID 3, well, it knows 3 is not in there because it's not between that minimum and maximum value. So it can do data skipping. Suddenly, it's got really, really fast because it knows it needs to read that data, doesn't need to bother reading that data. So it's got a load of stuff built into it for sheer performance, like auto-indexing. And I know statistics aren't an exciting thing in a relational database. This is magic if you're doing it in a lake. Again, it's borrowing all of that good stuff, all that learning, and giving that maturity to a lake. Okay, let's do a bit more. So we can take our data. Again, we can go and select it, we can go and view the data, that's all fine. What we're going to do, create a quick view. So creating a view with some more hard-coded data, that's changing that customer ID 11. I'm just going to change the data. So I'm just making a quick hard-coded view and then merging it in. So merge into my new Delta table from that view, join it on the customer. In this case, I'm just saying update everything. But we can do conditional, update these columns, not these columns, all of that good stuff. So I can run that. So it's going to look at it, figure out if it has to change any data, read that data up, edit it, write it back down again. It's still doing all that stuff. I didn't run my view. It helps if I actually run that thing. There we go. So it's still going to do the same steps it used to do in the lake, but it's managed forward, it's abstracted away. I can use my familiar commands. And again, we'll just see a new Parquet file. It'll say it's got rid of the old Parquet file. It'll mark it as removed, and it's added the new state of the data. But it doesn't delete the file. So if I come in here, I've got my new transaction. But if I go back, I've now got 3 Parquet files. So I had 3 records. It read it up. It put 2 records down in one place, 1 record down in another place, because that's the 1 record that's changed. That seems a little bit silly. We don't normally do this for 3 records. We normally do this for millions of records, but it's fine. We can go and have a look, again, what happened in there, and we'll just see those added 2 files, deleted 1 file. There we go. So I've removed a file. So my original file is no longer part of my Delta table. If someone says select star from this table, it's not going to bother reading that Parquet file. I've added 2 others, one with 2 records in, one with 1 record in. Again, that's terrible for performance in Parquet. You want nice big chunky data sets to compress it. But it's a little toy example with 3 records. But managing that, again, is just a merge statement. It's the thing we're super familiar with. It's the same way things have worked for a long time. And that familiarity, that way of working, that ability to lift and shift your existing merge statement scripts and just run it in Databricks and get all the scale and get all the performance of a lake is great. So there's tons and tons of stuff we can do in there. Okay, time travel we can do in little bits. Okay, So yeah, lots of things we can do. Now, there's a problem in there, right? In that, if I've done lots and lots of tiny changes, I've got those 2 Parquet files, one with 1 record in, one with 2 records in. That's not great. Because Parquet does a thing called run length encoding. And that's essentially, if there's repeated values, lots of the same value over and over again in a specific column, it can go, well, actually, it's that value for the next 1,000 rows, and it stores it as that, and it compresses really, really well. So the more data you have in a Parquet file, and the more there is repeated values, the better compression. So having a couple of rows spread across lots of small files goes really slowly. It still works, it's just not that performant. So if you're doing lots of tiny little updates, it goes slow. There's a thing called the optimize command. What that does, reads all the data and goes, I'm just going to take all that, lump it into a smaller number of larger files. It's a bit like defragging an index, right? It's just a regular cleanup job. You can run it as a maintenance job. You could do it in the evening or weekend, but you don't need to because we've got separation of storage and compute. I could be running that while people are querying it, and it makes no difference. But it's a maintenance job you have to do. You need to think about when you're doing that, part and parcel of it, and it'll go and fix it. We can go even fancier. We can go even deeper with a thing called Z ordering. And that uses a thing called the Hilbert space-filling Z curve. Bit of maths. And that is essentially a way of efficiently laying out data. So that's going to actually reorganize the data and go, well, because of those minimum and maximum values, if I put all the ones from like 0 to 50 over there, ones from 50 to 100 over there, I'm going to more efficiently be able to do data skipping. Again, it's a bit like doing a clustered index on reorganizing the data about how it's laid down on disk to make it more efficient. So we can go deeper and deeper and deeper into doing this to really get really, really good performance of what's coming out, all because of Delta. You couldn't really do this kind of stuff without that file format. Again, so a quick Z ordering thing. I've got 4 files with Bob and Fred and Andy and Tom, Brad and Tim, that kind of thing. I can say I'm going to reorganize this. So if I queried it saying where name equal Brad, well, Brad could be between Bob and Fred, could be between Andy and Tom, could be, obviously, it's in the one that has Brad and Tim. So my data skipping is not that good. So I wanted to come back in here and say, no, let's make it better. I can optimize this table and go, well, actually, let's pick it up, reorganize it, optimize it, and Z order by the name. And then it's grouped Andy to Dan together and Fred to Tom together to reorganize my data around that so I'm more likely to do data skipping. Again, small data example. If you think about this with millions of rows, hundreds of millions of rows, billions of rows, this suddenly gets massive, massive performance benefits. And that's one of the things, right? The lakehouse, building these warehouses, needs to be fast for analytics. If someone's going to have a dashboard and hit refresh, they can't be sitting there for 10 minutes while it trawls through billions of rows. People expect a certain level of performance, which you didn't traditionally have because it read all the data. And then it gave you the results, and it could do it. It could handle massive amounts of data, but it couldn't handle the nice, quick, small queries very well. So these are all things that are just adding maturity to make it better. Now, doing the optimize as a maintenance job, you might say, can't we just optimize it on the way in when we write the data? Yes, you can. So there's some auto-optimize. Whenever we write the data, I want you to just quickly tweak it, just make it a little bit better. And we can do 2 things. We can do optimize writes, and it changes the query plan. It makes the query less efficient so that it writes out bigger, chunkier files. It's saying, I want you to optimize to make the files a little bit better when I write it out. Or I can do auto-compaction. So that's once it's finished writing, it does a little second job to go and look, are there any small files there now? And cleans them up. So there's various different tools and techniques for improving the performance of our data, for making it more efficient, for building it in, that's enabled through Delta. So we end up with something like this. I've got a Delta table that's got some chunky-ish Parquet files in there, loads of really, really small Parquet files. I'm about to update with lots of tiny, tiny little files. And you can go, actually, no, let's make that more efficient. Let's write it out as 2 chunky files. Then actually, let's clean up, using optimized auto-compaction, let's clean up those little ones while I do it. And then afterwards, at the end of the day, I run an optimized job, takes all of that old data and puts it into really big chunky ones. There's just different patterns, different ways of maintaining things that we can do enabled by Delta. I know we've gone a long way there. We've gone from, we used to have CSVs in Lakes to now we have real efficient performance tuning techniques using these flat files. And it's kind of changed around a lot about how we do things. And so really, really quickly, we should have a look at what that actually does. So We're going to skip the schema evolution. Let's go and look at querying it. So if I've got my table, I've got my history of what's happened in that table. I'm going to rerun that again so we get today's one. So I've got this view of my transactions. I can see everything I've done to that table. I can go and have a look at who updated it yesterday. Who was the one who ruined all the data? Oh, it was me. Okay, cool. That's fine. We can do time travel. So we could say, just with this, show me what the data looked like when I'd first inserted. When I first created that table, what did it look like? So we can go in here and go, show me the version as of 0. That's an empty table. There's no rows in it. Version as of 1, after I've done that first insert of data, we can see it's got some rows. Version as of 3, doesn't exist. 2 is the one after I've done that merge state with my updated 1. That version is using this. So the delta has an implicit version, how many times have I updated it. I can also query it based on the timestamp, on the date. As of this point in time, what did that table look like? So time travel and the idea of that is all baked into it. When we're doing things like optimize and those big chunky rearranging of data, that's just another operation. It's another line in my transaction log. Weirdly, I can time travel to before I optimized it and after I optimized it. And the data's the same, it's just one side faster. Which you can do. It all treats it the same way. So optimizing things is literally as simple as optimize the table. It's all baked in. It's all nice, easy, familiar. You want to run a big job to pick up all the data, rearrange it, compact it better, get better compression, optimize this table, and it optimizes it. I could add in the Z order by, and that will rearrange it and try and rearrange the data to make certain queries faster. So it's all deliberately built to be familiar for you if you're coming from the SQL world, but give you all this power and benefit. There used to be a real specialist skill. So it's all changed quite a lot. Okay. So, what are some fancy things you can do? That's the basics. That's like the normal stuff. So we can do table cloning, which is a little bit insane. So if I wanted, maybe if I had a new bit of business logic, a new calculation, someone gave me a new definition for a merge statement, and we had to test if it worked. And I didn't have enough data in my dev or test. And they're like, just try it on prod. That'll be fine, right? No? Okay. If I wanted to do something, if I wanted to test it out, I can create what's called a shallow clone of the table. And that'll create a new delta table pointing at the original Parquet files. So I'm not moving the data, I'm not copying the data. It's just saying, here's a table that looks like it, that refers back to the original data. I can then run a big update script on it, and any data that changes will live in the clone. So it doesn't impact the original table, but it still has all the data from the original table. And then if that's good, I can just delete it. So you've got these different techniques to protect you in production. Again, all about making it production grade, making it enterprise grade, making it good enough to use in anger and not delete all your data accidentally. So table cloning, super useful, loads of different use cases for it. You can also do a deep clone, and that does physically copy the data over. It's up to you. So that's one. Table restores. It's a backup. So if I was looking at that delta table, and I did an update statement, and that put loads of garbage data in there, I can go, just restore it to the previous version. And it adds a new transaction, going, actually, we're going to go back to before that happened. Which again, it's basically a table-level backup. Now, it's pros and cons, right? We can't do the database style, restore this entire database back to this transaction. We have to do it on a table-by-table basis, but we can do it on the table-by-table basis, which is quite nice. And the ability to do that, the ability to roll back before a change. Again, I wish I had had this like 3-4 years ago. Just the ability to try something, if it doesn't work, get out of jail. Make a safe area to try something, and then roll things back. These are tools that we didn't have previously that really enables us to actually use it properly in anger. We can do CDC, so change data capture. So we can enable that on a delta table. So alter table, set table properties, turn CDC on. And what that does, it keeps an additional copy of any data that's updated, saying, well, this was updated, this is updated, this is the version of it before the update and the version of it after the update as a separate record store. So if you're trying to have this as a big ETL chain, and you just want something to subscribe, and just tell me what's changed. Just tell me what was deleted and what was inserted. That automatically starts logging it and keeps it as a separate data store that you can just query. So you can go, well, select from there, tell me all my changes, pull from my table change log, kind of similar to the way CDC works in SQL Server when you turn it on, and it's just stored automatically as extra data sitting in your lake. Again, it's all nice, automatic. Switch it on, starts working. Yes, you are going to have more data. It's going to be a cost to it. You're keeping extra copies of your data, therefore your storage cost is going to be slightly higher. But if you need that, you want to turn that on, you can just turn it on. Other things, we've got things called Delta Live tables. Starting to get into the weirder Databricks things. So, Databricks have kind of seen that everyone's building an ETL framework, right? Everyone has some orchestration thing and some metadata-driven thing. People are building more and more of these patterns to do this, to move your data from your raw, uncleaned area to your nice, clean data, to your nice star schemas, or whatever kind of curated data models you're doing. And that's hard. Dependencies are hard. Trying to say, well, actually, which table do we need to run to get to that table? Well, that depends on it, and then it needs to run those two things, and then I need to run that one. Building out that is a complex thing to build. And so there's plenty of these ETL tools knocking around. You can do things like mapping data flows in Data Factory. There's various different flavors of it. The Delta Live tables is Databricks' flavor of that ETL framework. So I can write a load of SQL. I can define a load of tables in SQL. I can then put it into a Delta Live table, and it will look through it all and go, actually, that depends on that, depends on that. I'll run it in this order, and it will run it for me. It will also optimize the tables for me. It will look after the telemetry. It will look after all the logging and all the auditing. And it's fairly new. Honestly, it went to GA about 3 months ago. So it's still maturing. There's still some things that it can't do. But there's a lot of things getting baked in. It can do mergers now. I know that's not crazy, but it can do mergers. It couldn't do mergers originally. It can do data quality expectations. And it's based on a similar idea to an open source Python library called Great Expectations, which is about saying, great name, it's about saying, I expect this value is never more than 1,000. I expect this record has to have this ID, otherwise it's corrupt. So you can set out these expectations based on kind of a SQL where statement. And what this will do, it'll automatically keep track of it. So just general reporting, going, okay, we had a 50% failure, a 5% failure. There's some metrics which are just keep an eye on it. There's metrics are, if it fails that, chuck out the row, get rid of any bad rows that fail. And there's expectations which are, fail the whole thing, that is a critical error, break it. And you can just plumb that into the logic of your scripts. So there's a load of stuff that we can do inside Delta Live tables. It gives us so much power. So we're going to have a quick look at a quick example one. So we dive in here. Going to go back out. Let's have a look in here. I actually grabbed a real quick basic one. This is from the Databricks documentation on it. So they've done a real quick script, pulling some data from a bit of JSON. So it's from a JSON location, and they're saying create live table. That's it. It's just create table as select from blah, 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 blah. So they're creating a live table called clickstream raw. This is their raw data, pulling out some Wikipedia data. They've got a little comment which goes into the metadata so we can see just a little bit of documentation, and saying go and pull from this hard-coded file. Or that could be an API, it could be a database, it could be a Parquet file, whatever your source data is going to be. And then they've got a second table, which is pointing at that original table. So I'm going to create my clickstream prepared, and that's selecting from live to show it's a Delta Live table, clickstream raw. So the dependency there. So it knows that in order to get this data, it has to run the other table first. So we can just pile up these things, building them on top of each other, and it's automatically going to work out where those dependencies lie. We can see I've got these two things. I've got some expectations. So I'm adding an expectation constraint that the page title's not null. And it's just going to keep an eye on that. I'm adding an expectation count that it can't have a negative view count. That's not a thing. If that ever happens, I want the whole thing to fail. So I can build in, for each of my different tables, what my data quality expectations are. And I've got a final one, which is going on my silver one, which is just doing a little bit of aggregation. It's my final gold table, if we're using the Databricks parlance of bronze, silver, gold. And again, this is built to be really accessible to your end users, right? To your data analysts, to your people who are like, write a bit of SQL, this is good. Write a giant pile of PySpark, no, that's evil, dirty, and wrong. So this is meant to be really accessible. And you can do this in PySpark if you prefer Python, like me. So what you do, you have this notebook. And then we've got these things called workflows. So in Databricks, workflows is where you have like your scheduler, it's a bit like SQL Agent. You can say at this point in time run this, at this point in time run this. And then we have Delta Live tables, which is where we have this pipeline. So in my pipeline, if I created a pipeline, I can give it a name. There's additions. If you want the expectation stuff to work, you have to go for the premium version. Shockingly enough, it's the main feature in there, therefore they put it in the full price version. But what I do is I give it a quick name, and I point it at that notebook. So which notebook do you want? Where's all these definitions? And I could say it's in that notebook. And I can do a whole bunch of notebooks. So I can say, well, there's the notebook that defines that data model. There's another notebook that defines that data model. Here's another notebook that I've written in Python to automate and engineer a load of stuff. And I can just bundle it all together. And I'll work out all the different dependencies and do it for me. So if I just go into one I've made earlier, we can see I've got that SQL DLT pipeline. And then you'll see what it looks like. So we get this. So it's looked at that notebook. It's worked out that I had 3 tables. It's realized that one depends on another, and it's mapped out those dependencies for me. I can dig into one of the tables and say, well, what's actually going on inside there? Whoop. You can see inside that clickstream prepared, the data quality. So it wrote 100% of my rows, so it wrote 22 million rows. And I can see what are all the expectations. So my valid page count, there's 5 failed records. So it's okay if it's beneath 0.1% failure. What are my valid counts? There was 0, so it was okay. It didn't break the whole thing. So data quality management just baked in by adding a few expectations onto those tables. If I go a little bit fancier, so I built one just with a bit of Python that goes in a giant loop around a load of stuff. And normally, if you build a loop, who likes cursors? No one likes cursors. In Spark, cursors are fine, because Spark is lazy. So you can do a load of definitions. We use loads of iterators. We say just go down a list of rules, apply all those rules, and at the end, execute it. Because unlike SQL, it's not executing like the data every time you make a change. You line up a load of instructions and then say, right, now run. So you can do a lot more automation. You can do a lot more framework building using this stuff. So we can get things like this. Oops, if we zoom in properly. So you can get like a load of tables with dependencies. So go and make a load of data, get some data, clean the data, land the data, and then run other things based on it. And very fancily, we can say, actually, rerun my entire thing, but I only want you to update those 2 tables. So we can do like selective partial reruns. We can do dependency management across my whole thing, and we can do it based on automation and metadata. So loads and loads of stuff which is all being baked in, and beneath the scenes, all of this is running on Delta. It builds a lot of Delta tables for you. It saves a lot of Delta tables in your lake. It automatically optimizes all of your Delta tables. Again, it's just underpinning this stuff. So the world's changing. Lots of things are coming out. It's moving very, very quickly in terms of how we see things. And all of that is what we're talking about when we say the data lakehouse. So it's all coming into this thing of saying, well, all the problems that we had. So we said, well, for it to actually work, for it to be a real thing that we could do, it's got to be structured. It's got to be governed. It has to be familiar and fast. And we can see it's ticking all those boxes. All those features are working towards that story. It is structured. It's got a schema. The schema's baked in. The schema can evolve, but it's managed. It's governed. We've got an audit trail. We've got backups. We've got restore functions. We can do permission models based on it. It's familiar because we can write our merge statements. We can do delete. We can work with it the same way we work with existing relational databases. And it's fast because it's got all these different layered performance approaches which are starting to get more and more automated to make it good. So all of the bits and pieces we wanted from relational databases, we've plumbed in. But those other problems, the problems with lakes, small files are really slow. Having lots and lots of thousands of tiny files is a real performance bottleneck. But that's not a problem anymore because we've got optimized. We've got things that we can just run that fixes that. The operational complexity of having to do 10 steps to update a record, that's gone because we can actually apply these straightforward merge update kind of functions. The problem that is not auditable or indexed is gone because we've got our audit trail, we've got our governance layer, we've got our transaction log, and we even have indexes we can put in these days. The thing called a Bloom filter index, which sits on top of Z ordering to add more performance. So those problems are kind of gone away. So all those reasons why, in the past, we used to do the modern data warehouse, we used to do a little bit of lakey stuff, all the good bits of the lake, and then we pick the data up and we put it into a relational database because that's where a warehouse lives. That was the past. I've built many of those in my lifetime. But these days, because actually serving data from the lake is so much faster now, it's so much better, it's so much more trustworthy because we've got all these layers of protection, we can skip that. We can say, actually, I should do everything from the lake. And that just means where my data engineers are. It's the same tool, the same language, the same platform, the same data as where my data scientists are. My people building out their Power BI reports, building out all their analytics are going to the same place, using the same tool. So it's just making things simpler. And yeah, it feels a bit scary because there's new tools and new technologies and this weird and wonderful stuff it's doing underneath the hood. But in the long run, it's making our architecture simpler. It's removing extraneous bits that we don't need. I no longer have to teach my support team how to look after a relational database and how to look after a lake. It's just look after this one thing. That is what a lakehouse is. And that is what I spend far too much of my time doing. Cool. So, thank you for listening to my little lakehouse rant. I do a lot of YouTube. So if you want to know anything about Delta, anything about Databricks, anything about Synapse, then just go and I just rant quietly in my little office at home going mad over the pandemic. Go nuts. Any questions? Get hold of me on Twitter or you can help now.
You talk about optimize and the kind of things you talk about optimize, perhaps not with the Z option. It feels similar to what checkpoints do. So I suppose the question for me is how much should you rely on checkpointing? Bearing in mind that that's configurable default. And how much would you recommend using explicit commands? And also, I suppose, secondly to that, what does that then do to the checkpoints?
Okay, so by checkpoints, you mean the checkpoints that are part of the transaction log inside the Delta table? Okay.
Every 10 transactions.
Yeah. So a little bit of context. So what does checkpointing do when we're doing optimize and how much should we rely on it? Those little JSON files you saw, every time we change it, we get a little JSON file. But I've just told you, querying lots of small files is really bad for performance. If you make 1,000 changes to a table, we don't have to read 1,000 JSON files to work out what's happening, otherwise my table will go really slow. So every 10 or so, I think the change that Cinema will decide depending on how busy your table is, every 10 or so changes, it'll actually wrap all those transactions into a bit of Parquet, which is better, and faster, and quicker. So that's like an auto checkpointing thing in the background. But that won't change at all the performance of querying your data. So it's absolutely true that you use in conjunction. Checkpointing keeps your transaction log fast, and you should just let it do its thing in the background. That should work away. Older versions of Delta didn't do checkpointing, which is why it's really bad and get into trouble. The Synapse flavor of Delta didn't do checkpointing, which is why you get into a lot of trouble, because Synapse uses the open source flavor of Delta, not the Databricks flavor of Delta. Databricks have now open sourced everything. So pretty soon we should be seeing all those extra features and checkpointing things in every flavor of Delta, wherever it is. But you still need to optimize, because checkpointing is not going to make your data faster. It'll make the interactions with the Delta table faster, but it's not going to make your data any speedier. So absolutely use both. And an optimize is just a transaction. So if you optimize, you'll see a new transaction saying, I've changed the file layout. These old tiny files are no longer part of it. The new chunky files are part of it. And that's it. Otherwise, it's the same as any other update. Okay. Because they were broken with serverless querying Delta for a while. I believe that's fixed. Maybe. Any other questions, or do we need to vacate the room, in which case grab me outside? Yeah?
See if you're using Delta tables and just PII data in them.
Yeah.
Essentially those PII values end up in the log. Is there any way of obfuscating them or hiding them?
So there's patterns for doing like dynamic data masking and obfuscation and that kind of stuff, but absolutely the minimum maximum values would be included in the transaction log. It only actually does those statistics for the first 32 columns. So what you can do is actually make it the 33rd column, and then it's fine, it won't be in there, or just turn that off, reduce the number. You can override it and say, actually, I only want statistics gathered for the first 5 columns, and then make sure all your PII come after that. So it's a bit weird. It's like just reorganize the number of, like the column that it falls in, but yes, you can protect it. There isn't a specific command to say, don't store this value, it's just a don't gather statistics for it.
So that number is just a switch that you put on your code?
Yeah, it's a table property. And that brings us to the end.
This is the test of the fire and voice alarm system. There is no need to take any action.
And that brings us to the end. Yeah?
I was just going to ask, I presume you can remove all the kind of histories things don't want?
Yes. There is a log retention threshold, so it automatically trims the log after 30 days, I believe, but you can override how long it keeps that transaction log for. If you do go past that, you can't time travel past that point. So your ability to be that temporal querying is governed by how long you keep the transaction log for. And there's also a pattern where you vacuum up the old files. So you can clean that up, so you need to be doing that. But obviously that limits how far back you can go. All right, I'll leave. God, jeez.
Attention please, attention please. Fire has been reported in the building.
Thank you.
And this is interesting because I'm from Finland. I'm a bit Finnish. So talking for a full hour about myself feels a bit strange, but yeah. Over the past 6 years, I've done a lot of things that I did not believe I would do. So again, one more thing to the list, I guess. So before I hop in, I want to, if the clicker works, it did work earlier. It shouldn't require anything. All right, I'm reverting back to the arrows, I guess. There we go. All right, before I head into the main topic today, I really want to say thank you to the organizers of this event. It is a free event, but still there's a lot that goes into it, and the organization has been super good, so it's been very smooth for us. And of course, what makes this event possible to be free is all the sponsors. So thank you to all the sponsors. This is what makes it all happen. And I'm super happy to be part of this event. I've heard good things. It's my first time at Data Scotland, and it has been a blast so far. So for those of you who don't know me yet, I'm Heini Ilmarinen. I am from Finland, as I mentioned. I am the Azure lead and also a DevOps consultant at a small Finnish company called Polar Squad. We focus solely on DevOps things. There's kind of that underlying theme with everything. It doesn't matter whether it's data, infrastructure, Azure, AWS, all goes. I'm also a Microsoft MVP and an MCT. I am a third of the Knee Deep in Tech podcast nowadays. Again, a thing I didn't imagine I would ever do. And my favorite topic is architecture. You will maybe hear a bit more about that. And I'm a math nerd at heart. And I'm a bit of a serial doodler, as you will see in the slides as well. So this is where I'm at right now, but this is not actually where I started. 6 years ago, I was a freshly graduated mathematics major, and well, the path was paved for me to become a math teacher. And well, I wasn't really so keen on that. Like, I thought that math in itself is pretty fun. But somehow the prospect of teaching math all my life felt a little like just not exciting. I could not really point what is necessarily wrong with it, but I just wanted more challenges on the kind of the intellectual level, I guess. You know, there are challenges in teaching, like the teenagers and stuff like that, but I wanted a bit different kinds of challenges. And if you had asked me 6 years ago where will I be in 6 years, I would have had no idea. I was still trying to figure out what should I do with my life. I still had no idea of really IT and what I could do in IT at that point. But let's see how I got there. So I had studied mathematics, and while I was studying mathematics, I did my thesis in something called elliptic curve cryptography. And this is what they look like. They're these curves. Pretty, aren't they? There's a interesting property to these kinds of curves. And what it enables us to do is, if we choose 2 points on this graph, and we draw a line through that, we can always find a third point on the graph. So this is true to any 2 points that you choose. You will always find a third point. And then when we take a reflection of that point, we can actually define that as addition. So we have the 2 original points, and then we find the third point, and we take a reflection of that, and we can define addition. Yes, we might be more familiar with the kind of addition of 2 plus 3 equals 5, but actually these points act in the same way. We can say 2 plus 3 equals 5, but just as well 3 plus 2 equals 5 too. So these points have the same property, which is kind of like pretty cool, at least in my opinion. How this relates to cryptography, though, is that we can actually use this addition in public key cryptography. And if you're not familiar with public key cryptography, I'll give a brief intro. Welcome, everyone. So what is the base of public key cryptography is this issue that we have Alice and Bob that want to communicate with each other. Sorry, those who walked in might just think like, where did I walk into? No worries. We'll get past the mathematics portion in just a bit. So we have Alice and Bob, and they need to send a message to each other. So within public key cryptography, we have a private key that is used to calculate a public key. And then when Bob wants to send a message to Alice, they can use that public key to encrypt that message. And when the message is sent to Alice, then they can use that private key then to decrypt that message. And since we are calculating that public key from the private key, we want that to be as easy as possible. But on the other hand, since the public key is public, we want the reverse to be as difficult as possible. So we want to find this one-way function. And actually using these elliptic curves is one way to define that kind of one-way function. The addition of one point to itself over and over again is super fast, but figuring out what that one point was, having the result, is super difficult. And so this is what I did my thesis on as a mathematician from the mathematic perspective. And well, this actually got me thinking that maybe I noticed that this is used in IT, within security. We have elliptic curve cryptographic algorithms that can be used for encryption, for example. So I thought, oh, right, hey, here's a field I can get into, security. The problem is I had no prior experience in IT. I could use a computer, but the fact is I didn't even know how the internet works. And I am not kidding. I had never thought where a website comes from. It was just magic to me at that point. So I started looking for junior positions in security because I figured, well, I'm not an expert at this yet. And I got to an interview, and I was thinking I am applying for this junior position in security. But the first thing that came out of their mouth when I walked in was that, well, we have already filled that position when I arrived at the interview. But then they continued to explain, but we have this other position open for a junior architect. And well, I really had no idea what an architect does within IT. An architect for most people means building houses, not, designing IT systems. So I was, of course, intrigued, and for some weird reason, they actually thought that I would be a good fit for that position without any background, but they wanted someone with a different kind of background. And with my mathematics background, I was able to present to them that, actually, yeah, I'm pretty good at problem solving. And I think they thought that that might be beneficial in this. So I actually started in a junior architect position, which is kind of a weird junior position to begin with. Mostly we think of architects as very senior people. But anyways, that is where I started. And right away on the first week, I ended up in a meeting where we were talking about a customer. And well, how the meeting went was that there were all these abbreviations flying at me, and I felt like I was listening to a foreign language. So in one browser, I had Google open, and I was Googling frantically and trying to figure out, what are they talking about? And, well, the funny thing is also that, at least in Finnish, they sometimes use the same abbreviations for different things, which makes it so much easier. And they say VLAN for VLAN and WLAN, and they are a bit different anyways. So I got some of my Googling a little wrong as well. But I started to kind of figure out, okay, there's these topics relating to networking, there's these topics relating to compute and so forth. I started to get a bit of a sense of okay, there's these different concepts flying around. Even though I was still quite a bit confused for quite some time, I have to say. And at this point, well, I was at the verge of all this unknown, all this that I had no idea how it all worked. And what I really had to focus on is remembering that improvement is possible. It is possible for me to learn. And you might not be facing such a completely new area, but just facing a kind of a new focus area or just new information. It is really good for us to remember that, hey, we've been able to learn things in the past. So that's kind of proof that, yes, we can learn them in the future as well. And this is actually often nowadays referred to as having a growth mindset. Having this idea that, yes, it is possible for us to grow, it is possible for us to improve, and it is possible for us to get better. And keeping this in mind with so much unknowns, well, it was really helpful because it gave me hope that I will start making sense out of all this and not just be faced with all these difficult things all the time. On the other hand, if I had gotten stuck in the fixed mindset of, well, there's so many things I don't know, and just focus on that, it would have been much, much more difficult for me to keep learning because that also blocks me. And since I do have my background in the teaching side, it is kind of interesting because I have learned a lot of background knowledge about teaching as well, and learning. And it's not that I've always kind of consciously thought about these things, but since I've learned about them, I've kind of picked up the habits as I've gone forward in my career. And so it was natural for me to stay in this growth mindset and remember that improvement is possible. But it might not always be the case. So sometimes we might need to remind ourselves that, yes, this is possible. So this has kind of carried on with me over all the years that I've been in IT, and especially in the very first weeks and months that I was working. And one of the first tasks that I was tasked with was drawing a customer's entire IT infrastructure out. So their data center environment at a high level, firewalls, servers, etc., all the networks that connect to different offices, and how is the cloud in use? There was some Azure AD and Office 365 in use as well. And then how do remote workers connect to the networks too? And this was such a great learning experience for myself. I think it was a bit of a coincidence that this happened to be the first thing that I did. But what this enabled me to do is to really kind of map out the big picture of everything. How do these things link together? And this is what enabled me to take all those abbreviations and kind of figure out where do they fit in all this. And if we look at the educational psychology side, there is actually a theory that all our information kind of links to the past information that we have gathered. So if we're stepping into something completely new, we need some kind of basics first, because otherwise the information doesn't have anything to grow onto. And the same thing if you're directing to just a new area. You first need to kind of get the basic information, the premises that you need to know. Then you'll be able to go into the details of the different areas. Also, what this enabled me to do is that now that I started to have this big picture in my mind, it then enabled me to start figuring out, well, where do I want to dig into next? And the fact is, there's so much in IT. There's the infrastructure side, there are a lot of data topics, as we've been learning today. So how do I choose where I go? Well, first I was kind of going a bit randomly and deciding that, well, I need to first know about these major topics like networking and virtualization and things like that. And, well, I've been pretty okay at reading as well and pick up information from that. And I read this massive, I think, 700-page book on TCP/IP. Yes, it was a bit dry, to be honest, but I did read it. Actually, I don't think I read the very last chapters, but it allowed me to understand networking much, much more. I also looked into virtualization and how we have a physical server and we can run virtual machines on that. And with this one, I had a bit of a hard time because I'm a person who needs to understand how does it work? How does this hypervisor thing virtualize the resources to these virtual machines? How does it work? And I'm still convinced that it is magic. I haven't quite figured it out yet. But it is, of course, software, and that software enables you to virtualize those resources to the virtual machines. But yes, it still feels a bit like magic. And there has been these many points where I've felt that my brain has just melted, just like, I cannot grasp this. But that is sometimes what is required for us to accumulate new information, to kind of restructure how we think that no, not everything is physical. There's also this virtualization aspect that is present there as well. But after I started getting some of these basic concepts and understanding these basic topics that are relevant in whatever we do, I started kind of figuring out, like, where do I go next? And I think this was something that I did a little unintentionally. I just followed what interested me, or I followed the joy. So I just went where my mind was like, ooh, that's interesting. And on the other hand, I'm a very logical person. So I try to make very logical progressions to things like, yes, I learn virtual machines, and then I need to learn about VMware, et cetera, and so forth. But when I was kind of looking at when have I been successful, it is not the times that I have followed a logical progression. It is the times that I have followed something that I'm really interested in and that makes me excited. And I think we've lost a bit the value of this in our world because we are not encouraged to be, do what we really, really enjoy. We should be logical. We should do what is the most beneficial. But there is actually a lot of value to this because this is necessary, in essence, talking about internal motivation. And time and again, this has been in the learning side of things been figured out that the best way we can learn is when we have internal motivation. And that is emphasizing the fact that we actually enjoy the process of doing something, of learning about something, of working with something in itself. We don't need any external rewards or anything like that. The process itself is rewarding. We can, of course, also have external motivations. We might get a bonus if we do a certification, for example, or other kinds of rewards as well. But the internal motivation is something that will keep us learning in the long term, not just in the short term. So it is actually something that we should nurture. We should kind of let go of those ideas that work shouldn't be fun. I think we should enjoy work. We spend a lot of time there. And we might even have been told that, well, you shouldn't follow like your passion. I'm not one, actually, I'm not the one who is very easily following their passion. It hasn't been easy for me, but somehow I find the area where I really kind of light up. If you hear me talk about networking, you might want to run away. I might get a little too excited about that topic. But this is kind of the thing that will keep us going because there's a lot to learn all the time as well. So we want to keep it fun and we want to focus on the areas that are really relevant and resonate with us. And even if I look back at my studies, like I studied a whole lot of random things. I studied physics, chemistry, psychology, pedagogical studies for the teaching, math, a little bit of coding, etc. But it wasn't logical. But it has all actually been useful in my current career, even though it has nothing to do with IT. So you never know how those random detours might benefit you in the future. You will find out at some point. Sorry. So where actually this joy part took me personally is that I started to get into Azure. I saw this coming across when I was talking to customers, and I was like, oh, this is interesting. I want to find out more about this. In a later point, the joy took me to exploring data topics. And that is where I started to find connections with my mathematics background. And the most recently, that has led me to DevOps as well. I have just always followed what I really like to do. And all the previous paths have actually benefited me in a later point too, so it has never gone to waste. So I started exploring Azure in the beginning, and of course, in Azure, there are many things to learn. The more I learned about Azure, the more I started to think, wow, this is actually pretty cool. I learned about the virtual networking, and actually figuring out networking on premises before that helped me pick up that part too. I learned about virtual machines, databases, and different data services in Azure, and for example, things like web apps and other PaaS services that are available in Azure. And I approach it the same way. I first learned kind of the overview of everything you can find in Azure before I started to go into the details specifically. So the nice thing about where I started my work with, other than, well, I started to look from the big picture first, kind of naturally without having to go there. But on the other hand, I was working as a consultant. That means that I was talking with customers all the time. So as I was learning about Azure, even though my specific projects were not necessarily about Azure at that point, I was always able to kind of bring that information right away to my projects and say, hey, maybe this thing could maybe from Azure help you in your project too. And have you thought that maybe this particular aspect you could move to Azure in the future? So right away, I got to go and explain about the concepts that I learned and try to implement them in practice, even though I wasn't yet working very much hands-on at that point. So essentially what happened to me was that I got to teach what I had learned. And there is actually a lot of, a lot of benefits behind this. And it is known as a very efficient method to boost your learning. There are many variations along the years that have been introduced about this particular method. And one of them came from Richard Feynman, which is a physicist that won a Nobel Prize from the 1900s. And his method approached this in the way that, well, choose your topic that you're going to explain and pretend that you're explaining it to a kid. You don't actually have to explain it to a kid, but pretend. Make your explanation, figure out where are the gaps in your explanation, and then improve that explanation again. Make it even more simple to understand. And this is what I was trying to do with my first example of elliptic curve cryptography. Did you manage to pick up anything from that? I see some nods, maybe. So it's actually a very beneficial skill to be able to explain what we do in very simple terms. To a child, to maybe a business owner that might need a little bit of simplifying the technical terms. And it's just a very useful skill to have. But what you might not have thought about is that this is actually what happens also when you are rubber ducking. You are explaining your topic to somebody else, and well, suddenly it just kind of clears up to you. Like, how does this all work? It's interesting. It just happens. They don't even necessarily have to ask you any questions or answer anything. It just clicks. Or this could be happening over a cup of coffee when your relatives ask, so what do you do for work? And then you think, like, how do I explain what I do, like in practical terms? Exactly. But of course, if you are in a position that you can train others, it is a fantastic way to also teach yourself. And why is that? Well, when you are preparing to teach others, you are actually paying more attention to what are the main points you need to get across. How do different topics link together? It just forces you to process the information further than if you're just learning it for yourself. So this is why it's such an efficient method to learn yourself in a faster way, but it is also a method in which you can benefit others on the go as well. So it's a win-win, I would say. So especially with this part of teaching others, I noticed that, wait, my previous background kind of helps. I had been teaching a lot of mathematics while I was studying, doing substituting, and well, that was really helpful. I already had been practicing, like, how do I make my points clear? How do I time things? how do I make sure that whoever's listening can kind of think about the topic themselves and not just give a fully chewed answer, I found that, well, that actually is really helpful in this IT world, as being a consultant, as in talking with others in an informal way. It kind of, for me at least, it kind of links to everything. I also realized that, well, I've always loved puzzles, and that's kind of what mathematics was for me too. It was about finding very exact methods for solving a problem. You need to identify the relevant information, find the requirements, and then go from point A to B in a very logical way. And what I found is that in architecture design, whether it was for hybrid environments or later when I started working with Azure, I found that this problem-solving skills that I already had accumulated from mathematics, they started to come in really useful. And the thing is, I didn't have to think about it because it's just kind of, that's how I approach things. I could just use that skill that I had already accumulated from mathematics right away. And then kind of the third aspect that I noticed is that I like drawing, as you might notice. So whenever I talked with my customers, I would take out a whiteboard when we were in person, like an actual whiteboard, and draw on it, and then we could actually point at things and say, is this actually what you mean, or do you mean this one? And that really made the communication easier, and we could proceed in a much concise way, in the way that we're not taking as many missteps, because we're actually talking about the same thing. And about how many years back? 2 years back, a little more, before COVID started, there's Alexander who got me into speaking. It wasn't something that I had thought about, really, because I never thought I was charismatic enough for speaking, or that I had the right skills for speaking, or anything like that. I somehow thought it's very different to speak in public than teach a class, or I don't know. But anyways, I had this mindset that, well, that's not for me. But somehow I got convinced. I think it did happen rather easily, but I don't know. Can't remember. Oh no, oh never mind. It wasn't easy, okay. So when I started to prepare for speaking, I realized that I think I can still use these same skills for speaking too. And I decided to take the drawing there as well. And here's my very first slide that I created. I don't think it's the first slide, but presentation. I decided that I want to keep the drawing. It's kind of how I process things in my mind, so it's kind of natural to just share that process with others. But, you know, it's okay, but it wasn't perfect quite yet. But I knew, again, I kind of had to keep returning myself to the aspect. Remember, you can improve. You don't need to be perfect yet. You can just take one step at a time and get better. And so, whatever you go into your career, make sure that you actually take the skills that you already have and use those to your benefit. I did that just starting in IT. I took all the skills I had from my previous life and I used those to my benefit. But also when I decided that I would start speaking, I decided I would carry those over in that arena as well. And I still use all of those every day, I have to say. So for me, I think my existing skills are kind of easy to see how they link, but it might not always be as easy to see. And the thing is that we might also have been told that our existing skills aren't actually beneficial for us in our position right now. I have heard this said by many people that, well, my old background is not beneficial here. But whatever your background is, that is what brings your point of view. So it will be beneficial to somebody to have that. And for example, if you have experience in let's say retail. This is a sample of somebody I know. And you go into building reporting systems. That will definitely carry over and that will be of benefit. Because we need also the business knowledge. We need to know what we need. So if you have that kind of background, for example, it would be very beneficial to leverage. But whatever your background is, you can always find the benefit that you can use right now. I've always thought, like, trying to figure out what are the past skills that I've used kind of after the fact, looking at it. And I even realized I've done a lot of like competitive sports when I was growing up. And I was thinking like, well, I don't think I've used that to any benefit. But I do think that that actually brings a lot of the goal setting and being able to handle difficulties on the way and, you know, having to reset like, oh, it didn't go to plan, as sometimes happens. And just kind of being able to find your own path and stick to it even when things don't go the right way in that way. And also actually that's where I've learned, you know, calming yourself down when you're a bit nervous, which is very useful for speaking. So I personally just kept on going with using my existing skills. I've been now speaking for the duration of the COVID time, and after COVID, I've gone to actually present in person as well, which is nice to have actual faces in the audience. And what I've kept doing with my presentations for my speaking too is to just run with it, to keep improving what I do. This is, for example, from one of my more recent technical sessions that I do on networking and configuring private endpoints for your data services. And I've just taken it up a notch, and every single presentation I do, I just keep improving my slides one bit at a time. And that brings me to kind of the last portion that I want to remind you of. I think in the IT industry, we kind of slide into this illusion that we should be able to handle everything. But there is so many topics that we can cover. So we should remember that perfection is a bit of an illusion. Sorry to say that. But it is. Every single time I speak, I find something that I can improve on. It doesn't mean that I sucked or anything like that. It just means there's something to improve on. And on the other hand, I can be have a bit of compassion for myself, I guess. I don't need to be perfect. I can just do my best and improve one step at a time. And the fact is that we're gonna run into mistakes. We're gonna make mistakes on the way. And it is kind of helpful to remember that we do not have to be perfect. And actually what we can take away from those mistakes is to learn from it, to make sure that in the future we do better. And we can even take that and teach others of that mistake that we did, and even benefit others in that way too. And something that I've had to remind myself of regarding this particular topic is also that uncomfort is okay. Because, to be honest, it is not entirely comfortable talking about myself for an hour to strangers. I'm a bit Finnish in that way, even though in other senses I'm not so Finnish, I've been told. But it's okay. That's just telling you that you are doing something that you haven't been doing before. It's telling that you are taking a step outside of your comfort zone. And that is also what will help us improve, because we are challenging ourselves. So we can even kind of relax in the uncomfort and be okay with it, and even get comfortable with being uncomfortable. So it's just a feeling. It'll pass. We'll get through the speech or whatever else situation it is that is making us uncomfortable. Another very useful trick for if you feel like you need to be perfect and know everything is to join a community. Because what that does is that you get to know people who know about other topics that you don't know about. So that means that even if you don't know about something, you can go to all the other people that are around you and go pick their brain, ask questions, and find solutions for the things that you do not know yet. And so for me, that has been a really big influence in being able to be, okay, actually, I don't need to know this. I can go and ask one of the other people for this particular theme because I know they know all the details about it. And if you think about the whole arena of IT and even just the data field, there is so many topics that you can specialize in, whether it's reporting, relational databases, data lakes, etc. So it's impossible to know everything in detail. So it's better to find your focus area that you really enjoy and dig deep there, and then use the other people around you for the areas where you might need some support. So I personally did my path from mathematics to IT. And as I said, I went first to infrastructure and architecture. Then I kind of started to wander towards Azure. Then I found the data side of things. And what happened is I actually took all the architecture and infrastructure side and just brought it with me. That is why I talk about networking, authentication, all the very juicy and hot topics out there. And even as the latest part, I've moved more towards DevOps. So I've started to talk about infrastructure as code, about deployments, and that all can come together with the data side of things as well. So you might not be looking at this kind of a drastic shift from a completely different career to another. You might just be trying to look for ways for how do you keep up to date, because the fact is, especially in Azure, everything is changing all the time. A lot of the technologies that we work with, the change is just really, really fast. So we need to find ways in which we can actually approach that efficiently, but also we should enjoy the process as well. So what I shared with you today, kind of on the way with my story, is 3 practical things that you can do to make that process easier for you. And so the first is to really find the big picture, because that will enable you to go into the details. It can also even give you almost like a map of everything there is within the data field, and then whenever you hear new information, that can find its own place on that map and kind of fit in with the rest. And that way it is much easier to figure out how is everything connected, how does it relate to what you do, is it something you should be going deeper into, or is it just something that is good to know? And with finding the big picture, that is what also allows you to determine which way should you go. Because if you don't know about things that are out there, well, you won't know if there's something that you are really interested in. So it can also help you find where to dive in next. Then, one method that you can really use to boost your learning is to teach others. And find your own way to do this. It doesn't necessarily need to be public speaking and sharing your experiences with others in that way, but it can be just talking with colleagues over coffee very casually and sharing what you learned that day. And at least to me, it has seemed that there has been a little more kind of emphasis towards this in many companies. There might be knowledge sharing sessions or something like that where people can share their learnings. And so if there is that opportunity possible for you, I encourage you to take it. It can be a little nerve-wracking and challenging, but it is also a great process for you to see where might your gaps be, what do you need to learn more about, and it will really make your understanding of the topic much deeper. Because at least for me, when I research for a topic and I'm preparing a session, I kind of want to know much more than the actual points that I'm making, because I also don't know what the audience will ask from me. So I also want to have the answers ready in that sense too. And thirdly, make sure that you use your existing skills. Whatever your background is, you will find something to use. Whether it is, I don't know, dancing, that will help in your use of your body language, for example. Whether it's sports, mathematics, whatever your background might be, you will be able to find some skills that will benefit you. And they might not always be obvious, so you might need to dig a bit to find what that is. And you might want to ask somebody to kind of spar with you a bit, like, how can I use this? I don't see how this is of benefit. And even if you've been told that some of your past experience is not beneficial, remember that you can always find that benefit there. So to me, these are more things that you can do, like in a practical sense. But the fact is that our learning is very much affected by our mental state too. In the learning sciences, there's a lot of emphasis on what is our motivation, how do we view the problem, how do we see the world. There's always a subject that is learning about something, and our internal experience actually affects a lot how that learning process goes. It can either bring us down, or it can lift us up and take us to the next step. And so I still want to highlight also these 3 items that I presented to you during my story as well. So whenever you're learning about something, remember that improvement is possible. We might have built-in kind of restrictions for ourselves. We might think that we're not good in math. We might think that some topics are not for us. And if we believe that, that is actually what will prevent us from learning that. It's not easy to kind of unravel those, but we can start from just reminding ourselves and paying attention to where we have been able to improve in the past, and just see that. And then we can use that as proof for ourselves that yes, it is possible to improve, and we can learn something new. And by emphasizing this growth mindset, we are able to really learn without restrictions. Because the fact is, we all have some restrictions for ourselves, and if we focus on letting those go a bit, it will become easier. We should also follow what makes us joyful. We should follow the joy. It came to my mind that some of you might be familiar with this writer Maria Kondo, who wrote a book about organization and what stuff to keep, that you should only keep things that spark joy for you. So it's a bit of the same thing. Like, if you don't want to keep things in your house that do not spark joy, so why should we be working with something in our life that doesn't spark joy for us? We spend so much time at work that it doesn't make sense to be excited about what you do. And I didn't get this right the first time because, well, all the time when I was studying mathematics, I knew I wasn't going to become a teacher. That did not really make me excited. But still, I did it and I finished it. I could have maybe done some actions earlier. But still, I do feel I've benefited from what I learned from there as well. But I wasn't definitely following the joy at that point. But what we can do is really find the things that make us excited, because that will keep us also consistently improving and wanting to work for the things that we do in daily life. Keep in mind that those things can change over time. It doesn't mean that if we find one thing, we should stick with it forever. It probably is going to change over the years, the different themes that we want to emphasize, and it can also make us kind of keep an interesting path through our career. On the other hand, since IT is so fast, the data field is so fast, this can also help us focus on a specific area that really makes us excited. And remember that perfection is an illusion. We don't need to aim for that. We just need to aim for improving day by day. That's all we need to do. We don't have to, put ourselves down if we make a mistake. It's kind of part of the process. We can learn from those, and we can even share those. So remember that we can just take one step at a time and just improve day by day. And even when I say improve day by day, you don't have to stress about it. Just take one step at a time and go with the process. And by following these 6 points, 3 that are more on the practical level and 3 that are more about mindset, this is how I got from a mathematician to where I am now. And I can't pretend and say that, well, this was like I had a checklist and I followed these 6 points in that way. It is more that what I have noticed after the fact, now that I've looked at the process and I'm here 6 years later, after having no idea what I was going to do with my life and ending up doing quite many cool things. And it has required me to be uncomfortable at times. I have done many things that I've been uncomfortable with, starting with speaking, starting with joining a podcast, and, talking about myself for an hour, and many other things as well, actually. But it has, all those points that have been a little uncomfortable have also been very rewarding for me, because then you have this sense of, I have overcome myself, and it can really feel good and give you more enthusiasm for the future. So, I'm very excited to see myself where my next 6 years can take me, and I hope that this session has really encouraged you to go for whatever direction you want to go in next in your career. I hope that you will leave some session feedback for me. I'm just getting started on these soft topics, so anything that I can improve, please let me know. And please also leave some event feedback. If you weren't here for the welcome session, they will raffle a prize at the end. You can win some Legos, so that's exciting. So remember to put some feedback in for me and the other sessions that you view. And other than that, thank you so much. You can find me on Twitter and also LinkedIn. Thank you for joining. And as the last bit, lunch will be served on the second and the third floor, so you don't have to crowd into just one floor. Thank you so much.
We good to go? Yeah. Hi, everyone. My name is Shane. I'm the lead data scientist at Linus Health. Before I start today, I'll just mention the sponsors. So as mentioned earlier, it's very important that we give credit to these sponsors and that we visit the stands. This event wouldn't be able to happen without them, and we're all very grateful for free coffee, free lunch, and good talks, hopefully. So thanks very much to all the sponsors. Today, I'm going to talk about some of the work that me and my colleagues at Linus Health have been doing to use AI to improve outcomes for COPD patients, so chronic obstructive pulmonary disease. This is a disease which is particularly prevalent in the west of Scotland and in Glasgow in particular. So it's a very progressive illness, and it's one which, where possible, we want to try improve outcomes as much as we can to improve the well-being of the patients. I'll start by telling you a bit about Linus Health, a bit about the kind of context behind why companies like Linus Health are needed, and the change that is coming in the near future, particularly with healthcare. And from that, I'll move on to some kind of more data science related examples that we've been working on. So Linus Health is a digital healthcare company. We're based in Leith in Edinburgh. We were spun out of Storm ID, which is a award-winning consultancy who do a lot of work with the NHS. A lot of that work has since moved to Linus Health. So I joined Storm about 3 years ago, and when the two companies split, I moved to Linus Health as that was the focus of my work. One of our main offerings is the Linus Health platform. So what this does, as it says on the slide, it combines patient-generated health data. So this could be from smartphones, from wearable devices, the likes of Fitbit, Garmin, Apple Watch, with medical devices, so more condition-specific medical devices, along with data that's already held in clinical systems, so traditional EHR data. It's a common data platform which enables a lot of things, so virtual care, long-term management, and what's really key here is that clinicians can come in and they don't need to open up 10 different systems to look at the history of a patient. Everything they need relative for that specific condition is there and surfaced. Some of the stuff which I'm going to get onto towards the end of the talk, this platform enables the deployment of AI solutions, so AI or non-AI type models that might be needed for clinical workflows, and it has been proven at scale in the NHS. We currently have about 14 services across different condition types, and it was also involved in or underpinning the Test and Protect COVID-19 response. This is a nice schematic someone's put together on what the kind of platform looks like. What's key with a lot of this work is the patient is always at the center. So we can see here, as I just described, data is surfaced from multiple different points and can all be viewed in a clinical dashboard by the clinical team, whoever that may be. So here we have an infrastructure layer, a secure analytics layer, and then the service layer. So this is a very high-level overview of the Linus platform. In terms of some emerging context for why the likes of Linus Health is needed, I guess a lot of us over the last couple of years with COVID have seen big changes to how we work or how we go about our day-to-day lives. And that change has been happening in the healthcare sector as well. It was happening before COVID, but a lot of things have been accelerated because of that. So some key points here. The center of gravity of healthcare data is shifting. Traditionally, data would be collected maybe at certain points of care, but now we have data coming from lots of places, wearable devices, at-home sensors, to name but a few. What it's going to do is it's going to lead to a much richer and better capability in terms of diagnostic tooling than we have had in the past or than clinicians have had in the past. Another one of the focuses here is from moving care from the acute setting into the community to make it more manageable and better outcomes for the patient. Some challenges here, and this is always a challenge, is breaking down barriers between care institutes, funding streams, and data owners to deliver this joined-up holistic view. One of the main goals is diagnosis of long-term conditions early and then managing patients with those conditions. So just to summarise, the businessy slides. The big opportunity we have here is for advanced data analysis and machine learning. The goal or the objective of these models is to identify and risk stratify patients. So the likes of this would be for diagnosis or for patients who are already diagnosed with a long-term condition. How can we tell how they're doing on that pathway? So, for example, a patient might have COPD, but how do we know how severe that COPD is? So are we able to use AI to stratify where they are, to cluster them, for example? Big advantages of this to all of us is to improve efficiencies within the NHS, reducing bottlenecks, enhancing therapies or pharmaceuticals, so a patient who may not necessarily be on the right therapy. This work also aims to really target them there. And then bringing in third-party devices, so medical devices, point-of-care testing, at-home wearables, and being able to, again, surface that data, with the goal here being to improve the health outcomes for the patients. So I'll talk now about the COPD use case, and this will lead on then to our data science work. This is one of the first conditions that we kind of focused on. This service was built in collaboration with clinicians in GGC, so Greater Glasgow and Clyde. And what this service was, or what the service is an app that the patients interact with daily. So the patients answer questions about their COPD symptoms. So it's quite rich information that comes out of this. It is very detailed. They answer that daily. It also has two-way messaging. So it's asynchronous in that the patient might send a message, the clinician can pick it up the next day, pick it up the following day, but it's not that conversation is lost or that appointment is lost. It also integrates wearable devices. So this particular version integrates Fitbit and home NIV, so that's the ResMed device you see on the right-hand side. From the Linus platform then, other electronic health record data is surfaced, and that's the kind of clinician dashboard you see on the kind of tablet, iPad view. So this is the COPD service. It's been rolled out since 2019, and this was the kind of, I guess, the first interaction the company had with data. So the use case here then was what's known as the receiver trial. Initially, 83 COPD patients from GGC were onboarded to the service. So that's the service I just described. So they answered daily pro questions about, there's a lot of them just about general well-being, how their breathing is, some that are more related, very specific to the condition itself, and that's all captured and surfaced. Again, the two-way messaging, and what's kind of quite important here then is around the events. So patient events here being hospital admissions, or if you have COPD, what's known as an exacerbation. So that's where you have a big flare-up of your condition. The ultimate goal with all of the work that we might do here is to try and reduce exacerbations. As I said, it is a progressive disease, but every time a patient exacerbates, it kind of knocks them down a step. So that's the kind of, the long-term outcome of this. So this went on for a couple of years, and, things looked to be quite successful, which they were, but we needed a way to quantify this. Unfortunately, in terms of, a data analysis approach, this kind of occurred during COVID, so it's quite hard to determine what effect did this service have, if any. So the approach taken here was to retrospectively analyse the results. So what the team did was they came up with 5 matches per patient from the wider GGC cohort, and these were matched by age and sex, so all matched by sex, and then as closely as possible by age, to find suitable controls. And what the team then did was to compare outcomes in a year previous to being on the COPD service and in the year following, just to kind of, as it wasn't a randomized controlled trial, but it's a way to mitigate this effect of COVID, to say how good was this service. So this is one of the outputs from that. So if we look on the left-hand side, or the left-hand side of the figure, that's the control group that I just described. So these are the 5 matches per patient, 405 or so. And on the right-hand side is the receiver group, so this original 83 patients who were onboarded. As you see across both groups, there is a reduction in admissions. This is the kind of COVID effect. Everyone was trying to stay out of hospital during COVID unless you had COVID. So this is the kind of effect we were seeing. But if you look at the difference between the two groups, in the control group, there was a mean reduction in days spent in hospital of 3.78 versus our receiver group of 8.31. So quite a significant difference. Scaling this up a bit then, just on the right-hand side, we see 4.5. Okay, so this is, the figure on the left is just for the receiver group. If I just go back one slide previous, we can see then there's this receiver plus dynamic Scott. They're ones who are onboarded a bit later. So the overall savings were 4.5 annual bed days per patient when you look at both groups, which is a 54% or equivalent to a 54% reduction in admissions. So this has, it clearly showed its benefit. Summarising more of these trial outputs, there was improved survival. So in terms of survival, we're looking at time to an event being death or admission. So that was good. Reduced admissions, very important for COPD. So that was seen, as shown previously. There was some other outputs from this, which I won't get into as much, but we have stable quality of life. That's a measure that can be captured from EQ5D questions, which are answered through this app. Efficiency, one of the main ones in terms of clinical workload. It was kind of proven to be very efficient. Clinicians could see more patients. Another effect of the reduced admissions is the CO2 aspect of this. For the scaling this up to 500 patients and assuming 70% of journeys to the hospital are made by car, this is the equivalent emissions of driving 700,000 kilometres. So it is a nice saving from an environmental viewpoint also. And a big one then for the NHS is cost savings. So as well as the benefits to the patient, which again is the most important here, but for cost savings, this is equivalent to over £3 million for this 500 patients. That's the kind of savings where this scaled up. So from all this, this kind of motivated, this is just from the service. This isn't without any AI. This is patients being more engaged, patients being more aware of their condition, clinicians being able to see all that data, and clinicians being able to identify this patient's deteriorating, we should check in here. So this had nothing to do with AI or ML, but then the opportunity did present itself from this. So the question then was, can we do more of this data to again improve the outcomes for the patients? So that's where this opportunity to use AI came into play. So the COPD service generates a huge amount of very valuable structured data. So the data I described around the patient pros, patients or data around wearables, and what's kind of very important there is clinician verified events. So in this type of space, trying to pinpoint when, let's say, an exacerbation event actually occurred is quite challenging. So the fact that this was verified through the service from a modelling point of view is very important. These data were complemented then using linked patient EHR. So I'll talk a bit more about the data on the next slide. And then for the COPD use case, some initial models were identified by our clinical team as ones that would be of use. So the ones that we looked at were predicting 12-month mortality all cause in COPD patients, predicting 3-month respiratory-related hospital readmission risk. So this one, again, is quite important. It's one that you would be able to act on either by increasing therapies or sending patients home with a device to monitor them more closely, and then exacerbation prediction. So that's in, trying to predict within a week or that kind of time frame when a patient's condition is going to flare up. And again, the idea of that is that the clinician can check in with them and say, it doesn't look like you're doing too good, or how are you feeling? Maybe you need to take your rescue medication. The data we had available to us, so I've described some of this already, the PROS data. Along with the service also comes COPD status data. This includes a lot of really rich information around a patient's lung function, smoking status, marital status, quite good information. The wearable device data, so from Fitbit, we got that intraday granular data, so we had it down to 2-minute frequency. From this, we got activity, sleep, and heart rate. Home NIV data, so that measures high-frequency respiratory events. So ResMed was the device that was integrated here. And demographics data also came through the COPD service as well. So that's patients' age, their gender, ethnicity, and things like deprivation index. And then the other data sets are ones which are linked. So we have laboratory, so any lab test a patient's ever had. Similarly for prescriptions, the prescribing data set, hospital admissions, and comorbidities. As with all data science problem, the kind of standard steps we had to go through. So data cleaning, feature engineering, transformation. As you might expect with healthcare data, there's a lot of data cleaning. There's a lot of, it's not in a very usable format when you first get it, so there was a lot that had to be done there. A lot of that in collaboration with the clinicians and with the data owners, as it is quite challenging data. Some of the feature engineering techniques, just to mention, again, quite standard, one-hot encoding and k-fold target encoding for categorical variables. If you think of that data set, I mentioned prescribing has thousands of unique drug codes. So from a modeling point of view, how do you handle that? You're not going to look to one-hot encoder, so something like target encoding may be needed. Some simple aggregations, data scaling and imputation methods, and then what probably is most important here is domain-driven feature engineering. So this is really from the data science team and others at Linus sitting down with our clinical team, and as well as that consulting literature and saying what is important for this use case, or what do you think is important. So I'll describe two of the models, the first two, and from that then I'll kind of talk about some general challenges in AI, but with, I guess, a specific focus on healthcare. In terms of 12-month mortality, we had the advantage here that we could use the linked data set, which was a very sizable data set. So the service data was not used for this model. The service data was used for the exacerbation prediction model, but for these first two models, it was linked electronic health record data. So for this model, we had data from 46,000 patients, so quite a good data set. 39,000 was selected for training and validation, and 7,000 was held back for an evaluation test data set at the end of the project. The team were investigating data drift and concept drift, and the decision was made to censor data previous to 2013 for recency, and we went up as far as COVID, basically here. This problem was modelled as a binary classification problem, so 0 the patients survived the following 12 months, 1 they did not. It was quite a high class imbalance, 93% to 7. And then in terms of the feature engineering, so this process went on for quite a while. It was iterative. It wasn't. It took several months to a year for this process. We came up with about 150 features derived from that EHR-related data, and the final model today is using 80, so the one that is in production. XGBoost was selected as the classification algorithm of choice, and the model was then tuned for the clinical use case. So I'll discuss that a bit more in the next slide or two. In terms of model performance, so here we presented the area under the ROC curve and the area under the precision recall curve. Quite important here, particularly with such a high class imbalance, that you show both curves. More often than not, you only see the curve on the left of the inflated metrics, or you might see someone reporting on accuracy. This kind of all comes, I guess, down to transparency, which we'll discuss a bit later on, but when evaluating these kind of systems, you need to look at every metric possible. For this kind of imbalance, you would expect a relatively low area under the precision recall curve, but we're quite happy with these numbers. The model is very performant compared to any similar work. In terms of our clinical use case, though, if you think of the kind of clinical setting where a model like this is being used, the clinicians want to know more than who we're predicting to be alive or deceased. They want to see associated risk with this. So they're not actually looking at that outcome. They're interpreting the model probability output and using that to infer risk. So on the left-hand side is the inference probability distribution for both classes, for the alive and deceased on this holdout test data set. Again, as expected, that 93% class is quite centered around 0, much more of a spread on the deceased, However, the model is still able to discriminate between the two. What's kind of key here then is, if you do want to use this in terms of a risk score and you want to say, okay, I'm going to action patients over 70% risk, what does that actually mean? Does it mean that they have 70% risk? So the figure on the right shows a calibration curve. So what this is saying is, when we say 70% risk, what is the true risk in reality on this holdout test data set? So the green dashed line, the kind of faint line you see there, that would be a perfectly calibrated model. The orange line, which mostly hangs a bit beneath, that's uncalibrated. And the red line is this model after applying calibration techniques. To start off with, it wasn't terribly calibrated, but it could be improved, as you see there, and the model now is well calibrated, meaning that the clinicians can action it as they expect. But then what does that mean for a clinician? So if we look at two different thresholds here, so I'm looking at 0.25 and 0.6. So if you go back to the previous slide on the left, and if you imagine just slicing a vertical line at 0.25, what that's saying then is everyone to the left we're predicting as alive, everyone to the right of that line predicting as deceased, and similarly for 0.6. There's obviously consequences of this, one being the patient and the second being the clinical workload. In terms of the patient, this service as is, so I'll discuss it a bit more later. This is a feasibility study. It's due to launch in the next month, and this is being used alongside regular patient care. So this alone isn't dictating patient care. It's been kind of piloted as feasibility, but these considerations still need to be talked about now. So in terms of the 0.25 threshold, we can see that the model correctly predicts 363 out of every 379 surviving, if you scale the numbers back. But then you have to consider who's incorrectly brought forward. So maybe if you look at the confusion matrix below, actually, that's probably a bit easier to understand. So this is scaled to 100 patients. So we kind of present it this way to the clinicians for them to visualize what a workload would look like and what patients would be missed. So if we look at that top row of the matrix, there are 7 patients who are truly deceased in the following year. The model gets 3 of them correct. If we look at the bottom row, there's 93 patients who are truly alive next year. The model gets 89 correct, incorrectly brings forward 4. So these are the real decisions in terms of workload and the consequences of missing patients, or the consequences of incorrectly telling the patient you have a disease. 0.6 then, we're moving to the other end of the spectrum. So if you look back to the scaled 100 patient matrix, it's bringing no one incorrectly forward as being deceased. So everyone, or as being alive, sorry. But out of the 7 deceased, it only gets 1 right. So they're the kind of balance points that we work with together with clinicians. They specify their needs and we go back or tune our model based on that. Again, this is performance metrics, or a fuller picture of performance metrics for different thresholds. So again, your performance, obviously your ROC, AOC, PRAC won't change with varying thresholds, but your other metrics will. Brier loss is a measure of how well calibrated a model is, if you're not familiar with that one. Okay, so I'll discuss a bit on the 3-month model, and then I'll go into kind of the biases that we've encountered. This is very similar to the previous model in that it was developed with EHR data. This one uses slightly less number of patients. 31,000 patients were used here, 26 for training, 5 for testing. And again, the same time period was chosen. This is a much more balanced problem. So this is no readmission. So 66% to 34%. 150 or over 150 features were derived from this data. The final model uses 84. And again, XGBoost was selected. Again, reporting on the 2 performance metrics here. We're quite happy with the results. The clinicians have deemed it clinically useful. That's always important with this work as well. And then in terms of the inference probabilities here, so I guess in this case the key difference is there is better separation between the 2 classes, as expected. There's lots of factors that are going to influence how well separated these probabilities are, but being more balanced helps, and the better your model obviously as well helps. Similarly here, the model, in the lower regions it wasn't that well calibrated. After calibration, that's corrected, it's still not perfectly calibrated when you look in the higher regions. So again, these are things just to call out to our clinical team, even when they action on this. So this, again, is kind of presenting where the clinicians to action at a 50% risk, a 25% risk, a 75% risk. What would that look like for the patients, and what would that look like for them? So you can see the dashed kind of vertical lines describing that. So again, the 25% vertical line, the first one you see, that's saying everyone to the left of that will not readmit, everyone to the right will readmit. The extreme line then on the right, 0.75, that's saying everyone to the left will not readmit, everyone to the right will. And you can see visually how it's capturing much more people. In terms of looking at the scaled back 100 confusion matrices, so if we look at the 0.25 threshold, so out of 34 patients, it gets 27 right as readmitting, and then out of 66 patients, it gets 32 right as not readmitting. So that's your kind of trade-off there. If you move extreme to where we capture all patients that do readmit, we only get 4 out of 35, but we're not incorrectly bringing anyone forward. So again, these are just the different clinical use cases that have to be considered, and then the consequences of that. So, you know, what I'd say now is, as far as I've kind of shown there in terms of 2 models, that's just the beginning in terms of how you should evaluate a model, especially one that's used in a healthcare setting. So in terms of ethical AI, this process does happen at the start, but I think it's good to kind of take check now. You know, there's this big trade-off between performance, explainability, and fairness. You know, traditionally in the past, if you look at maybe like a decision tree classifier, I think everyone would be able to understand the decision that you make by following a decision tree. If you take something like a neural network, deep learning, you're not going to be able to follow anything from the output of that model. Maybe things like random forest and XGBoost might be somewhere in the middle, but they're still not explainable, they're not inherently interpretable. So there's always this kind of balance between those three, and how do you get it right? And that really depends on the setting as well. So something like AI being used in the justice sector or healthcare settings, they are both very high risk. In that we need a performant model, but we also need one that's quite explainable or quite interpretable. You know, this all feeds into developing AI ethically. There's lots of principles you can look to follow, so I've listed a few of them there. There's self-assessment frameworks you can check against, so you can assess the work you've done to see, have you developed this ethically? And you know, I think a draft framework was published in the last couple of weeks. There will be something that you can formally assess against. The key principles which we've, as a company, pulled out of this is transparency, fairness, and do no harm. So I'll talk about some of these challenges. I'll give a couple of academic examples, a toy example, and then examples we've seen in our own work in terms of these kind of biases, types of ones you might hear about in the news when you hear about an AI model that's being used for something and it goes wrong. So this is quite an interesting paper, and it kind of describes this explosion in wearable device data and the consequence of it, in that everyone has decided to start building machine learning models without really thinking about, have I done this correctly? One of the key topics it talks about in this paper is the idea of record-wise versus subject-wise or patient-wise validation. So an example of this would be where you have repeated observations for the same individual. You know, I'm trying to see the numbers here. I think it was around 50% of the articles that were surveyed in the study were using the incorrect validation method. So the kind of danger of this, and again, it is very problem specific. There are cases where you can do this, but the danger of this is that the model learns the patient. It doesn't learn anything about the condition. It learns their age, it learns their gender, it learns their postcode, or whatever features might be used in the model. And it's learned that, okay, I've seen this patient before, and it's not capturing anything about the condition. So over half of the papers were incorrectly doing this. And this is just one example of it. And comparing the results of the papers that gave it had much higher accuracies, as expected. Problem with this is it's not going to generalize when you look to apply this somewhere else. This is a really interesting one. This is pneumonia risk prediction study. So what the authors were looking to do was, when a patient presented to hospital with pneumonia, what were your survival chances? So they built a good model. It was quite performant, but one of the key kind of features or the key findings of this model was that if you presented with pneumonia and you had asthma, your survival chances were greater. So if you kind of think about that, does that make sense? Like it doesn't really. So having asthma makes your survival chances greater. So it's, something like that kind of raises a red flag. So I think these authors used Microsoft's Interpret ML framework, which is an inherently explainable model or interpretable model. And what they found was patients who presented with asthma and pneumonia were sent straight to ICU, whereas patients who didn't have it were sent to general care. So that's why they had a greater survival likelihood. But the danger and consequence of that is if you said, okay, got this great model, I'm going to apply it down in England. It was developed in Scotland, but I'll apply it in England, and the hospital doesn't have that care set, and what happens? So there's potentially detrimental impact for the patient. I'll give a toy example to visualize this. This is using real data, but with some kind of artifacts added to it. So I'm just calling this a toy disease prediction model. So it's a model that's looking to predict whether someone has a disease or not. We won't say what it is. It was developed using electronic health record data, so it was developed from real data. And this is, if you look at the right-hand side, is showing some performance metrics for the validation data set, so the kind of internal validation. And you can see it's a really performant model. It looks great. We dig into it a bit more. We look at some model explainability. So that figure on the right is a SHAP global model explainability plot. Again, it looks really good. The features, we look at them, they look okay. The top feature coming out is a patient's BMI, which, in a lot of cases is a strong indicator of disease. So, happy days, you think, okay, I've got a good model, I'll deploy it somewhere. So what happens with this use case now when we evaluate it on a holdout test data set? So this is a data set drawn from a different population. We can see a massive drop in model performance. So this model did not generalize some new data. Okay, I've said what the disease was there. Okay, so it's osteoporosis prediction. Again, this is a fake model. So it just hasn't done well on this data set. If we dig into the data a bit more, and we see why was this the case. So again, this is just another view of a SHAP summary global model plot. In this instance, if you're not familiar with these plots, red indicate high numerical feature value, blue indicate low. If it pushes to the right of that vertical line at 0, that means it's pushing you towards disease. If it pushes to the left, it's pushing you towards no disease in terms of a model decision. Grey means missing values. So what's kind of happened here is we've kind of encoded a systematic bias into the model. And what this bias is, if you have osteoporosis in this hospital system, okay, so pushing to the right, yeah. So this is the case where one disease type if you have osteoporosis, you routinely get tested for BMI, whereas if you don't, you're only getting tested for BMI if you happen to do so for another reason. So if you're going in for a certain test which requires BMI testing, then you will get tested for it. So in this example, we have a cohort of people who have a BMI test, and that is the reason the model is deciding they have the disease or not. So again, this is an example of the effect of not investigating your data. The likes of this should have been discovered earlier on in the data exploration phase if you were to look at the variables. This really is a toy example, but it just highlights how easy it is to encode these kind of biases. I can give a real example now. So this type of bias comes from when you haven't formulated your problem correctly. And this is the real 3-month readmission model with a bias added in. And it's one you might notice unless you're really thinking about each of these features. So in terms of some of the top features for the model, what's coming out as being important is respiratory-related hospital admissions. They're the type of features which are important. If you see the red value that's pushing to the right, it means if you've had a lot of respiratory events, you're likely to readmit. So, things make sense. But when we get down to this max stay variable, so LOS, max, RESP, COPD, 1 year, and we can see here what it's saying is having a large number of, or having very long lengths of stay in hospital is actually indicative of you not readmitting, which, you think about it, doesn't really seem to make sense. So the bias that's been encoded here is with the setup of the problem. So this is a case where patients were admitted to hospital and they stayed beyond 3 months. So they're still in hospital. So they didn't readmit. So that's just a problem with how this model was set up. And because of that, it's introduced this bias where it's saying, okay, well, the patient didn't readmit because they're still in hospital, so it's technically correct, but that context is completely wrong. So, the whole point to this is it's not enough to look at these metrics of your model and say, I have a great model. You have to interrogate every single aspect of it, especially when it comes to these kind of settings. I couldn't find the figure, but I had another bias where patients who were admitted and died as part of that admission, where they were kept in the model. And what you'd find there is certain blood tests which were taken at that admission, like low albumin, so maybe kidney disease, they were indicative of somebody not readmitting, which doesn't make sense, but again, they didn't readmit because they passed away. So it's that kind of bias that's quite easy to bring in. In terms of how you can interrogate the model more, this is the same framework, SHAP. These are local model explainability plots. These are kind of good examples now. So what this is kind of showing is the leftmost figure is running a risk prediction model on a real patient at a certain month. The rightmost is a month later. So on the left, the model incorrectly predicts the patient will be alive. On the right, it correctly predicts deceased. So this is just kind of showing what has changed. Why does the model now correctly think that the patient will be deceased? These are really important when you work with, say, your clinical partners, as these are the kind of plots they want to interrogate. So I'll go into the actual features in a second. Similarly here, that figure on the left is now the rightmost figure on the previous slide. So this is correct deceased. And then a month later, it would incorrectly say the patient was alive. So just to kind of drill into what's happened, this is the underlying data for the model then. So this is a certain blood test, and you can see the red line there where it's kind of correctly predicting. So what's happened there, this value has dropped significantly enough. Remember, there's interplay with other features that the model correctly gets it. In the next month, it spikes. Similarly with chloride, you can see the drop. Neutrophil lymphocyte ratio is quite a strong COPD predictor, and you can see that big spike there as well where the model gets it right. What's kind of happened here with this patient as well is they've had a really long stay in hospital, so their total length of stay has jumped quite a lot, and again they've had a big drop in their eosinophil value. So all of that can be seen from these explainability plots. So you can see I'll go back to this one. If you look at the length of stay to date, so the second most important feature on the right-hand side, that's jumped massively. It wasn't even present in the previous plot as an important feature. This patient's had a huge stay in hospital. So the idea of this is the clinicians can view it. They can say this makes sense or this doesn't make sense, but they can then go and look at the underlying data to say, yeah, this is the reason. Feedback from this also, really helps us with the development process as well, in terms of identifying biased features or features that don't really make sense. So I'll mention fairness now, just briefly. How do we evaluate model fairness? So model fairness, again, this is very dependent on the use case, but for healthcare, it is very important. So this is kind of analysing, okay, you have a good model, it's performed well, it looks explainable, clinicians are happy, but is it fair to everyone? So how you define a fairness group really depends on the problem. So it could be done by male versus female. It could be done by age, ethnicity. There's any number of factors you might want to look at here. If there is a significant issue identified, the model can then be retuned, retrained. There's a number of methods to do this. You could use a custom loss function that's going to optimize for fairness. But how you initially kind of investigate this, there are a number of techniques, but one that we've used is FairLearn. It's a very good library. So what FairLearn, there's a lot to it. This is only a very basic use case of it. What it does is it evaluates your model performance metrics on the different subgroups. So here I'm showing patients over 65, less than 65, and male versus female, and just in terms of performance metrics and selection rate. So again, selection rate is one you would still consider here, but if you think of more, if you had a model to predict if someone's going to get a loan or not, then you might be really interested in selection rate and how that breaks down by different groups. So there might be one marginalized group that isn't being selected for a loan, for example, and this would pull it out here. We can see the model performs slightly better on men versus women, and it performs much better on over 65s. So whether this is a problem or not really comes back to kind of collaborative discussions, because it really depends on the use case of the model, the data the model was trained on, and if it is an issue that is not performing well on a younger cohort. So these kind of steps that I've kind of described, they happen at all stages. It's not just at the end of the modeling process, but it's always kind of things to keep check of. So we showed a couple of biases there. So one was around incorrect model formulation. So the likes of that, not excluding people who stayed longer than 3 months or people who were deceased as part of the admission can get you into trouble. It's so important to understand the data, and in particular the context behind the data or how the data was generated. What's been kind of really valuable for us is this domain expertise, which we rely on our kind of clinical partnerships for. So we have a lot of kind of interactive sessions with them around those kind of figures I showed you. And then kind of importantly, it's not enough to evaluate a model in terms of performance. So you should consider all performance metrics. It's really important to look at things like explainability and fairness. So just to kind of finish quickly with a couple of slides, this work is part of the NHSX Phase 3 award. So we got this just over a year ago now, and the idea of this award is to operationalize AI as part of routine patient care. This is due to be launched very soon, in the next month or so, and this is kind of a snapshot of what the clinician dashboard will look like. So essentially, the clinicians will have all the regular data that they would have had from the patients anyway, but on top of that, they now have a model risk score. So here we've depicted a few of them. So 72-hour exacerbation risk, that's that short-term risk, the 12-month mortality risk, and 3-month readmission risk. And most of the stuff I kind of showed today, they can really drill down in this dashboard and view more information on it. So if they're looking at Joe example and they want to say, why are we predicting that he will be deceased? They can really drill in, they can see what the explainability looks like, they can then go and get the underlying data, so they're not just looking at these SHAP plots, they're looking at the data itself in that whole context. So that's what we've kind of been working towards with this work. As a team, there's a lot more that's going on in the background that I haven't showed here today, but just to give a flavour of some of the stuff we're doing. So thanks very much for giving me the opportunity to speak today. It's great to be here. If you want to follow us on Twitter and LinkedIn, the socials are there. We're also recruiting, and if there's any feedback on the event or the session, you can find it here. Thank you. I don't know if anyone had questions. Sorry. Thank you.
One thing I wanted to ask you is more of a general question, because in healthcare there is always the issue of imbalanced data.
Yeah.
Like given that, has there been any research in terms of generated synthetic data, either be it from some statistical model or using deep learning generative models? It seems like that if we can come up with a technique to generate more synthetic data will solve a lot of the issues, especially with the imbalance data set problems.
Yeah, so I guess as a company or our data science team, that's something we are investigating. There's been kind of an explosion of companies offering that as a service now as well. So there's very good synthetic data tools available now. One challenge with healthcare data around that is most of these offerings, you have to bring the data to them, and there's a lot of governance concerns then, as opposed to a software we can apply on top of the data. Yeah, it's definitely it's one that's worth more exploration. But I have seen some studies on it, but nothing too conclusive.
Yeah, I imagine that you would probably better off trying to build it than by yourself. Because otherwise you don't understand what exactly.
Yeah, just the nuances that are in the data and.
One more thing in terms of understandability we're talking about.
Yeah.
Not only we have to make a model, we have to also understand,
Yeah.
especially the risk factors. So I imagine you sort of do something like, you talked about feature engineering, but you probably do something like, I don't know, principal component analysis or something to see
Yeah.
the risk factors. I guess those was the basis for your, what you did before you started building.
I guess starting off, a lot of the data sets, there's nothing very intuitive in them. Like if I take prescribing, you have a prescription date plus a code. So straight away with that, you have to think, I need a technique that can model this. So something like target encoding we might use. Some of the other features might be more intuitive. So say lab test values, you could take the value as is, or you could do some kind of aggregations or maximums or medians, different things like that. A lot of the ones derived from hospital-related data. Most of them come from discussions with clinicians or the literature. And then when we have this huge set, then we might use PCA to try and find what's most important. So.
I was going to ask, what sort of approach did you use to reduce from the original 150 features down to the 80? And then within those 80 features, did you look into sort of multiplier effects between different things?
So in terms of reducing the feature set, we would have done this in cross-validation or a number of different techniques just for examining feature importance. So you could just look at dropout and see what change you get in scores. So we'd have different methods set up for that. In terms of your second point, it depends on the framework you're using. In terms of ones derived ourselves, say neutrophil lymphocyte ratio, that's one that the clinicians informed us on. In XGBoost, we might use feature interaction constraints. So say there are certain features which just don't make sense to let them interact together. So you're kind of controlling the ones. And again, that comes from feedback from clinicians. But say that's the way you would have interactions with the XGBoost framework, say. If we're using a more statistical, say a GLM model or something, we might look at different interactions. But
you talk a lot about explainability and the importance of that, which is, I absolutely agree, but you're also using something like SHAP to do some explainability features. Could you not still have a deep neural net that is...
Yeah.
Because SHAP can then say, well, this for this patient is why the deep neural net said this, so is that acceptable?
yeah, so this is really interesting. It's something I discussed during my job interview for this position, but there definitely was a feeling for not using deep learning just because they are inherently so unexplainable. But when you kind of abstract away then and look at the method we are using, it's not explainable. We're still relying on third-party SHAP, and SHAP supports deep learning now as well. So it is for consideration. I guess there's more fear around using deep learning in this setting, at least with the likes of XGBoost. It's still built on decision trees. Clinicians could go and interrogate the tree and understand it more. I think the shift will be to more glass box interpretable models, but the performance just isn't there at the moment, or it's just about there now. But traditionally you're talking something like decision tree, a regression, which aren't going to give you the same performance as XGBoost or a deep learning method. But I guess maybe the best in that space right now is Interpret ML from Microsoft. We've been doing a lot of work on this.
A comment on that actually, maybe you could look into variational autoencoders that would give you a dimensionality reduction. And well, that counts as like reducing the
Yeah.
size and understanding. So you can probably use deep learning in terms of that to understand.
Yeah.
Yeah, it's really interesting to see what you're saying about like the ethics and the fairness of evaluation. Obviously, that's within the data itself, but how do you account for the kind of bias in the collection process? So, for example, using data from wearables and stuff, only a certain like wealth group would be able to access.
Yeah, so that's the challenge. I guess for the models we're talking about, we provided that wearable data, so it'd be part of a service model. So it would be if you were on the COPD service, we'll give you the tech. But yeah, that is a challenge. Or I'll just give one more point on it. If you look at the EHR data we have, that's from a very homogeneous white population in Glasgow. You know, that's a challenge in itself as well. But all good challenges.
Is there a variation in the clinical data between like different hospitals that you get?
Yeah. So there's different processes. You know, that's anything we build here in Glasgow, we do need to test it then in Lothian or somewhere else where might have different hospital systems, different practices. Okay. Yep. Thanks very much, everyone.
All right, it seems we are on time, and since I have a lot to talk about and only 50 minutes to talk about it, let's start. So the session is called Battle of the Cloud Data Warehouses. However, as this is a session I had done over the years, there's been a shift in the way the market is working. So I've actually renamed it, but I haven't told it to Scotland, so we will now be talking about the Battle of the Cloud Data Platforms. And I'll be talking a bit about what is the difference between them going onwards. This is a very high-level presentation. I'm not going to go deep into the technical details of each and every one. I'm going through 5 different ones today. So it will just be touching on, and of course there will be variations on some of the things like pricing mechanisms and so on that I might not cover, but ask me questions if there is anything you're wondering about, and we can see if I can answer on that. So yeah, my name is Johan. I haven't put in a vanity slide because I don't have time to talk about it, but I'm Norwegian MVP. I'll be talking first a bit setting the stage, a historic introduction. Why are we talking about data warehouses or data platforms as such? Was the evolution? Then we'll be going through Redshift, BigQuery, Databricks, Snowflake, and Azure Synapse Analytics. Not in that order, I shift them about, but that's okay. And then I'll be going through some analytics to try to compare them and see what makes one shine better than the others in some aspects. And in the end, I'll give my not so honest opinion about, or humble opinion about which one I think is the best. But it will be, it depends probably. So, we're starting with the enterprise data warehouse. Most of you guys have been involved in one kind of other data warehousing solution. It has been around since 1988. So it evolved over time, of course. We have different forms and shapes of it, Kimball, Inman, Data Vault. And it basically works around that you have structured schema on write data. It is relational, and it stores historical data that needs to be transformed and be presented. And typically you either do an ETL or an ELT, depending on, where you transform the data before you store it in the presentation layer of either reporting services, Power BI, whatever have you. And because it is aligned to be cross-source systems, so you can query across different source systems in the data warehouse, it's very good to be building up for business decisions. How are we doing? What have been done since the last 14 days, a month, a year? But that also means that we have a high focus on data quality and exact numbers. And that, of course, also means that we need to do a lot of checking and validation and transformation before we get things out, which means that data warehouses have a reputation of being expensive projects, long-running, and users getting what they wanted after they've forgotten what they asked for. Then the data lake came in around about 2011. And the data lake tries to answer some of the pains that the data warehouses and relational databases faced in the terms of big data. And we have volume, variety, velocity. Of course, if you're talking to marketing departments of Cybernet, some company that tries to sell something big data, you could have 4 or 5 or 6 or 7 or 10 Vs to be why their product is so much better in big data. Anyways, again, the main part is this is areas where the relational database systems started to struggle. And big data or data lake was a way to help on that. And the typical varieties of a data lake are raw, so you just dump everything in and then let users do whatever they want with the data. And a business data lake, or a layered data lake. And in these data lakes, you transform data only after you've landed them in the raw layer, and then you can have various amounts of layers until you get to a presentation mode. So various use cases, various users can have access to different layers. So data engineers and data scientists typically want to look at the raw data, whereas an analyst might want to see partially curated data, at least you have some data quality checks in, whereas a business user probably just wants to see readily transformed data consumable in a dashboard. Because you don't have all these cross-query or cross-domain queries happening, you don't need to transform data as much, you don't need to have as much focus on quality, which means that a data lake is speedy, it is great for ad hoc analysis, it's great for looking at trends. Again, if you know that you have exact quality in that data source, fine, you can have exact numbers. But mostly you don't really know what kind of quality you have, so trends is the best you can rely on. And because, again, no quality checks, very fast time to market. And it is an enabler for data science and self-service analytics. The problem, of course, with the data lake, especially when we're dealing with on-premise data lakes, is it's very hard to add another storage node. It's harder to scale, and it also ends up with you putting a lot of data in, you don't really think about what you're putting in, and you're getting a data swamp, which means that it's full of data, but you don't use it because you don't know what's there. Yeah, and there's no normalization between the source systems as you have in a data warehouse. I see I've forgotten to delete the slide, okay. But yeah, sorry about that. The next point in this is that relational database providers, such as Microsoft or Oracle or Teradata, tried to put in massive parallel processing to help with the pains that relational database engines faced. So massive parallel means, again, you have one controller node and then you distribute the data across several nodes, and the queries that hit the controller node then gets distributed across, which means that you at least partially get away from it, but still there are some challenges in this because you need to put a lot of hardware in and you get quite expensive systems. The cloud solutions that then came into this solved some of the problems because you could pay only for what you use, but still that massive parallelism adds some complexity in how you organize and put your data out, as well as it is still a take on the data warehouse, which is not very good for data scientists. It's not very good for self-service analytics or ad hoc analytics. So this is where the cloud data platform comes in. And again, this is a shift in the market that I'm trying to talk about today, is how can we take the good parts of the data lake and the good parts of the data warehouse together? Because let's face it, so many companies have put a lot of money into data warehouses. They function today. Why should you throw that out just because Snowflake or Microsoft tells you otherwise? So how can we put things together in a way that you can get the best of both worlds? One way of doing this is Gartner's logical data warehouse concept. I think they came up with around 2015. Gartner is always very good at coming up with big ideas, and not all of them are very possible to implement. But actually today, there are several of these data platforms that can function as a logical data warehouse for you. Again, logical data warehouse means that you have an upper semantic layer-ish, and instead of having to transform into a data mart from X number of systems because a user asks for a data set, you just make that publicly available on SQL endpoint, for instance, so they can query it. Then you have the cloud data warehouse. Again, you have Redshift, and you have Snowflake, and you have SQL data warehouse for part of Synapse, which we will be looking at today. Again, scalable, massive parallel processing engines, relational databases. You have virtualization engines, such as TIBCO or Denodo, which offers, again, one single layer that you can query against, and the source systems are then being queried by that virtualization layer. The problem with the virtualization technologies, though, is that they are as fast as the slowest data source. So if you're combining files and several SQL databases into one query, you will have to wait for the files to respond. Or you will have to cache them and build a lot of extra expensive technology on top of that. So that's where the new cloud data platforms come in. And this is a lot of boxes. Don't try to read them all. It's not as such a bit silly. But the thing about this is we have, at the bottom, we have the cloud foundation or the foundational layer with the capabilities that you might need when you're building your data platform. Then you have the middle layer, which is data foundation, AI analytics and BI foundation, and AI analytics and BI execution, which again are capabilities that you might think of when you're building your data platform. You might need a storage because, of course, you have sources that you need to put in. You want to model them somehow. Okay, how would you want to do that? What kind of data engines do you need in? If you're going to build machine learning models, okay, you need to put them into production, and then you need to monitor them and fix for data drift and so on. So you need to have a data science workbench. You need to have a model catalog to know which version of the model that you are running in production right now. Some companies need to justify why they've scored one customer one way and another that way. And then you need to look at, okay, which version of the model was running when that client got scored, which again means you need to have control of that in a model catalog. You might need data modeling, aggregated fact solutions. All of these things are checkboxes I use when I talk to my clients to say, okay, what do we need to build your data platform? But of course, none of this is interesting if your users don't trust that data. So where can I find what data we have? Again, data swamp is a danger unless people know where to look. What kind of quality is that data? What does this KPI mean? Load factor, what is that? So a business glossary is to explain a common terminology within the business, again, to make people trust what they see. And of course you have data privacy, data lifecycle management when you have a lot of data, and so on. So again, these different layers are an important part of a data platform, but you don't need to check off all the boxes. It depends on the need for your business. Yeah, so just checking them off. So let's look at the different components we're going to see today. One is, of course, Azure, and specifically Synapse Analytics. AWS with Redshift, Google Cloud and BigQuery, Snowflake, and Databricks. First off, we have Redshift. And Redshift is a massive parallel relational database engine. It is based on PostgreSQL, but adapted in such a way that it's you don't really recognize it as such when you look at it or run it. It is a columnar engine, which means that, and most of these are, instead of having a table with rows, you put each record into columns and then split that up, because that means when you are querying just a wide table and you select a couple of columns, instead of having to go through all the records and all the columns before you return your result, you can just go and the engine can go down and look at these specific columns that you request. So it speeds up as well as it adds a nice compression. And it's a distributed database system. So what is a distributed database? Well, as I mentioned before, you have a controller node, and then you have X number of copies of the databases lying on each distributed node, which means that you separate across, so you can select, for instance, if you are running on a per year, you can split the data per year over the nodes, and then the controller node can send the queries to each of them and they can return a result. There are some distribution types. How do you distribute your data across? In Redshift you have key, all, so all into one node or all into separate ones. Key is partitioning key. That partition was the word I was looking for. and even distribution, so just randomly distribute. So, okay. There are 3 different versions. Actually, that's wrong. The dense storage is out this year. The other 2 are dense compute, DC2, and then you have RA3, Advanced Query Accelerator. And they have slightly different architecture. So the DC2 version is very fixed, and it has the leader nodes and it has the compute nodes with the distributed database systems underneath. Yeah, the compute nodes. And then they have slices and storage combined, so the compute and storage is attached. So you can't turn it off without just closing everything off. So it is a dedicated hardware that you're running in the cloud. The latest version of Redshift is a more flexible approach because the competitors had separated compute and storage, so you could host the compute without paying for it and just have the storage underneath. And RA3 is trying to come with the same thing. They have a leader node, then you have the compute nodes underneath, and then you have managed storage, which is SSD for the hot data, and then S3 for archival or cold data. There'll be lots of clicking, sorry. Then you have Redshift Spectrum, which is also a way to look at getting your data across several different places, because you premium disk storage, which is what you have in Redshift or in your database engine, is quite expensive. There might be data that you have in archive mode, which is something you only query once or twice, or if it's a news source that you want to analyze if you bother to take it in. Let's just put that in external storage, build a view over top of that, so somebody can query it from Redshift, but without having to pull it in. So Spectrum is Redshift's answer to that. And that means that you can push your data into cheap storage in S3 buckets, and then just query it from the single pane of glass that is Redshift querying engine. So it's basically external tables or materialized views that you can build on top of that. Snowflake is a cloud data platform, and I'll come back to why it is a cloud data platform in itself. It is also a cloud data warehouse. It is based on ANSI SQL. The guys who started this previously worked for Oracle. So they put a lot of the thoughts and ideas they had from Oracle into building a completely brand new cloud native data warehousing solution. It is also columnar, and it has separate compute nodes called warehouses. And the storage is then decoupled from the compute, but they are shared among the warehouses. It is, in their marketing slides, maintenance free. You don't have to have a DBA, which is, of course, marketing. It's not true. And the Snowflake architecture looks something like this. They are very, very quiet about their secret sauce in these virtual warehouses. You have the common services on top, which is authentication, infrastructure manager, optimizers, transaction managers, and the security part. Then you have a metadata repository, which is of course important when you separate the compute and share that, the data, and share that data between the nodes. You need to have a shared metadata repository. And then you have compute resources with caching. So they pull the data in when they're hot. Previous queries are then responded very, very quickly. And if you turn them off, that cache is flushed, of course. And then you have the shared storage underneath. And one of the strengths there is that you can clone a DB in minutes. It's just clone DB and it's ready in half a minute. I mean, it depends on the size, but it's still very much. But the really strong point here is that the virtual warehouses are auto-scalable, and you can pause them so you don't have to pay money when they're inactive. So you can pause it if it's been inactive for a minute or for an hour. Of course, you lose the cache, but the minute you start querying against it, that node is available like that. It is amazingly fast. Snowflake works across AWS and Azure. I think they are in Google now as well. They were at least working into that space last time I looked. But they are a separate provider, so they are, you need to integrate with it in another way that you would do, for instance, with Databricks, which is native, at least in Azure. And you can have a dedicated compute node or warehouse per use case, which means that you can have one for finance, you can have one for sales, and one for data engineering, and one for data science. And again, it means because finance typically runs month-end reporting, and they want to check how things are going 9 a.m. in the morning and then after lunchtime, and you can pause it afterwards. Whereas data engineering and ETL tends to run all day. And they are auto-scalable, so you can say, okay, I want to start at 3 times, or the smallest one, and then scale 3 sizes, or all the way up to 4XL, I think is the largest now. And then scale down again after a couple of minutes. And yeah, it clones for dev test environments and so on very quickly. You can also query over data lakes. You have file sharing, which is one of their main selling points, is that they have a data marketplace. So you can either commercially say, okay, this data set is very nice. I want to make that publicly available for all Snowflake users, but you have to pay me money to get it. It also lets you share or connect to external tables on S3 or Azure as you want. And you can build materialized views and use stored procedures and everything else. So it is a relational database engine, but it has a lot of extra. But the cloud data platform part is, of course, because it is a whole ecosystem. I mentioned that you can run on all clouds. Yeah, you can run on Google now. It has data engineering, so you can use what they call snow pipes. Everything is snow something. Snow pipes to do transformation and pull data from an external data lake into the system. It's not streaming though. You can only do micro batch or batch. You have the data exchange with the marketplace. You have data science availabilities, so you can build models in. Or you can't do data science in Snowflake, but you can build data science outside. Until now, when they put in Snowpark. And Snowpark is a way to put in, yes, everything is snow. So now you can run Python, Java, Scala, and other languages. And you might understand why they do this if you're familiar with Databricks or with Synapse. They need to come up with other solutions to respond to the data science needs or the people that want to use Python instead. Right, so SQL or Synapse Analytics, and if you just look at the part of Synapse Analytics that is called Dedicated SQL Pools, I hate the name, but it's there, formerly known as SQL Data Warehouse. It is also SQL Server as a massive parallel processing engine. You can run T-SQL scripts just as you can in your SQL Server. There are some discrepancies, there are some things that are supported in Synapse and not in SQL, and vice versa. It is also columnar per default, but you can, and that is the cluster column store index. You can turn that off if you want and use row-based index instead, but it is cluster column store default. And it has separate compute and storage, so you can pause your data warehouse, but unlike, for instance, Snowflake, it is not a pure decoupled architecture, because when you pause it, the SQL database is unavailable afterwards. But you only then pay for the storage of the data and not the compute part. Even though it's a premium storage, so it costs more than if you just store it in the Azure storage. It is also distributed databases as with Redshift. So, yeah, distributing across, I think there are either 3 or 6 copies of a database per compute node. And the SQL data warehousing partition keys are, partition key, again, year or customer or something else. All, and again, typically for an all scenario is if you want to bulk load data in and then distribute afterwards, ELT. Or if you have a dimension table, you want to distribute that across all nodes, so you have stored the dimensions for lookups when you're creating your fact tables, instead of having to wait for the response or the query engine to fetch from one of the nodes and then copy that across. Or you have round robin, again, even distribution among the nodes. Synapse Analytics, of course, tries to do more, because typically we had Data Factory, Databricks using or building Databricks for big data processing, strong transformation capabilities and so on, data science and stuff. And then you have SQL Data Warehouse, integrating with Power BI and Azure Machine Learning and so on. But by building everything into a service, they try to offer the customers a more comprehensive platform without having to have too many different components in your architecture. So you don't have to go to Databricks to write your notebook, and then to Data Factory to orchestrate it, and then to SQL Data Warehouse to write your stored procedures. You can do everything from one single pane of glass. So you have serverless SQL, you have Polybase 2, which is again for external tables connecting to various sources, relational database engines, your data lake file systems, and so on. You have Spark for your containerized Spark queries, Data Factory or data pipelines to replace Azure Data Factory, and Power BI integration. You can actually sit in Synapse and develop your reports or do modifications on your Power BI reports and then publish them back to Power BI. And then the single pane of glass, the Synapse Studio, where you're working. And now lately they've also added Data Explorer, which is a time series database, a very big query engine, or big data query engine. And you have also Purview integration to data cataloging. Next up is BigQuery. And BigQuery is Google. It is serverless, which means that unlike Synapse, where you say, okay, I want a provisioned data warehouse with hundreds, or version 100 or 500 or 1,000, or Snowflake from small to XXL, you don't have to think about how to design your BigQuery. It scales as it needs to. The query engine itself says, okay, I need 2 nodes for this, or I need 5 nodes for this query. It is ANSI SQL, as Snowflake is as well, which is basically, if you know T-SQL, you can very easily get into ANSI SQL, which is the native language. T-SQL is an adaptation of it. It is also separate compute and storage. So you don't pay for compute unless you are querying it, then it's just paying the storage where it is lying. And it is also columnar by default. Again, very quick response times, compressing the data very neatly. And since you don't control the capacity, you only pay for the query. There are, of course, various types of pricing scenarios, but typically you pay for the amount of data that is being processed for each query. I've heard of people saying they've pushed a $50,000 query once. So yeah, it can get expensive, as everything can. And BigQuery, unlike the others, is not a star schema optimized compute engine. This is optimized for wide tables. And the reason why I say this is because, yes, you can do star schemas on everything, also BigQuery, but you are paying for the amount of data that is being processed at the time. And if you look at the query optimizer in SQL Server, and you do a lot of joins, you will see that the amount of data that's being processed versus what is being delivered is a lot more when you're doing joins. So avoid joins and have cheaper queries and slightly higher performance than if you are building a lot of joins into it in BigQuery. And BigQuery also supports both streaming and batch queries. BigQuery has also a very nice feature. It's called Omni. It is a multi-cloud functionality run by Anthos. Anthos is their containerized or Kubernetes-ish implementation, such as Azure has Arc, which means that you can run and process the data on your Azure account using BigQuery, even though, and not have to pay for the full transfer of data. The egress costs between clouds can get quite expensive over time. Then you have Databricks. And Databricks started out as containerized Spark. Everyone used it for big data transformations in Azure. But you can also get it on all the different hyperscalers, which is Google and AWS. It is a distributed in-memory processing engine. Again, it's Spark, with some extra sauce on top, so it's not just the plain vanilla Spark you get from Apache. It has multi-language support, so it doesn't matter if you query it with Scala, Python, Spark SQL, it will handle it. And it has a common development environment using Databricks workspaces and notebooks. And of course, it is not a relational database at all. So unlike the others, they are taking, their approach is coming from the big data world and getting into relational database engines as they go along, which is what they did when they launched Delta Lake as part of their data lakehouse architecture. And the Delta Lake is file-based, which means that underneath the hood here you have the Parquet files. But you don't really care about that. But for those who don't know, Parquet is an open source Spark optimized storage and binary storage file, which is columnar. And it's very, very nice to use just that. I mean, compromised storage on Blob Store, cheap, like very cheap compared to a SQL database, for instance. But Delta Lake has a wrapper around that, which means that you don't really need to think about those Parquet files. You connect to the Delta Lake table, and it will handle and look as a table for you. And it has a transaction log. It lets you do all the ACID principles on the data lake that you can't do when you're just running CSV or Parquet files, which means they can do updates, deletes, merges, and it supports, since it's open sourced, you can have it on-prem in HDFS, or you can use S3, AWS, Google Cloud Storage. And it is also both a source for streaming and a sync, so you can just, it's a unified batch and streaming source. And it allows you to have schema enforcement and schema evolution. So if you add a column or you change from a varchar 3 to a varchar 10, it will update everything for you without you having to think about it. And transaction logs means that you can look at whatever has happened to a transaction, as well as go back in time and see what did that row look like a week ago, or a year ago, or 10 years ago, depending on how large your transaction log wants to be. The fun part, though, is that the command to clean up your transaction log is called vacuum. And yes, it does support updates, deletes, foreign keys, all the things that you will need from a relational database. And yes, it is open sourced under the Apache Foundation. Or is it Linux Foundation? I can't remember. Anyways, the data lakehouse architecture looks like something like this. You have your files in your Delta Lake tables, bronze, which is raw. Then you have the refined tables, which are curated, silver. And then you have your feature stores, data marts and so on in your gold layer. And again, this is just varieties of layered data lake. On top of whatever data lake storage, object storage you want, and it supports streaming, batch, and then whatever analytics engine you want on the other side. And Databricks gets into the data platform part by releasing a SQL analytics engine, which handles things like group bys, sums, aggregations faster than the regular Spark. It has SQL Serverless in preview now, or public preview this summer. It has a Unity catalog, which is also in preview. I think it's launching, if it hasn't launched this month, it will launch soon, enabling you to do audit logging, so checking who queried employee data and at what time and which query did they use on that data, which is a very, very nifty feature. I don't know any other data catalog that has that. But it is still a very technical catalog. It's not meant for regular users, but it also has security features allowing you to do more fine-grained access control. And Delta Live Tables, which is out now, which is their ETL tool, which is also a very powerful tool. For instance, you can write that you want to merge data into a Delta Lake table using slowly changing dimension 1 or 2, and it will handle that logic for you. Oh, good. So, now that we've gone through all the different systems that we're going to look at today, so what can we look at in functionality comparison? You might already have realized that all of these contenders, at least superficially, resemble each other quite a lot. All of them allow you to use some kind of a SQL dialect. Most of them also allow you to use Python or R. I think you can do that in Redshift as well now, but not BigQuery if I can't. Yeah, I might be wrong. So it's very easy to start using any of them, because SQL is by far one of the most known programming languages. But as I mentioned, Databricks is the only solution that did not start out as a relational database engine, which means that their take on this might differ a lot in terms of costs over time, if you look at it that way. Then we have querying against external data, and yes, they can all do that, except that Synapse and Databricks let you query against all the relational database engines. As long as you use Python, in Databricks you can connect to whatever has a JDBC connector. BigQuery has support for Cloud SQL, which is a native Google SQL engine. And if you're using Snowpark in Snowflake, you can of course also use Python and JDBC connectors there, but then you have to pay for that extra compute. And Redshift Spectrum incurs an extra cost per terabyte processed. I will share these slides afterwards, no worries, so you don't have to, if I click too fast, you will get them. Then the scalability. Well, yes, all of them scale, though Redshift is a bit restricting in that you can only have two different, it's only small and large within these, in DC2 and RA3. And in this setting, BigQuery is considered serverless because you don't have to think about scaling it. It will handle that in itself. And of course, both Redshift, Synapse, and Databricks have serverless features. Whether they are good or not, well, I haven't tried Databricks yet. I'm curious to see how that goes, but Synapse, at least in my experience, is too slow for this. But they have them. Then about loading data into the systems. And you can do that, and all of them have support for external ETL tools. Databricks let you use Data Factory, or you can use Fivetran or dbt if you want. And all services offer tools as part of the package. So you have Synapse pipelines, you have Snowflake or Snowpipes. Redshift has not bundled everything together. Redshift points, or Amazon points to the different tools that they have for this specific use in their ecosystem. So there's no common query platform there. Redshift and Synapse SQL pools needs to be signed according to the distribution. Again, when you take a table in, should that table be distributed evenly, or do you want to use, look at what kind of query patterns you use to partition it with a partition key instead? Because if you use this wrong method of partitioning, you will get very slow response times, because you have to shuffle the data between the different nodes and the compute node in itself, or the controller node. And Redshift and Synapse are very similar in that aspect. And BigQuery needs to sign decisions to avoid the joins. Again, you don't have to, but it's the price performance, and particularly the price part. But Snowflake and Databricks don't have these constraints, though you do need to think about partitioning also, and especially in Snowflake, because Snowflake doesn't allow you to tune your queries. You can do performance tuning, but you can't tune your queries in itself. It's just put on more compute. Then all offer browser-based access or query tools, and all offer APIs, which means that there are third-party tools that allow you to connect to them and query them. But in my opinion, Synapse and Databricks have the richest development workspaces, Synapse Studio and Databricks Workspace. When it comes to speed, you will see everyone has an idea that they are the fastest. And there was a fun tit-for-tat blog post war between Snowflake and Databricks briefly in November last year. But which is the fastest? And it really depends. Do you really need to have the fastest query engine? And does that speed mean that you have all the queries cached? Is that the most important part? Because if you spin up the clusters right, they can have a hot for the most hot patch for the most used queries. So looking at speed is really, really hard to define what is the best for you. I think the whole package is the most important. And Synapse is available worldwide. Snowflake is available worldwide, though it has fewer data centers per region, which might or might not be an issue depending on GDPR and so on. Redshift is also available worldwide, BigQuery and Databricks worldwide on all hyperscalers. When it comes to pricing, Redshift has varying pricing per version and then per tier, as well as separate pricing for Spectrum and so on. And Snowflake prices storage for terabyte and then compute per second when it's hot. So it's priced according to the node size at the query time. It's very scalable. Synapse has auto-scalability for the SQL data warehouse, serverless options, Spark cluster selection. So the pricing depends on which service you are using when. It might be a bit difficult to predict, unlike Redshift or Snowflake, or specifically Redshift, because you have lesser options available. And BigQuery prices for storage, and then streaming inserts, and then per megabyte pass-through, or per gigabyte pass-through the query as default. There are other options as well for pricing. You can go on a fixed price or so on. And Databricks might be the hardest one to predict the cost for, because you need to look at the compute size of the node, and then how many nodes per cluster. Analytics engine has a separate pricing for it. And it might be a bit hard, and I don't have a really good calculator to predict it either. So that's the main pain of Databricks in that aspect. Synapse has some cool features that are not available for the others. One is the Azure Synapse link, which allows you to get CDC connections to Cosmos DB, Dataverse, and then Dynamics 365, and SQL Server. Also, you have Synapse Pathway, which is a slightly automated migration tool to let you migrate away from competitors and into Synapse. But the main point here is that not all of these players are real data platforms. And again, coming back to the layers of the data platform architecture, data governance and data trust domains are a bit weaker in AWS, Google, and Snowflake. Snowflake and Google do not have their own data catalog offering as such. But of course, you can use a third-party solution. That's fine, but they tend to cost a lot. AWS has a data catalog, but only if you're using Glue for transformation. But none of them have good data lineage or data quality and the rest of these data governance tools. But again, there are third-party tools available. Microsoft has Purview, Databricks has Unity Catalog, and you can always discuss how good they are versus the competitors of the more expensive third-party solutions. Again, back to the data trust part of our data architecture. And as long as you're running on a hyperscaler, you have the cloud foundation bit in place anyways. So, I'm 3 minutes out, I think. So yes, do we have a winner? Well, again, in my not so humble opinion, I think Databricks has the most compelling data platform service, because not only can you move your Databricks instance from one cloud to the other, if you're using Delta Lake underneath, it's open source. So even if you get fed up with Databricks and you want to move to something else, the data stays as is and is open source. So all competitors, and probably also in the future, can connect and read from them. Synapse is also very compelling, but it's not quite there yet. The different components don't really work as well in Synapse as they do outside, in my opinion. So I'd rather use Data Factory and Synapse pipelines, but the vision of Synapse, the totality of that, as well as Synapse Studio, means that I like Synapse quite a lot. Snowflake is very nice as well, but again, because it lacks some functionality, and it is locked into a pricing model that is for them very compelling in the short term, because the only way to tune it is by turning up the notch and pay more dollars, which I think will hurt them in the long run if they don't, if you're not careful, as well as their developer environment is horrible. Ugh. BigQuery is a special player in this. It is fantastically fast. For smaller sized data warehouses, it is also quite cheap. And again, if you're using white tables, I've had talks with customers who have 200 columns in their fact tables. Perfect. And AWS, they really need to put up their game to be able to compete in this market. I think they need to put really a lot of effort into getting into the Linux space instead. They are really strong in developer tools and very strong in their original core, which is the virtual engines. But for data analytics, they are behind the competition. So, with that, thank you for your attendance. Are there any questions? No? Then remember, if you like or dislike anything, please give me feedback. And if you write why something sucks, instead of just saying, I suck, it means I can improve. I have had people call me idiot. That's fine. I'm happy to be wrong if you tell me what I did wrong. Thank you again.
We can start.
Yeah, let's start. Hi, welcome to our talk. So the talk's about, kind of as the title says, so we're going to be talking about real-time analytics and kind of going beyond stream processing. I'm a developer advocate at a company called Startree who kind of run a service sort of on top of Peter, and this is?
I am Corrine Wallach. I lead the developer community for a company called Startree, the same company that Mark works for.
Imagine if it was two different ones.
I mean, it could be. You never know.
With the same name. Cool, so I'm going to let Corrine kick us off. And then...
Okay, so just to get started, I'm just going to go over some basic fundamentals. Generally speaking, there's three types of analytics use cases. I'm going to dig into each one a little bit. The first one is dashboards and BI tools. This is probably the most commonly known and most widely used form of analytics. Normally, this is used internally and processed internally, so it's like provided and usually analyzed by BI analysts or something or something along those lines, but it's usually internally facing. The next one is user-facing analytics. This is essentially when you are building an application and providing the end users or customers, like the users of your application, with their own ability to have real-time analytics, their own use of analytics, right? This is the one we're going to be digging into a little bit more in this presentation. And the third one is machine learning. This is generally the analytics that you are feeding into a system, and then the system does some automated type of processing around that, right? So this could be something that's like an automated fraud detection or like anomaly detection, things like that. But essentially, you're feeding the analytics into a system that then the system is the one doing the processing. So for this presentation, we're going to dig in a little bit more into the user-facing analytics side of things. And this chart is just kind of an example of like the progression of real-time analytics over time inside of businesses. So it used to be that analytics were internally facing. Organizations were using it internally. As I mentioned before, the dashboards, BI tools, a lot of BI analysts were the ones kind of utilizing this internal data. And as time went on, organizations started seeing the power of providing your end users and the end, like your customers, with their own real-time analytics. And what's happened is businesses actually started transforming and productizing these real-time analytics capabilities for their end users. So they're literally building premium features, premium products, providing their end users with real-time analytics. And some organizations are strictly user-facing analytics on top of products, right? So this has become extremely powerful, and organizations productizing this business, it has tremendously changed businesses and also made some businesses extremely wealthy. Okay, so actionable insights. Actionable insights is when you're providing your end users with their own real-time analytics and insights, and then they have the ability to take action based on these insights that they now have. This is, I think, an important takeaway, because one of the things is like you could provide your end users with dashboards and things like that, but like, if the dashboards are, a second or two late or whatever, it's not the most important thing, right? But if you want your users to take action based on seeing that something else happened internally in the system, you need everything to be real time, right? And this obviously increases like the user engagement on your platform and like the happiness factor. The users are happier when they have the ability, they're more empowered, right? They don't always realize how empowered they are, but they are. Okay, so just some examples of user-facing analytics use cases. So the first one, we're going to just review LinkedIn. LinkedIn does user-facing analytics really, really well. They have productized this all across the board inside of their organization. So if you've ever used Who Viewed My Profile, this is a really good example of user-facing analytics. You as a user have the ability to see who viewed your profile, and you also have the ability to slice and dice this data by company or like country or like geographic location and things like that. So there's a lot of dynamics in there too. Another example of like a real-time analytics system is the news feed. So essentially what happens is the user goes to the homepage, they're querying this data, and it's giving them all the relevant information of what's happening now. So when your news feed, you need to make sure that it's something that they have not seen before. If they refresh the page, they need to see all new information, and it also has to be relevant. And then they have the ability to take action upon seeing this relevant information, right? This is where kind of like the actionable insights comes in when you're giving them the ability to have real-time insights. And then the third one is the recruiter tools, like the talent insights, things like that. So this is, again, where LinkedIn has majorly productized a huge part of their platform by providing real-time analytics to their users. This is a very widely used feature, and it gives the recruiters like high-level bird's-eye view of what's going on inside of the market, and everything is in real time. If there is a trend or something is happening, they will see it, instantaneously inside of their dashboards. Another example of real-time user-facing analytics is Uber Eats. So Uber Eats has a restaurant manager platform with over 500,000 different restaurants using this to manage their restaurants and their deliveries, right? So this is an example of what the internal of their dashboard looks like. There's missed orders, inaccurate orders, top-selling items, things like that. There's a lot of dynamic information in here, high dimensionality of data. Which is what makes this kind of building these types of systems quite complex. But essentially, as you can imagine, the restaurant owners need to know what's happening right now. If all of a sudden there's menu item feedbacks that's going down or inaccurate orders or something like that, they need to be able to take action, right? So they need to know now. They can't know the next day that something is wrong. So
this one is interesting, right? Because there obviously aren't as many restaurant managers as there are users of LinkedIn. But on a dashboard like this is it's not really an internal dashboard because it's not internal to Uber itself, but it is internal to people who are using Uber for something. But on this page, like there would be queries, like lots of queries being done, the top selling items, all of these would be individual queries, like pulling in the orders, the inaccurate orders, the downtimes, the weeks, like comparing the amount of revenue they've made on different points in time. But this one is quite a good one for seeing like actionable, like being able to do something about it. Because if I can see like what's happening right now, if I can see the orders that I've just missed, like in the last 10 minutes, I can maybe go, hey, look, I'm sorry we missed this order, we're going to do something about it. Like almost like a really good server in a restaurant can try and fix it before you leave the restaurant and hate the restaurant forever. They can try and sort it out for you. Whereas if they only saw this, like say they were, I don't know, like loading this into a data warehouse and then they ran it afterwards and like, oh, we missed like 10 orders today. Well, what are you going to do about it now? Like the best you can do is maybe tell them and they're like, oh, I already hate you.
We'll give you a $5 coupon for
this. Whereas here we can see it and we're like, oh, well, like especially with an inaccurate order, right? We saw like, oh, we've given them the wrong thing. We go, quick, let's go and pay the money, get like someone out there and fix it rather than let them be annoyed with us. So like this is quite a good one of the throughput is, the throughput is lower. But the ability to do something with the data is maybe more obvious than
that's true.
Some of the other use cases.
Okay, so another example, I really like this use case. This is not necessarily the end user facing analytics, but in terms of like building this real-time systems with these like high amount of queries with all this dimensionality, it's a really good example of that. So Stripe, financial payment platform, there is a lot of restrictions on how they're working with their data. Everything has to be accurate, and I think there's a couple slides in here. Okay. Before I get into that, sorry, I'm skipping ahead a little bit. So what problem is Stripe solving with this like real-time analytics system? So Stripe has dozens of engineering teams that are working on all different parts of the platform. There's all kinds of data coming in from all these different teams. And then what they need to do is they need to be able to take this data, consolidate it, and then send it over to all their internal teams, things like accounting, finance, data science, fraud detection, whatever, in real time. And as you can imagine, this is also quite a complex task. It's similar, like where you have all this data coming in real time. You need to be able to pull it all together and then make it vastly queryable with very, very high speed because everyone needs to know right now what's happening. So I think this is a really good use case. And this is some of the challenges of having like, when you're working on like financial payment systems, like in terms of like everything has to be correct and precise and no duplications and there's like security requirements and all that kind of stuff. Okay, so let's just talk about properties of building real-time analytics systems, what it takes to build a user-facing real-time analytics system. So the first one is your speed of ingestion. You need to be able to pull in data very, very quickly. The second one is your speed of queries. You not only need to be able to pull this data in very quickly, but you also have to be able to pull it out very quickly. This high dimensional data, pull it in and pull it out. But the third part to it, which is quite challenging, is you have to be able to do this at scale. So in some cases, it's hundreds of thousands of queries coming in at the exact same time. You need to be able to, make this surface very, very quickly. So these are like the three components of building these real-time analytic systems. In this specific example, we're gonna, do you wanna do?
Yeah, so we're gonna, a bit later on, we're gonna run you through like an example of how you might build such a system, and we're gonna be using the tools that are in this rectangle in the middle. So we've got Kafka, which is gonna be acting as our source for the streaming data. So we're gonna have a stream of data coming in, and then we're gonna be using a database called Pinot to almost do like querying on top of that stream. And around the outside, you can kind of see like the properties that we're gonna require to build this application. So we've got to get the data in real time, so we're going to be streaming those events into Kafka. The data's got to be is going to be high dimensionality, so it's going to have like quite a few columns. We then want to be able to scale that up, like on both sides, at a reasonably cost-effective manner. So one way that both those systems do that is that the freshest data can be like stored locally or in higher cost storage. But if you have all the data, you can then push that off like almost into like a tiered storage type system. So you can say, okay, I've got this data, it's 3 years old, I barely query it, but I want to keep it. Okay, we're going to store that on S3, and when you want to get it, we'll go and query it from there. And then as Corinne said, like these kind of getting the data in and querying it need to be decoupled so that when data's coming in, we're not stopping the ability to query it. So we want to be able to query it, and we want to be able to query that like thousands or tens of thousands of queries per second. So just a quick run through of Kafka in case you're not familiar with it. This is one of the streaming engines. There are lots of them. They're kind of similar in some ways, and I guess each one has some unique properties. But for Kafka in particular, it has the concept of a topic. So it's like a type of event that you're recording. So for example, we might be capturing some orders on one topic. Maybe we're capturing products on another one. You can split a topic into partitions, which allows us to scale it. So if we wanted, we could have multiple places producing those orders, so like lots of orders coming in and getting published onto different partitions. They can then get consumed. So that's over on the right-hand side. Not so easy. Maybe I'll do it with the mouse. On the right-hand side of the diagram, and so you can consume like the more of those partitions that you have, you can set up a consumer for each of the partitions. So you kind of allow the scalability on the producer side, scalability on the consumption side. And then they also have this concept down here of a consumer group, which is where you kind of, like your consumer is inside a group, which is keeping track of what offset am I up to. So like, imagine that the topic is like potentially an infinitely long list of things. You could be keeping track, hey, I've read up to number 8, so if you crash and we start from position 8. Pinot in particular doesn't use this concept. It has its own way of tracking, but it's kind of the same. It's like, hey, where have I read up to? I've got that data, I've ingested that data, I know I've got that data. If something goes wrong and I crash, I'm going to resume from where I know that I'm up to. So that's why you have that. And then Corinne will just give us a quick...
So overview of Apache Pinot. So Apache Pinot was originally built at LinkedIn. And what it is a distributed OLAP data store. Essentially what it's built to do is it's built to pull in data from a variety of different sources, from batch and streaming, S3, Hadoop, Kafka, whatever have you, pull it into one aggregated kind of merged view. It has a lot of special, very powerful indexing inside of there, and then it makes it accessible for a high throughput of queries with very, very low latency. To cover it.
Yep. Cool. So just to give you a quick run through of the architecture of how this thing works. So we start down in the bottom corner. So imagine we've got a Kafka broker running, and it's got like each of these arrows is representing a different partition of a topic. We've got some Pinot servers down here. So Pinot servers are where the data gets stored. So they're storing the data, and then they're responsible for actually serving the data to any queries. And then the Pinot controller is kind of managing the whole cluster, managing all the different parts. And for example, one of the things it manages is where do each of the segments, or like where are they going to be placed? So a segment is the Pinot's name for a partition, so there's a partition of data which contains all the columns, but only some of the rows. And then it's going to decide which server does it go to. So for example, it's saying, hey, I'm going to put segment 1 or partition 1 onto server 1, and I'm going to spread the other ones across. And then if I've got a replication factor of 2, for example, I'm going to like put the other one somewhere else. If server 1 was to crash, I can still serve the data for all those partitions. So that's the controller. Zookeeper's acting as the store for the metadata. And then we've got the servers, which have the data. And then finally, on the other side, on the query side, when you do a query, it comes in through what we call a broker. And the broker will have a look at the query, work out which service does it need to send that query to, which servers have the data that it's interested in. Sends that out in kind of a scatter-gather type pattern, gets back, and then it will, if there's any aggregation to do, it does that, and then it returns it back to the client. So those are there are more components, but those are the main ones. We've got the controller, managing everything. We've got the broker, serving the queries, and then we've got the servers responsible for the data. Okay, so we're going to just run you through a quick demo so you can see how this works. So we've got this architecture here. So we've got kind of 4 parts to it. So we've got a streaming API up the top. We're going to call that from a Python application. We're going to get that data. We're going to put that into our streaming engine, so into Kafka. We'll then have Pina hit up, and then we're going to use a front-end tool called, or for low-code, a kind of low-code front-end tool called Streamlit to visualize the data. And so you can imagine, right, so we're going to be using Wikimedia's recent changes feed. So you can imagine that the user for this might be one of the editors of Wikimedia, or it might be the Wikimedia operations team, like they're just trying to see what is actually going on in this world of people making changes. It's probably not the Wikipedia users. I don't think that this data would be particularly interesting to them. So it's kind of more, I suppose it's more, vaguely more similar to the Uber restaurant manager than the stuff we showed about LinkedIn. The data source, so Wikimedia give us a recent changes feed. It has a stream of events coming in, showing every change, and they publish that. They actually store it in Kafka, and then they publish it over HTTP on the server-side events protocol. We'll have a look what that looks like. That's kind of weird. So we're going to have Kafka, server-side events, Kafka again. It would be cool if you could go directly to the Kafka, but I guess that might not be very secure from their perspective. So what do the events look like? So they've got 3 parts. So there's a field called event, which always seems to say message. I've never seen it not say message, but anyway, it says message. We've got an ID, so it's sort of identifying the individual event. And then we've got data, and data is mostly what we're interested in. So it's in JSON format, and it has a bunch of stuff. So it says like what URI are they making the change on, shows you a request ID, what time did they make the change, what was the name of the page, what was the actual change, what was the length of the page before and after the change, what was the comment that they left, and so on. And so let's, not done yet, let's go and have a look. So I'm going to start with, so we've got all of this code, if you want to look at it, is available in...
Can everyone see in this huge...
we love the size of this... So all the code, if you want to look at it afterwards, is available here. Yeah. Well, so if you want, well, it's very big. It's very big. So I've got no problem with the size. So it's in this repository if you wanted to have a look at it, just so you can play along. Cool. So let me just come back. So we've got this Docker compose file. So everything, if you're using Docker, you can spin this up like in one command, and then you'll be ready to go. So we've kind of got, we've got the Zookeeper sitting up here. We've got Kafka in the middle, so kind of got that configured to, if you're inside Docker, it's using port 9093, and if you're outside, it's 9092. And then we've got the different Pino components. We've got the controller, we've got the broker, and then we've got the server. Okay, and then we've kind of run that already. And so that's now actually ready to go. So what I want to show you now is how do we go about querying this Wiki API. So this is the code to do it. So we're getting the most really interesting bit is here. So we're using the requests library to make a HTTP GET request to this URL here. And then I guess we can have a quick look at that so you can see what it looks like. I mean, the messages are gigantic. It's like, you can kind of see them. There they go, coming through. So that's what the messages look like. So they're the same as what I had on the slide, but just so you can see what it is. And it will just keep going forever, so I probably should kill it before Chrome gets angry with me. And then, so we get the URL, we tell it, hey, we're expecting to receive a stream, and then we pass it into this Python library called SSE client. So you can see it saying, I'm initializing the SSE client over an existing ready-to-consume event source. And then what we get is an infinite stream of messages here. And they are JSON, so we process them as JSON. And in this particular example, we print them to the screen. So let me just show you what it looks like in here. So it's basically the same. It's pretty much the same as what you saw, but this is how you would process it from Python. I forgot what this is called. I think it's called event source. And most of the examples you find on how to process server-side events are in JavaScript and Node. I somehow find a Python one after a lot of searching because I have everything else in Python. But mostly people are. Seems to be like a Node.js piece of technology. But you can kind of see we can get the events. The next thing we want to do, so we've kind of got the events, they're available now. What we want to do next is get those into Kafka. So we've got a bit of code, which is in it, just a slight extension on what we saw there. So most of that bit at the top is kind of the same as what you've already seen. So this is all the code we saw on the previous slide. We've then got a couple of things for Kafka. So we're saying, hey, we're going to call this act function. If we get an error, we're going to say, hey, there was one of the messages didn't get delivered. And then we've got this JSON serializer function. So if they see anything that needs to be any date times, it's going to serialize that properly. And then we're looping over the events. And now instead of printing it out to the screen, we are running this bit of code here that publishes it into Kafka. So we're publishing it into an event called wiki-events. We pass in a key. The key is used to work out which partition should it go to in Kafka. And then we're printing out the value as well. And then finally down here, we are flushing it, like forcing it, the Kafka topic to flush to disk in case it hasn't done that already, every 100. And so if we run that one now, so we'll come back up here. So we'll do Python wiki to Kafka. So we should see something like, hey, I published 100 events. So there we go. We've got 100. And how many is it doing? So it's about 25 a second. So there we go. So we'll leave that running. So we've got the Kafka events coming through. And then we can actually go and have a look, if we wanted to, we can have a look at those events coming through. So we can use this this tool called, I'll save you from my typing. So you can use this tool called, it seems to be still called Kafka Cat on Ubuntu, but on Mac it's KCat, and this is like a way of going and consuming the messages. So again, it's kind of the same messages. So we've seen the same messages in 3 different ways. We've seen it in the browser, we've seen it from the Python script, and now we've seen it in Kafka. So we kind of got it into the middle now. So what we need to do now, so we've got it into Kafka, what we want to do next is get it from Kafka into Pinot. So Pinot, as Karine said, so it's OLAP data store, stores data in columns, but the way that you define it is very, very similar to the way that you would define a SQL table. So you need to specify the schema, and then you need to define a table config. So the schema is defined using a JSON format. So we give it a name. So for example, in this case, we're calling it Wikipedia, and then we give the Pinot query runner some hints. So we say, hey, these are dimension fields. And so these are it's kind of using the language of BI, I think. So we're saying we've got dimensions. You can have metrics, and then you can have date time. So dimensions are the ones where we might be filtering on those grouping by. Metrics would be what we're summing or averaging or counting. And then date times are kind of being used as well. So it's using those to work out what if you were ever in the future to do some sort of retention scheme, it would be using the date times to kind of deal with that. So in our case, we've got ID, wiki, user, title, comment, stream, blah, blah, blah. And then we've got a timestamp is acting as the field. By default, the names that you use in there, it will look in your data source, so like in this case, our Kafka topic, and if it sees that the name in the schema exactly matches something in there, it will just automatically import it. So it's like kind of an automatic importing going on there. But in our case, some of those don't match, because if you've got nested messages, it might not necessarily pick it up. And so in our case, what we have to do is we have to define we can define transform config. So it's almost like if you don't want to introduce a stream processor into your architecture, because it's such a tiny change. It's like, I've got the data there. I don't really need to do much massaging of the data. It's just in the wrong place. And you can specify these functions that will go and pick out. So for example, if I want to map meta.id into ID, I can call this JSON path function, go and look up meta, get me the ID, and then the same for stream, for domain, topic, URI. And then the only other thing that we're doing is for the timestamp, Wikimedia gives us a timestamp in epoch seconds, but Pinot works in milliseconds, so we just take that field times it by 1,000 and then we've got the right value. So that's the data transformation code, so you can kind of do that in this table config. Other things, we've got a table name, we need to indicate hey, it's real time. So as Karine mentioned on the Pinot slide, Pinot can deal with batch imported data. So if you had some streaming data, but like say you wanted to start today, and you're like, hey, I've got some streaming data that I want to pick up from now, but I also want to capture all the Wikimedia events for the last year. That last year's worth of data probably isn't in Kafka, right? It will have been pruned already, maybe stuck in S3, and so we can do the batch load of that into it. So you can actually have a table that has an offline component and a real-time component. So that's what this table type does, and Pinot can then combine those together. So it will kind of look for where does the offline data end, and then it will go, okay, so everything at this point is going to be read from the offline table, everything newer, I'm going to read it from the real-time table. But in our case, we only have real-time data. We need to say what's the timestamp column, what's the name of the schema. By default, it will be the same as the table name, but we've explicitly defined it here. And then because we said real-time, as soon as you say real-time, it says, okay, well, I need some sort of streaming config, otherwise it's not going to work. We need to tell it what type, so we say Kafka. It also supports Pulsar. Obviously, Red Panda will work because it uses the same protocol as Kafka. Other ones available on the Startree Cloud, and I guess will eventually be open source of Google PubSub, and I think Kinesis might be on the open source one as well. We then need to specify our topic, where the broker lives. The consumer type indicates low level means I'm going to ingest each partition in parallel. If you were to say high level, it will treat everything as if it's one, so you want to probably use low level. Smallest, and then we're telling it to start from the smallest Kafka offset, so I don't only get the messages that happened once you'd started Pinot, get all the ones, like all the ones for 12 that are happening now, because we don't currently have this table configured. And then you can kind of play around, like this is like some code that tells it how to pass the message, that's these two lines, and then how big should the segment be, like when do I flush that segment to disk so that it's, and it would then be persisted often in some sort of, we'll call it deep storage. In this case, it's on my laptop. In a real life thing, it would be like on S3 or in Hadoop or somewhere else. So you'd have like a canonical copy of it somewhere else. But then Pinot generally, like in majority of use cases, it's got another copy of it on the instance storage as well. So what we want to do now is we want to go and create that table. So I'm just going to save you my typing again. So we just create this here. We'll come over to, is it this one? Yeah. Cool, so that one's still running. So we're going to run this command, and it's going to create the schema and the table for us together. We can then come back in here. So you go to localhost 9000, that's where Pinot runs. And if I go onto this query console tab here, you can see we can write a query. Now the giganticness of the screen is working against us. Can you still read it if I zoom in?
It's pretty legible, I think.
Yeah.
Right?
So you can kind of see, like we can see these are the comments that are coming, or these are the events that are coming in. We can do some. We can say, I don't know, what domain is being changed. So you can do most of SQL stuff. You can't do joins at the moment, but there is a PR. Which I think it will probably be in the next versions. We're on 0.10 at the moment, so 0.11 will be the next one. So let's just group by domain, and then we'll run it. So there we go. So those are the changes that are being done at the moment. So mostly people are changing Wikidata, which is their like structured data store. So lots of changes are being made there. And then I think Commons Wikimedia is all the images and stuff like that. So there's some changes being made there. And then English Wikipedia, French Wikipedia, I guess that's Polish Wikipedia, Russian Wikipedia, and then Spanish and Dutch all the way down. And so you could, like, if you had users, like if your end user was familiar with SQL and they were like which could be, and they were happy to type it, you could just say, okay, I'm going to let you use this as your interface. But probably what we want is something a bit more, like automate this a bit more for me, like show me something nice, and show me some charts, like show me where things might be going wrong, like where is somewhere where I need to do something. And so that's where a tool like Streamlit might come in. So just in case you've not seen it, so Streamlit. So this is like a Python application for building, or Python library for building web apps. I first came across it early 2020, which I think is probably, I think they've only been going since the end of 2019, like October 2019 or something like that. And they've got acquired by Snowflake, so now it's Snowflake owned company, but kind of seems pretty much the same to me since they got acquired so far. Kind of still doing their thing. It's
rare, but it's good.
And so far so good. And so the way it works is you can write these. Streamlit. You can write this Python code, and you get this Streamlit import here, and it has a bunch of functions. So you can say, hey, I want the set of table config. I want to write a header to the page. For example, here, I'm running a query, and then I want to write some markdown to the page. I want to write a chart to the page. So one thing that we're doing is we want to see, like, are there more changes happening in the last minute versus the minute before that? And we could change that query, but that's like an easy one to show in a demo. Like, are there any anomalies in what is happening? Like, are people doing anything different? So maybe like a real version of this would be, let's compare it to last week and see, like, this day last week, is there any change based on that? But a simple one is the last couple of minutes. And then we get the result of that, and we run it. We create what they call metrics. So some other tools call this an indicator. You know, I'll show you in a minute what it looks like, but it's basically just showing like a headline number and then a comparison underneath it. So maybe we'll just have a look at it, and then we'll come back to the code. So if we go Streamlit run, Streamlit app v1, and there we go. Oh, so that's what the metrics look like. So we've got one showing the number of changes, one showing the number of unique users who have made the changes, and one showing the number of domains that have been changed. And then underneath it's doing a delta of like 1 to 2 minutes ago. So it's comparing 1 to 2 minutes ago against the last minute. So what it means is that this last one is always going to be on the chart, is always going to be slightly behind because we haven't completed the minute, right? We're like, I don't know what my laptop clock says, but we're probably like 30 seconds through the minute. And so you can kind of see the comparison between them. By default, like if you're building this and you kind of go and make a change, it will automatically refresh it on here. But it doesn't, like, for example, it's not picking up like the changes that are happening while we're just watching the page. So for that, you need to add some extra code around the whole thing to get it to handle that. So that's V2. Let me show you V2. So you can kind of they let you keep session state. So we can kind of keep this session state here, which is keeping track of whether or not we've said we want to automatically refresh the page and how often do we want to do it. And then down the bottom of the page, we can use this code here called the experimental rerun, which will force the whole page to run again. So effectively, the way it works is every time you make a code change, it runs the whole page again. That's the model that it operates with. So let's just have a quick look at V2. There's V2. So that one should now be, well, if we change that, that's now updating every second. And imagine if an operator was looking at this, they might be looking for, hey, is there suddenly like some spam? Like are there lots of like events suddenly happening somewhere? Like it's pretty stable though at the moment. There's not like any big peaks where like maybe some bot is doing something weird. And so let me see, like that's sort of like an intermediate step, and I'll just show you what you could finally end up with. So this is our final version of this dashboard. So we can end up with like this type of thing. We could have the actual changes streaming along underneath. You could style this actually, like if you can convert this into HTML and do some styling on it. Let's just stop the auto refresh for a minute so I can show you the other bit. So we can see who's making the changes. It's kind of weird, like I don't really understand how they define a bot. Because they claim that only 25% of these changes are being done by a bot, but given how many changes are being done in the time that we're talking, it can't be a person typing it. But anyway, so they've got a definition of a bot. You can then see which users have been doing the changes, so you can see, was it QBot, Subot, 1100?
It seems like everyone's name is bot.
Research bot, yeah, these are and then we've got it broken down. These are bots, and then these are apparently no bots, but you can see straight away it's a no bot. It's got the name bot in the name. So it's really interesting like how those are categorized. So we've got like the research bot. It's like, but it's called and classified as not a bot.
Some people do that. They put their username as something bot.
And then we've got the drill downs. This is like a chart showing the same thing that we saw before. So you can see, like from here, you can, like with the actual numbers, you see, okay, it's bigger. It's miles bigger. Like those top three are like, obviously not infinitely bigger, but like they're covering like a massive amount of the changes that are being made. We can see the types of changes. Every time I look at this chart, it has 142. I have no idea what 142 is, but they have some sort of category of change. So edit, categorize, log, new, and 142. And it sneaks out all the time, right? So I don't know what it is. So maybe I need to Google it. Maybe somebody knows. And then finally, we can do it by user. So this would be like the drill down. So this is typically what you'd see on this type of dashboard. So you can see, hey, here's all the aggregates. I've seen them very quickly. I can see, is something going wrong? Do I want to go and see what's going on there? And if I see there's a particular area, like, hey, why on earth is this QBot doing so many changes? I can drill in. And at the moment, we've aggregated them. So it's filtering and aggregating. So saying, hey, show me by domain, what types of changes are they making? And if we wanted, we could also show the actual individual changes themselves. Maybe we could build we could do another line chart and say, hey, show me how many changes is QBot making over time? Like, what on earth are they doing? Why are they changing so many things? So hopefully that's like a good, giving you an idea of what you can do. Probably you're not going to build something on Wikipedia, but you can imagine like putting it on your own data and like trying to figure out. Like the tricky thing with these is that it's very easy to pull in lots of stuff and not make it actionable. Like even a lot of this stuff, maybe there's not really any, like it's quite hard to come up with what can we actually do with it. So in this case, it would be like, is a user going rogue and doing something weird? Like, is there a new user that we can encourage? Like, if you were, for this case, it might be, actually, that might be more interesting. Like, can we find the new users who we've never seen before? Like, is there somebody actually who's just getting into Wikipedia editing that we want to encourage to do something? So depending on the type of data that we have, we've got to work back from, hey, what do we actually want to do? Like, what are we trying to encourage people to do? In Uber's case, it was, well, let's help you run your business like more effectively. In LinkedIn's case, it was, let's show people stuff that they will feel good about and then hopefully like interact with, or it's feel good stories, like make everyone feel good about like the great thing that I did and boast about that. Could be that as well. And then I guess with Stripe it was can we process the financial information more effectively? So
nice
demo. Like there's our relief.
That's how Mark feels right now.
It worked.
We were debating which emoji to put here.
Very important talk preparation.
This was actually like part of the biggest back and forth. We went through multiple.
Disapproved of my other choice of the sweat emoji guy.
Yeah, the sweat emoji. I think this one makes more sense.
So I just want to just to conclude. We've got about 10 minutes, 15 minutes, 10 minutes. 12 minutes. All right, we're doing well. So just to quickly show you how does Pinot store its data. So. We kind of said that it's splitting up like partitions into segments that are going on different servers. So for example, we've got like partition 1 is on server 1, partition 3, and partition 2, and partition 4. But then within those partitions, it's then breaking it up into smaller segments. So for example, we would have like multiple segments capturing that one partition of data coming in. Actually, it might be more interesting to look at it on this dashboard. So if you go into a table and you click on it, and then if you scroll down, so you can see here, like the way that this is named, it goes, wiki events is the name of the table, 0 is the name of the partition, and then the next 0. So _0, partition number, and then the next one is like an incremental count of the segment. So these are all from, so 00 is the first one from partition 1, 0 to 10, 0, 2, 0, 2. I think we've actually only got 1. So if you had 8 partitions, you'd go wiki events 0, wiki events 1, and then it would kind of increment on top of that. And so you end up, let's click on one of them. It gives you a bunch of metadata. So it says, hey, we started at the offset, it should be 0, right? Yes, it started at Kafka offset 0. It shows you where you can go and download that segment if you wanted to. It tells us what was the end time when that happened and what was the end offset. And then we can, that's like one that's already been committed. And if we pick like the one with the highest number, so what are we up to, 24? This one is in progress still. So this one started at the offset number 24,000 in Kafka. And in this case, it will stop when it gets to 25,000. But it's using like a threshold size of 1,000, but it's kind of got, that's probably interesting enough for now. But that's how it goes about storing the data. And then when you're querying, it can look at the timestamps to see, oh, well, you're actually asking for data after this timestamp. So for example, if we said, show me the data from the last 2 minutes, it knows, oh, well, actually, the data in that partition is not interesting to me. I can just exclude it. And so that would be one of the optimizations. So how does the data get stored inside these segments? So the segment is kind of like a big file. Like it's a big file of data being stored. So there's a bunch of metadata, and then it has the entire column of data for one column, then the next one, then the next one, and then it's kind of doing compression and stuff within that. So by default, it will literally be every column. So country, it will go US, or US, CA, JP, US, CA. I'll just keep on storing it. Normally a fixed size, all the way down. And then it'll be browser, then it'll be whatever is after browser. We can introduce indexes. So by default, everything has. It's weird, but this is referred to as a forward index, but it's not really indexed. It's just storing stuff as a column, which gives you some benefits, right? Like if your thing is, hey, I want to sum some values, that's quite a good format, like because it can just sequentially scan through all that column and just sum it up, rather than if it was stored as a row, I've got to go and do a lookup, get that particular bit of data, get that bit, get that. So it kind of gives you some optimization to start with, but not as much as what you would expect if you were doing filter queries, like putting wheres in your clauses in your queries. So there are most of the stuff that you would expect to be there by standard. So you can do range queries, you can do null checks, you can use a Bloom filter for doing equality predicates. There's text search, and then. We'll kind of go through them, and then the last one is there's a star tree index, which is where the company name comes from. We'll talk about that. So that's kind of doing like a tunable pre-aggregation. So just to quickly recap, inverted index is where, hey, I want to look up a value, and I don't want to scan through every single value that you have in this table and check, is this one US, is this one US, is this one US? So what we're going to do instead is we're going to have this almost like optimization, where it's still going to store the data in another format, where in this case I'm going to have each of the things that you might look up, all the values for countries, so US, Canada, Japan, and then I'm going to store like the document IDs or the row IDs next to it, and they'll all be in the compressed format. It's not storing them literally as numbers. And then when you say, hey, I want to go find me I want to do a count of from my table where country equals US, it's like, cool, I can just go and look at the doc IDs and see how many there are. I don't need to go and scan it all the way through. Sorted index is done automatically, so when the data is being processed, you can tell it, I want this one explicitly to be sorted, but it will also sort automatically. We'll go and have a look, like when it flushes that segment, it has a look, hey, which things in here are sorted, and it will then go and add a sorted index. And what that means is that instead of storing it like in that initial format with everything sequentially, it'll store it like this. It'll say, hey, I've got this country, and I know that from position 0 to position 80, everything is US. From position 81, or CA. CA is what? Canada. Must be Canada.
Yeah, that makes sense.
JP, everything from 81 to 100 is JP. And then if you look up JP, it's like, well, I don't need to bother. I can just ignore everything else. I just go and look at those particular ones. All right, and then finally the star tree index. So the idea here is that we're falling somewhere between indexing on the top, where we're not taking up that much space, but we have maybe a bit higher latency, all the way down to the bottom side, where we're like pre-aggregate everything, but it takes up loads of space, and then but is then quicker to query. So the idea with the star tree index is that you can say how much pre-aggregation you want to do. So you can kind of fit it on this imaginary curve that we've got here. So you can specify which columns or which combinations of columns would you like it to pre-aggregate, and then on top of that you can say how much do you want it to pre-aggregate. So it will like do it down to a level. So you specify, hey, like the most rows I want to query is, for example, 10,000. And so then you kind of, it might not be as far, like, so then it will go, okay, well I'll figure out a way to build myself an aggregation tree so that you're never querying more than 10,000 rows in your query. So it might not be as fast as what you could get if you absolutely pre-aggregated everything using like a cube, but you're kind of restricting the latency while not taking up insane amounts of space. And you're choosing, hey, I know that everybody's going to be searching by country and browser, but they're going to infrequently do device. So if they do device, I'm happy for it to be a bit slower. And then finally, in terms of how this is working under the hood, there are optimizations across, like all the way down. So like the way the data is stored, the way the filtering works, the way that it actually processes the data in the first place, and then the way the query engine picks up, like it goes, oh, I don't need to even look at that segment. So there are lots of techniques. Some of them are common across, like it's not like everything is being invented from scratch, and some things are very, very similar across any column store, and then some things have been like specifically been written in this database. So I'll let Kareem.
Yes, so I don't really need to read you the slide. Basically, for any like user-facing real-time analytics use case, this combination of some type of streaming system, and you can also include batch in there too if you'd want, and Apache Pinot is a really powerful combination to do user-facing real-time analytics. And in terms of like the growth and adoption, we have to update this slide. We have over 3,000 Slack users now, and I think it's grown. It grows very fast, so we have to like update these slides like pretty regularly. In terms of like the growth and the power of Apache Pinot, in terms of like the largest cluster, it was ingesting over 1 million events per second. With a query per second of like 200, I think it was like maybe 250,000 queries per second, while still maintaining millisecond latency, which is quite powerful. You can go to pinot.apache.org. You can also go to dev.startree.ai. We have that on the last slide. Okay. So here are the takeaways. Do you want to run these, or do you want to?
Yeah, sure. Yeah. So things to hopefully that we've covered in the talk. So the whole point of building a system like this is that we want to provide our users with some like data so that they can use it to do something, whatever that is, something useful for them. So hey, I want to interact with this more, I want to make my business run better, I want to make Wikipedia better, in our example. And then the properties of whatever you build, it needs to be, the data needs to come in quickly, we need to be able to query it quickly so that from the time the data actually, that the event happened to when we're able to use it is very, very minimal. Like we don't want it to be a big gap. And then at scale means either lots of users can do it, or maybe fewer users, but doing lots of queries at the same time. So either way, lots of queries are coming in. And then Kafka and Pinot is a pretty good combination for achieving that. And then...
so you can go to dev.startree.ai if you have questions too. We also have a Slack. That's the Slack QR code. We should also talk about the Real-Time Analytics Summit.
I mean, if you want to do feedback, we were told, there's a QR code on here.
Yeah, you want to tell people?
We didn't know how to get it from here onto here. Apparently some other clever speakers did it. We're not that clever.
We're not that clever. We couldn't figure out the emoji to use after the post demo. We also are I feel like I should mention this. We didn't put this on the slide, but we have a virtual summit coming up. It's free. It's RTA Summit. It's Real-Time Analytics Summit. .com. It's free if you want to register. It's like later this month.
There you go.
Yeah. Cinematic virtual event.
And you got to say the right date.
I know. Oh my God. I was doing. I did a presentation for DevOps Ukraine like literally 15 minutes before this presentation started, and I told them the wrong date. So I was like,
told everyone to come on the 29th of September. Where is it? So yeah, this is all online. I don't know. Do we have this?
Yeah, it's
so I can show them what.
It's RTA Summit. RTASummit.com.
Yeah, so there's is this the first day? Yeah, so
there's 2 days. There's September 28th and there's like November 14th or 15th. Oh my God, I'm going to say the wrong date.
Don't trust
Just go on rtasummit.com.
So you can kind of see, like, there's some, like, they sort of, like, if you imagine this is more of like a intro talk to these technology, the stuff that people will be doing here will be more like, hey, how I'm using it on a real thing. So someone from Etsy doing a talk.
Yeah, so the presentation we just gave that I gave the wrong event, I did the presentation with Mary for the DevOps Ukraine, and that's what she said the right date. I said the wrong date. I was like, I actually work for the company who's producing this event.
Good job.
Thanks. I mean,
you're not doing a great job of self-promotion in this talk.
I mean, no, we're doing it's fine.
So this one is about using like Pulsar for these type of systems. So Pulsar is another event streaming engine.
I'm going to tell you something. All these people are going to remember the date now for like years from now. They're going to be like the 28th of September. They're going to be like, that was the date of the Real-Time Analytics Summit.
Yeah. RTASummit.com.
Yeah.
There you go.
Yes.
Cool. And thanks for coming along. And I guess this is the last talk, so now we're going to go for the raffle.
Yes.
Good luck to everyone in the raffle. Cool. Thank you.
Cool. It's really funny.